Welcome to the next course in database engineering. The focus of this course is on advanced MySQL topics. Let's take a moment to review some of the new skills that you'll develop in these modules. In the first module of this course, you'll learn how to create and work with functions, along with both basic and complex stored procedures in MySQL. This is so you can reuse or invoke code blocks to perform specific operations. You'll then learn how to make use of variables and parameters to create more complex stored functions and procedures in MySQL. You'll also learn how to develop user-defined functions for when MySQL's built-in functions don't meet the needs of your project. In the next lesson, you'll make use of MySQL triggers to automate database tasks. You'll explore different types of MySQL triggers like insert, update, and delete. And you'll learn how to make use of each type. You'll also develop an understanding of how you can make use of scheduled events to ensure that your database tasks and events are completed at specific times. The next module focuses on core rules and guidelines for database optimization. In this module, you'll develop an understanding of the concept of database optimization and the advantages it brings to a MySQL database. You'll review techniques for optimizing database select statements so that they're executed quickly and efficiently. For example, targeting required columns or avoiding the use of complex functions. You'll also learn how to work with indexes in MySQL to speed up the performance of data retrieval queries. In the next lesson, you'll be exploring further optimization techniques. You'll start by learning how to use MySQL transaction statements to manage database transactions. You'll discover how you can use common table expressions to manage complex SQL queries by compiling them into single blocks of code. You'll learn how to make use of prepared statements to limit the number of times MySQL must compile and parse code. And you'll discover how to interact with a MySQL database using the JSON data type. In the third module, you'll explore the concept of data analytics in MySQL. First, you'll develop an understanding of the relationship between database analytics and MySQL. You'll discover how to make use of data collected during data analysis by converting it into useful information that can inform future decisions. You'll also explore the different types of data analysis that can be performed within a database. You'll then move on to learn about the relationship between MySQL and data analysis, including the benefits and limitations of MySQL as a data analytics tool. In the second lesson of this module, you'll learn how to perform data analysis in MySQL using SQL queries like joins, subqueries, and views. You'll then explore how to emulate a full outer join in MySQL to extract all records from two tables, including those that don't match. And finally, you'll learn how to extract data from multiple tables using the join method. During these modules, you'll encounter numerous activities designed to test your skills and knowledge. These include lab exercises, knowledge checks, and module quizzes. And in the final module, you'll receive the opportunity to demonstrate some of this learning along with your practical database skill set in the lab project. And you'll also demonstrate your knowledge of these topics in a graded assessment. So, let's get started. In the previous courses, you learned that you could reuse code within your database projects with the use of functions and stored procedures. These methods save you from having to repeatedly type the same code. Over the next few minutes, you'll recap the basics of functions and stored procedures, and you'll also learn about their benefits and key differences. As you might recall, Lucky Shrub frequently make use of these methods to query stock data in the products table of their database. This means that they don't have to repeatedly type the same code each time they check their stock. Over the next few minutes, you'll take a closer look at how they achieve this. So, as you've just learned, the main purpose of creating stored procedures and functions is to wrap or encapsulate code together in the body of a function or procedure. This means that instead of typing the same code repeatedly, you can call a code block to perform a specific operation by invoking the identifier name. But there are other benefits to functions and stored procedures. They make code more consistent and more organized and introduce reusability to make the code easier to use and maintain. Let's look at a few examples of these concepts to find out more. As you just saw a moment ago, Lucky Shrub make use of procedures when checking their stock. First, they create the query as a stored procedure using the create procedure command, followed by the name of the procedure and the required logic. They then invoke this procedure using the call command to extract the required data from the database. If there's no data in the table, then function returns a null value. Let's look at an example of a function. The mod function can be used to find the remainder of the division of two numeric values, x and y. For example, 7 divided by 5. To find the result, invoke the function by using the identifier name within a select statement. In this instance, the result is 2. Remember that unlike stored procedures, a function always returns a value. For example, you might recall the scenario from the last course in which M&G used a function to determine the average dollar amount each client spent with their business. This function always returns a value because it specifically targets clients that spent money. Let's take a few moments to explore a key difference between functions and stored procedures: parameters. Functions can only have input parameters, while stored procedures can have both input and output parameters. Both functions and procedures can accept values within their respective code. In other words, they both accept an input. But only procedures can pass values back out again with the use of output parameters. Don't worry if you find this concept confusing. You'll learn more about parameters in later videos. You can create as many functions and procedures as you need. Just make sure you know when to use one over the other. For example, functions are best when you need to return one specific value, like in a SQL statement or within another function. Stored procedures are mostly for processing, manipulating, and modifying data. So, as you've just learned, functions and procedures are an effective way of reusing code to complete repetitive tasks. And even though they may bring many benefits, it's important to know when to use one over the other. In this course, you'll explore these concepts in more depth. You might already be familiar with basic stored procedures and functions from earlier courses. However, MySQL also offers more complex stored procedures and functions, which rely on variables and parameters. Over the next few minutes, you'll learn how to use variables and parameters to build sophisticated functions and procedures. Lucky Shrub Gardening Centre have several repetitive but complex queries they need to create for their database. They can create these queries using variables and parameters. Let's follow their process and find out how it works. First, you need to know what the term variable means in the context of MySQL. A variable represents a placeholder that stores a value. This value may change at times depending on the needs of the query. Basically, variables are used to pass values between SQL statements or between a procedure and a SQL statement. There are two different ways in which variables can be used in MySQL. You can create variables inside or outside of a stored procedure, and inside or outside of a select statement. So what does a variable look like? In MySQL, a user-defined variable is created from alphanumeric characters. You just type the @ symbol followed by the name that you want to call your variable. Then assign a value to your variable using an equal to operator. Make sure that you end your syntax with a semicolon. But how do you create a variable inside or outside of a stored procedure? To do this, you need to use the set command within your syntax. The set command is used to assign a value to a variable within a stored procedure. Let's take a moment to see what the set command looks like in practice. When creating a variable inside or outside of a stored procedure, type the set command followed by the name of the variable. Then assign a value to the variable. For example, Lucky Shrub have an orders table in their database that records orders placed with the business. They can create and use a variable called order ID to target the record with the order ID number of 3. They can now use this variable to delete, update, or query the record. Or you can create a variable inside a stored procedure using the declare command. In this instance, you type the variable name without an @ sign. Then you assign the variable a relevant data type and default value. Lucky Shrub can use this method to create a variable called minimum order cost. The expectation is that this variable stores a value equal to the cost of the minimum order in Lucky Shrub's database. As you learned earlier, you could also create a variable inside a select statement. However, when assigning a value to a variable in a select statement, you need to use the assignment operator syntax. This instructs MySQL to assign a value to the variable. A standard equals operator just checks that one value equals another. So type a select command and then the name of your variable. Then assign a value to your variable using the assignment operator. For example, Lucky Shrub can create a max order variable that retrieves the most expensive order from their orders table. They can then access the value by typing select max order. The output shows the most expensive order. It's also possible to create a variable inside of a select statement and assign it a value returned from a function. You just type the select command followed by the function, then the into keyword and the variable name. Finally, type the from keyword and the name of the table the value must be extracted from. Lucky Shrub can use this method to create a variable called average cost, which returns the average cost of items from their orders table. Now that you're familiar with variables, let's move on and explore the topic of parameters. A parameter is used to pass arguments or values to a function or procedure from the outside. In MySQL, a function only takes input parameters, but there are 3 different types of parameters that can be declared in stored procedures: in, out, and in-out parameters. Let's take a few moments to explore how each of these works. The in parameter is the default parameter. It's used to pass an argument or value to a stored procedure. To use this parameter, type the create procedure command and your procedure name. Type the in keyword in a pair of parentheses. If you don't specify a keyword, then MySQL uses in by default. Then, within your parentheses, add another pair of parentheses with your parameter names. Then add a select statement that outlines the logic of your query. For example, Lucky Shrub can create a procedure that calculates 20% of each employee's salary for tax purposes. They can then call the procedure against a specific salary value. This passes the salary to the procedure and returns the amount due in tax. Next, let's investigate the out parameter. The out parameter is used to pass a value to a variable outside of the procedure. Here's an example where Lucky Shrub use a procedure called getLowestCost to identify the order with the lowest cost in their orders table. They use the out keyword to pass the value outside the parameter. So the next step is to call the procedure. The value of the procedure can then be stored in the form of a variable within a pair of parentheses. To display the variable's stored value, just use a select statement to return the output. Finally, there's the in-out parameter. This is a combination of both parameters. It's used to pass an argument to the procedure and then pass the new value back to the outside. So it's effectively an in and an out parameter. For example, you could create a procedure called square a number that returns the squared value of a specific number using the in-out keyword and a number variable. The procedure expects an input number through the number parameter. It multiplies this number by itself, then returns the result to the same number parameter again. Then you can set a variable called x number with a value of 5. Call the procedure using the x number variable value. The procedure passes the value through the parameter. It then performs the calculation and returns the result back through the parameter. Use a select statement to output the variable value. You should now be familiar with how to create more complex stored procedures and functions using variables and parameters. Great work. You might already be familiar with MySQL's built-in functions, but what if none of these built-in functions meet your project's needs? No problem. You can develop your own user-defined functions. In this video, you'll find out what user-defined functions are and learn how to create your own. Lucky Shrub are having a sale in which they're offering a 10% discount on selected products. But rewriting the same statement for every product during every transaction would be very time-consuming. Instead, Lucky Shrub need you to create a user-defined function that they can invoke when needed to calculate these discounts. Before you begin helping Lucky Shrub, let's make sure you understand what database engineers mean by the term user-defined functions. You might already be familiar with built-in MySQL functions like string or numeric functions. User-defined functions are created to perform operations that can't be completed with built-in functions. Users develop code that implements equations or formulas to complete a task and return a result. Let's break this process down. A database engineer creates their own code. The code carries out a specific function, and the function then returns the required result. To build a function in MySQL, you can use the create function command alongside the returns clause and the return command. These commands and clauses specify the data type and values to be returned by the function. Let's find out how this syntax works. Begin your statement with the create function command. Then assign a name to your function. Follow the function name with parentheses and parameters. The parentheses are mandatory, but you don't always need to include parameters. Next, specify the return data type, followed by the keyword deterministic. Deterministic means that the function always returns the same result for the same input parameters. For example, if a sum function is defined as deterministic, then it always returns the same result for the numbers it adds together. Finally, you can implement the logic with a return keyword. Let's look at how Lucky Shrub can make use of a user-defined function. Lucky Shrub can use this syntax to create a function called findTotalCost. A cost parameter with a decimal data type passes a user input value of cost, and the returns clause defines the function's return type as a decimal number with 5 digits. Finally, the return command calculates and returns the final cost after deducting 10%. So each time Lucky Shrub needs to determine the sale price of their items, they just invoke the function in a select statement, followed by the current price in parentheses. But what if you want to develop a more sophisticated function? For example, Lucky Shrub want to offer a 10% discount to customers who make purchases of $100 or more, and a discount of 20% on purchases of $500 or more. The first step is to use the delimiter command to compile the whole function as a single compound statement using begin-end keywords. Then click Enter to change the delimiter from the default semicolon to a double forward slash. Next, use the create function command and name your function getTotalCost. Include a cost parameter with a decimal data type that passes a user input value of cost. The returns clause defines the function's return type as a decimal number with 5 digits, and the return command calculates the final cost after the discount has been deducted. The function is also defined as deterministic so that it always returns the same result for the same input parameters. The next step is to use the begin and end keywords to determine the body of the function. Use an if-else statement to check the input cost and deduct the appropriate amount. Then add the return command to calculate the final cost once the discount has been deducted. Finally, click Enter to create the new function. Then change the delimiter to the default semicolon so you can use MySQL as usual. Now it's time to test the function using a select statement. A customer has just made a purchase that cost $500, so Lucky Shrub need to determine the discount to be applied. Type a select command followed by the name of the function alongside the purchase value in parentheses. Then click Enter to execute the function. The output result is 400, so this customer's purchase now costs $400 following a 20% discount. If you want to drop the function, just use the drop function statement followed by the function's name. Click Enter to drop the function. Lucky Shrub can now apply discounts to their customers' purchases as required. And you now know how to create your own user-defined functions in MySQL for your own specific projects. Great work. You should already be familiar with the process for creating basic stored procedures. So in this video, you'll learn how to create more complex stored procedures that require multiple statements. You can learn how these procedures work by helping Lucky Shrub. Lucky Shrub need to determine the current cost of each of their products ahead of their upcoming sale. They must identify all products that cost less than $50 so they can add an appropriate discount. And they need to identify all products that cost more than $50 for further discounts. The required data is stored in the products table in their database. You can help them to complete this task using a complex stored procedure. First, you need to use a delimiter command so that MySQL can compile the code in a begin-end block as one compound statement. Type the delimiter command to change the delimiter from the default semicolon to a double forward slash. Click Enter to apply the changes. Next, type the create procedure command. Then type the procedure name getProductSummary. Add a pair of parentheses and include 2 out parameters along with relevant variables. These parameters output the low price products and high price products outside of the procedure. They also store the output values in the variables. Next, you need to create the body of the procedure. Implement the logic within the begin and end keywords. The logic consists of two select statements followed by a count command that targets the product ID column within the products table. The first statement returns the ID of all products that cost less than $50. The second statement returns all products that cost more than $50. A double forward slash indicates the end of the query. Click Enter to create the procedure. Finally, change the delimiter to the default semicolon again so that you can keep using MySQL as usual. Now it's time to execute the procedure. Type the call command followed by the name of the procedure. Then, in a pair of parentheses, create the two required variables. You can call the first variable total number of low-price products and the second variable total number of high-price products. These variables hold the output results from the out parameters. Click Enter to execute the call statement. The procedure retrieves data from the table and passes it to each variable. Now you just need to access the data using a select statement. Type the select command followed by the two variable names. Make sure the names are separated by a comma. Click Enter to execute the statements. The output result shows the total number of low and high-priced products. Lucky Shrub now have all the data they require for their sale, thanks to your stored procedure. Good work. As a database engineer, you'll often need certain actions to occur automatically when specific events take place, like when data is inserted, updated, or deleted from a table. But how can you make sure that these actions happen automatically and avoid the need to rewrite code each time they must be invoked? You can do this with the use of MySQL triggers. In this video, you'll learn what a MySQL trigger is and how to code and use them. Lucky Shrub's sales team are adding discounts to products. However, any discounts over 25% must be reviewed by a manager. This means that the sales team needs to add a trigger to the database that flags items when they're assigned a discount above the 25% threshold. Let's explore MySQL triggers and find out how Lucky Shrub can use them to complete this task. The first question to answer is, what's a MySQL trigger? A MySQL trigger is a set of actions available in the form of a stored program. These set of actions are invoked automatically when certain events occur. Examples of these events include inserting, updating, and deleting data from a table in a MySQL database. However, before you can use a trigger, you need to create it. And you'll also often need to drop or delete a trigger once it's served its purpose. Let's take a moment to explore the syntax for creating and dropping triggers. A trigger is created using the create trigger statement. To create the trigger, type the create trigger statement followed by the name of your trigger. Because a trigger is often user-defined, you can create a custom name. However, make sure that each trigger's name is unique within the database. Then define a trigger type. For example, is it an insert, update, or delete trigger? And should it execute before or after? Don't worry about this for now. You'll explore trigger types in a later video. Next, specify which table the trigger must be assigned to and identify how it should be applied to the table. Next, you need to define the trigger's logic. In other words, specify what it is that the trigger must achieve. The trigger can insert, update, or delete data. It can even combine these actions as required. If it requires multiple statements, then these must be enclosed within a begin-end block. Then execute the statement to create the trigger. Again, this part of the syntax isn't a concern at this stage in the lesson. You'll review different types of triggers and what they can achieve in a later video. To drop or delete a trigger that you've created, you can use the drop trigger command. To use this command, just write drop trigger. Then add the if exists clause. This clause makes sure that the drop command only works if MySQL can locate the trigger within the database. If you try to drop a non-existent trigger without this clause, then MySQL returns an error. Next, identify the schema that the trigger belongs to using dot notation to identify both the schema and trigger names. This makes sure that MySQL only deletes the trigger from the specified schema and not the entire database. Finally, type the name of your trigger. Then execute the statement to drop the trigger. It's also important to remember that if you drop or delete a table from your database, then MySQL automatically removes all triggers associated with that table. So, how can Lucky Shrub's sales team make use of these methods? As you learned earlier, the team need to add a trigger to their database that flags when employees attempt to add a discount of more than 25% to an item. An approval request must then be sent to a manager for any flagged items. Lucky Shrub can use create trigger commands to create this trigger. They can name the trigger approval request. They then assign a trigger type of after update so that the trigger executes the logic after an update operation has occurred within the table. Finally, they place the trigger logic within a begin-end block. Finally, let's look at a few more benefits of triggers. Triggers are useful for keeping a log of records or changes made within a database. It's basically a way of maintaining audit trails where a record is inserted into the database each time a change is made. Triggers are also an alternative to constraints. They can be a useful way to help maintain data integrity by making sure all data is updated as required. They're also useful for performing tasks automatically on specified actions on a database table. You should now know what a MySQL trigger is and understand the basics of how to create and drop them within a database. As you might know by now, a MySQL trigger is a set of actions that can be invoked automatically when certain events occur. But how do you determine when and how these triggers are executed? Well, you can control the behavior of your triggers by using different types. Over the next few minutes, you'll explore the different types of triggers available and learn when to use them. Lucky Shrub are rebuilding their orders table, which records orders within their database. They need to assign a new set of constraints or rules on this table. Maybe they can create these rules using triggers. Let's find out which types of triggers Lucky Shrub can make use of and in what order these triggers should occur. First, let's explore the two main types of triggers defined in SQL: row-level triggers and statement-level triggers. A row-level SQL trigger is invoked for every row inserted, updated, or deleted in a table. So if 100 rows are added to a table, then the row-level trigger is invoked 100 times. A statement-level trigger, on the other hand, is invoked once for each action, and it occurs just once no matter how many rows are inserted, updated, or deleted. So a single insert statement could add 100 rows to a table, but it only activates once for all 100 rows. It's important to be aware of both types of triggers. However, MySQL only supports row-level triggers, so they'll be the focus of this lesson. As you learned earlier, triggers are typically used to perform three types of actions: insert data into a table, update data in a table, and delete data from a table. But how can you determine when an insert, update, or delete trigger occurs? Well, depending on when a trigger is actioned, it can be classified as either a before or after trigger. Let's find out what this means. The before keyword or modifier indicates that a trigger must be invoked before any action is performed on a table row, while after indicates that the trigger is invoked after the action is performed on each row. By combining these modifiers with the insert, update, and delete keywords, you can create different types of triggers. For example, the before insert trigger is automatically invoked before an insert event occurs on a table, while after insert is invoked after an insert event. Similarly, a before update trigger is invoked before an update event occurs, and an after update trigger is invoked after the event. Finally, before delete triggers are invoked before data is deleted in a table, and after delete triggers are invoked after data is deleted. In each instance, the syntax is largely the same for each type of trigger. Begin with a create trigger command, followed by the name of your trigger. Next, add the modifier and keyword to determine when your trigger must occur and on what action it must take place. For example, before insert instructs MySQL to invoke the trigger before an insert event occurs on the table. Then type the on keyword and the name of the table. This is followed by the for each row keyword. This instructs MySQL to carry out the action for each row in the table. Finally, type the logic of the trigger. As you might recall, this is usually typed within a begin-end block, particularly if you need to specify multiple statements. Let's look to Lucky Shrub for an example. They want to impose a new constraint on their orders table. This new rule must state that no minus values can be inserted in the table's order quantity field. So Lucky Shrub can begin with the create trigger command. They can then name the trigger order quantity check. Next, they add the modifier and keyword before insert. Then they assign the trigger to the Orders tab and make sure it applies to each row. Finally, they create the trigger logic within begin and end statements. The logic states that if the table encounters an order with a value of less than 0, then it must set the value to 0 by default. Now, each time a new row is inserted into the table, the before insert trigger carries out the required action before it inserts a new value. Let's take a moment to explore some more types of triggers that Lucky Shrub can use. Lucky Shrub want to maintain an audit trail of all updates made to their orders table. With an after insert trigger, they can send a log message from the orders table to the audits table each time a new order is inserted. The company also needs to create a log that captures the date and time an order record is deleted from the orders table. They can use an after delete trigger for this task. After a record is deleted, the trigger inserts a record in the log with the date and time. These are just a few examples of how the different types of triggers work in MySQL. You'll explore them all in more detail later in this course, but for now, you should be familiar with the different types of triggers available and know how to create them. Good work. At this stage of the lesson, you should be familiar with MySQL triggers and the different types of triggers available to database engineers. Now let's take a few moments to find out how you can create and drop these triggers into your databases. To help you understand these concepts, let's look at how they're used in Lucky Shrub. Lucky Shrub's database contains an orders table with several columns that record information on each order placed with the business. Lucky Shrub want to make sure that no minus values are inserted in the table's quantity column when a new order is recorded. Any minus values that the table encounters must be set to a default value of 0. They can complete this task using a before insert trigger. The trigger syntax begins with a create trigger command. This is then followed by the name of the trigger, which is order quantity check. Always make sure that the trigger name is unique within the database. Next, assign the trigger type and specify when it must be invoked. In this instance, it's before insert. In other words, it's invoked before an insert command. Then type the on keyword followed by the table name. This lets MySQL know which table to target. You'll also need to type for each row so that MySQL targets each row within the table. Finally, write the trigger's main logic. This must be a series of one or more SQL statements that execute when the trigger activates. If you have multiple statements, then enclose them within a begin-end block. The trigger's logic checks if a minus value is about to be inserted into the quantity column. This action requires an if statement so that it can access the quantity column. To create this if statement, you need to use one of two modifiers, new and old. New suits our purposes here as it targets the value of a column after the operation. In other words, the value to be inserted. If you needed to access the column value before the operation, you'd use the old modifier. So type a statement that says if the new order quantity value is less than 0, then set the new value to 0. Don't worry if you don't quite understand these modifiers. They're covered in more detail later in this lesson. Now let's find out how to run our trigger. Before running this trigger, make sure you redefine the MySQL delimiter semicolon to a double /. Then execute the trigger. Once executed, change the delimiter back to a semicolon. Lucky Shrub now have the required trigger in their orders table. Lucky Shrub now need to delete this trigger from the table. You can delete or drop the trigger using the drop trigger statement. Type drop trigger. Then type the if exists condition to prevent MySQL from returning an error. Next, provide both the schema name and the trigger name using dot notation. The schema name is optional, but still recommended. It helps MySQL target the correct trigger. And don't forget that if you drop the orders table, then all related triggers are also deleted. You've now helped Lucky Shrub to create and drop the required trigger from their database. And you should now be familiar with how to create and drop triggers from your own databases. Great work! When working with MySQL databases, there'll often be tasks or events that must be completed at specific times, like inserting data or generating reports. With MySQL scheduled events, you can make sure that these events occur at the scheduled time, even if you're not present. In this video, you'll learn what a MySQL event is, review the syntax used to create events, and explore some examples. Lucky Shrub often make use of MySQL scheduled events. For example, the finance department has just requested a report on all orders received this month. However, this report must be generated at 11:59 p.m. on the last day of the month. Lucky Shrub can use a one-time event to create this report. They can schedule their MySQL database to generate the report at the specified time and date. Before you find out how Lucky Shrub can create this event, let's first find out more about what a MySQL scheduled event is. A scheduled event in MySQL is a task executed according to a given schedule. In other words, it's an event that takes place at a specified time. Each event has a unique name and contains one or more SQL statements. They're stored in the database and can be executed just once, or they can be a recurring event. The main types of scheduled events that you'll work with in MySQL include one-time events and recurring events. One-time events are scheduled events that occur just once, for example, inserting data into a table 1 hour from now. And a recurring event is a scheduled event that occurs on a regular basis, like generating a weekly report from a database. So, how do you create a MySQL scheduled event? Events are created in MySQL using the create event keywords. Let's find out more about how this syntax works. First, create the event using the create event keywords. You can follow these keywords with if not exists. This tells MySQL to create the event only if it doesn't already exist. Then follow these keywords with a unique event name. Next, type the onSchedule keywords and specify a scheduled time at which the event must occur. Then type the do keyword. This keyword is followed by the event body in which you specify the logic of the event using SQL statements. So, how can you use this syntax to differentiate between one-time and recurring events? If your scheduled event is a one-time event, then specify the schedule using the @ clause. This is followed by a timestamp, an interval keyword, and a specific time at which the event must be executed. For example, Lucky Shrub can use this syntax to generate a one-off revenue report 12 hours from now. And they can create their event logic within a begin-end clause. Creating a recurring event is more complicated. The syntax is largely the same. The key difference is that you must use the every clause instead of @ followed by an interval. You can also use the starts and ends keywords with the timestamps and intervals to designate specific start and end points for the event. Lucky Shrub can use the recurring event syntax to create a daily stock check event. If the event identifies that some stock levels are too low, it sends out an order to restock those items. You'll find out more about how Lucky Shrub can create this and the previous event in just a moment. Before then, let's look at how to delete or remove an existing MySQL event that's no longer needed using a drop event statement. First, type the drop event keywords. It's also good practice to include if exists. This tells MySQL to check if the event still exists and hasn't already been dropped from the database. Finally, type the event's name and then execute the statement. Now that you're familiar with scheduled events and their syntax, let's see if you can help Lucky Shrub generate that report. As you saw earlier, Lucky Shrub's finance department has just requested a report on all orders received this month. They need the report generated at 11:59 p.m. on the last day of the month. However, it's now the last day of the month and it's also approaching 12 noon. So they need the report 12 hours from now. This is a one-off event. So begin with the create event keywords. Then assign the event a unique name. Let's use generate revenue report. Now you need to specify the schedule. Since this is a one-time event, use the @ clause. Then schedule the event to occur 12 hours from now. So include the current timestamp and add a 12-hour interval. The next step is to add the schedule's logic. Type the do keyword and a begin and end block. Within this block, instruct MySQL to select all data inserted into the orders table this month and to place that data within a report data table. Great! 12 hours from now, the finance department will have their report. Lucky Shrub need your help with another task. They're reviewing their stock and need to make sure that they have at least 50 units available for each item on sale. You can help them by using a recurring event. First, create the event and call it Daily Restock. Then specify the schedule. As this is a recurring event, use the every clause and schedule it to occur once a day. Next, add the do keyword followed by a begin and end block. Within this block, define the event's logic. MySQL must check if the number of items for any record in the products table is below 50. If MySQL locates a record below 50, then the number of items must be updated. If at any stage you need to remove this event, just type the drop event keywords, then if exists, followed by the event name. Great work! You've helped Lucky Shrub to create these events in their database. You should now be familiar with the basics of MySQL scheduled events, include different types of events and their syntax. Well done! Congratulations! You've reached the end of the first module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you received an introduction to the course in which you learned about the role of an advanced database engineer in Meta, discussed what you hope to learn with your classmates, received an overview of the topics that you'll cover in this course, and you enhanced your knowledge by reviewing some key additional resources. In Lesson 2, you learned about advanced MySQL functions and stored procedures. You learned that the main purpose of creating stored procedures and functions is to wrap or encapsulate code together in the body of a function or procedure. The benefits of stored procedures and functions is that they make code more consistent, more organized, and introduce reusability to make the code easier to use and maintain. And you also know that the key difference between functions and stored procedures is parameters. Functions can only have input parameters, while stored procedures can have both input and output parameters. You then learned how to make use of variables and parameters to create more complex stored functions and procedures in MySQL. You learned that variables are used to pass values between SQL statements or between a procedure and a SQL statement. You can create variables inside or outside of a stored procedure, and inside or outside of a select statement. You learned that a parameter is used to pass arguments or values to a function or procedure from the outside, and that there are 3 different types of parameters that can be declared in stored procedures: in, out, and in-out parameters. You also learned how to develop user-defined functions for when MySQL's built-in functions don't meet the needs of your project. A database engineer creates their own code. The code carries out a specific function, and the function then returns the required result. In Lesson 3, you explored MySQL triggers and events. You discovered that a MySQL trigger is a set of actions available in the form of a stored program. These set of actions are invoked automatically when certain events occur. Examples of these events include inserting, updating, and deleting data from a table in a MySQL database. The 2 main types of triggers used to manage SQL events include row-level triggers and statement-level triggers. Next, you discovered how to create and drop these triggers in MySQL. You can now create a trigger using the create trigger statement and drop or delete a trigger using the drop trigger command. You also reviewed other aspects of the syntax used to create a MySQL trigger. This includes defining the trigger name and type and specifying the logic by enclosing multiple statements within a begin-end block. You then learned about MySQL scheduled events. As part of this lesson, you reviewed the syntax and process steps for creating a scheduled event in MySQL. You should now be able to work with functions and triggers in a MySQL database. Well done! I look forward to guiding you through the next module in which you'll learn how to optimize a database. You need your databases to respond quickly to your SQL queries. But as your data volumes grow and your data requirements become more complex, the response times can increase. Fortunately, you can use database optimization to improve the performance of your databases. In this video, you'll learn about the concept of database optimization and its importance. Over at Lucky Shrub, they've had a large increase in clients and orders during their latest sale. Their data volumes have grown considerably, so they now need to make sure that they can still retrieve information from the database quickly. Let's find out more about database optimization and discover how Lucky Shrub can optimize their own databases. Database optimization is improving the performance of a database system to reduce the time it takes to query, process, and transmit a user's query. Basically, it's the process of maximizing the speed and efficiency of the database's performance. An optimized database can process a SQL query and return the required data fast. It's also important to note that database performance depends on hardware and software. In this lesson, you'll focus on optimizing queries using MySQL software. At this stage of the course, you've encountered a lot of different kinds of SQL statements. These SQL statements can be divided into 2 categories. Data retrieval statements, which return data from the database, these are also known as select statements, and data change statements, used to alter data within the database, like insert, update, and delete. Both types of statements require different kinds of optimization. Later in this module, you'll explore optimization techniques in detail, but for now, let's look at the basics. Data retrieval statements are select statements. There's a lot of work involved in optimizing select statements, and it typically involves indexes. An index is a type of handle that you can use to quickly look up data. Indexes are created on table columns. You'll learn more about indexes later in this lesson. Other methods for optimizing select statements that you'll encounter in this lesson include targeting specific columns in the select command, efficient use of functions and wildcards in predicates, and making use of inner joins instead of outer joins. You'll also learn about deploying the distinct and union clauses and explore the importance of using the order by clause to sort results. Different methods are required for optimizing data change statements. For example, to optimize update and delete statements, you first need to optimize the conditions in the where clause. And insert statements can be optimized by performing batch inserts. This means inserting more than one row in a single insert operation. For now, you just need to be aware of the distinction between data retrieval and data change statements. You'll explore them in more depth later in this lesson. Although database optimization can be complex, it's worth the effort. As you've learned, an optimized database offers improved performance with faster turnaround times, and it removes unwanted task loads from the database. By optimizing their database, Lucky Shrub can process their sales data much more quickly and efficiently. They'll avoid any potential issues that could arise from the growth in data. You should now be familiar with the concept of database optimization, along with the different kinds of SQL statements that can be optimized. Good work. When working with a database, it's important that your SQL queries are compiled and executed quickly and efficiently by the database. But this can only happen if your queries are optimized. Over the next few minutes, you'll explore techniques for optimizing select statements. Lucky Shrub have received large numbers of orders from their clients. This has led to increased volumes of data in their database. They need to query this data using select statements. To improve the performance of their queries, they'll need to make sure that the statements are optimized. Let's find out more about optimization guidelines and explore some techniques that Lucky Shrub can make use of. As you might already know, select statements belong to a category of SQL statements called data retrieval statements. These types of statements are designed to return data from the database, but if they're not optimized correctly, then they add extra load to the database and slow down its performance. This means that it then takes longer for the database to execute your SQL select statements or queries and return the data you need. However, there are a few basic guidelines or best practices that you can follow to optimize your select statements. You might already be familiar with some of these methods. Target only required columns in your select clause. Avoid using functions in predicates and avoid using a leading wildcard in predicates. Use inner join where possible. And make use of distinct and union clauses only when necessary. Let's take a few moments to explore some examples of these guidelines. When querying a table, you might often make use of an asterisk in your select statement to extract all available data. However, instructing MySQL to query all data in a table adds extra load on the database and slows down its performance, particularly if you only require data from specific columns. A more optimal approach is to list only the columns in your statement that hold the data you require, instead of using an asterisk. Lucky Shrub can use this method to target the required data in their orders table and return the data faster. Another common mistake that database engineers make is using MySQL functions in predicates that refer to columns which aren't indexed. A predicate is an expression that returns a true or false value. An example of this is where clause conditions. You should also avoid using functions in the where clause on a column that's indexed, because this prevents the database from using the index. You'll explore indexes in more detail later in this lesson. Using a leading wildcard on predicates can also lead to a slowdown in the database. An example of this is using patterns that begin with a wildcard when combining the like operator in the where clause. MySQL can't make use of an index in a column during a search when it's matched against a pattern with a leading wildcard. Another method for optimizing databases involves using the inner join instead of the outer join where possible. An outer join retrieves all records from both tables, including rows that don't contain matching values. This takes longer for MySQL to process. The inner join is more efficient because it retrieves only the necessary data or matching records from both tables. This helps to optimize your queries. Often, when creating SQL queries, you'll use the distinct clause to eliminate duplicate values or the union clause to combine multiple query results. This can slow down the query because it must perform a sorting operation and eliminate duplicate records. However, if you use union all instead, then this eliminates the need for a sorting operation and speeds up the execution process. You should now know how to optimize MySQL Select queries and be familiar with basic optimization guidelines. Well done. Lucky Shrub have received large numbers of orders from their clients and need to query this data quickly and efficiently using select statements. They must make sure their queries are optimized so that MySQL can compile and execute them efficiently. First, the sales department needs to find out which orders are arriving on September 12th. They can write a select query that uses the where clause and date_add function. But sorting through the data to calculate delivery dates using the date_add function in the where clause places a lot of extra load on the database. A more efficient method is to generate a custom column in the orders table called expected delivery date. This column shows the expected date of each delivery. So now Lucky Shrub just need to scan this column for all values that match September 12th, and they no longer need to use a function. The sales department's next task is to process an order for a customer with the surname of Ito. First, they need to find the customer's details in the clients table in the database. One method is to use a select statement that combines a leading wildcard with the like operator. But MySQL can't make use of an index when there's a leading wildcard. The solution is to add a new column to the client's table using an alter table statement and call it reverse full name. The reverse full name column contains the client names but reversed. In other words, the client's last name or surname is listed first, then their first name. You can run an update statement on the client's table to carry out this task. Next, use the create index syntax to create an index on the new column. Don't worry about this syntax for now, you'll explore it in more detail in a later video. You can now make use of a trailing wildcard with the like operator on the reverse full name column to achieve the same result. And you can still use the index. Finally, the finance department need a report on all orders placed with the store. They can extract this information by targeting the product and orders tables in the database. Usually, this task could be completed by using an outer join query. However, this type of query also returns records that don't match from both tables, even though they're not required. A more efficient method of querying these tables is for Lucky Shrub to use an inner join that targets the shared product ID columns from both tables. This returns only the matching records, so it's a much more efficient way to execute the query. You should now know how to optimize MySQL Select queries and be familiar with basic optimization guidelines. Well done. When performing data retrieval, MySQL often scans an entire table, even though it only needs to locate specific column values. These queries take a lot of time to execute and place extra load on the database. But MySQL can execute these data retrieval queries faster with the use of indexes that target specific column values. In this video, you'll learn how to use indexes to speed up data retrieval. Over at Lucky Shrub, the sales department needs to retrieve the contact numbers of clients from the database. But there are thousands of clients and phone numbers to sort through. Fortunately, Lucky Shrub can make use of indexes to retrieve this data faster. Before you explore Lucky Shrub's process, let's take a few moments to get a better understanding of indexes. An index is a data structure that helps to maintain pointers that lead to sorted data. Although you can't see an index within a database, it's still helpful to visualize it as a table that contains two columns, one for pointers and another for sorted data. For example, Lucky Shrub can use an index that lists pointers in one column and the full names of clients as sorted data in a second column. There are two types of indexes used in a MySQL database. The first is a primary index, also called a clustered index. The second is a secondary or non-clustered index. A primary index is an index that is stored within the table itself. It's generated automatically once you create a table that contains a primary or unique key. The index enforces the order of rows in the table within the table itself. A secondary index is created using the MySQL create index statement. The syntax begins with create index, then write the name of the index. A commonly used approach is to write the name of the column you want to create the index on, prefaced by IDX for index. Next, use the on keyword to assign the index to a table. And finally, add a pair of parentheses and write a list of columns that the index is to be used against. An index can be created using one or more columns from a table, but you should only create indexes on columns that you'll frequently perform searches against. This is because when you update or insert data into the table, that same data must also be added to or updated within the index, which takes time. Lucky Shrub can use a secondary index to optimize their SQL Select query. They can create an index on the full name column so that client details can be located faster. Now that you're more familiar with the concept of an index, let's see if you can use your new knowledge to help Lucky Shrub. Lucky Shrub need to find the contact number for the client Jane Delgado. However, there are many client names to search against, and MySQL must scan all rows until it locates the correct name. Let's quickly review the approach that MySQL usually takes to complete this task. First, type the explain clause to output data that explains how the database executed the query. You can pinpoint potential bottlenecks and suboptimal queries by reviewing the output. Then type a select statement that selects a contact number from the client's table that matches the value of Jane Delgado. Press Enter to execute the query. The query returns the contact number for Jane Delgado. But as the output results have shown, MySQL had to scan and filter 10 records before it found a matching value. The possible keys column also shows a null value. This means that there's no key or pointer that can help to make the search easier. So the solution is for Lucky Shrub to speed up the search process by creating a secondary index. First, type create index. Then add IDX for index to the full name column. Next, target the client's table using the on keyword, and then place the full name column name in parentheses. Finally, execute the statement to create the index. To test the efficiency of the index, you can create and execute another explain statement. This time, the output result shows that MySQL only had to locate one row, and it was able to locate possible keys using the index full name index. This means that Lucky Shrub's SQL Select query can now search the index and locate the data faster instead of searching through all records in the client's table. And you should now be able to explain what an index is, outline the differences between primary and secondary indexes, and describe the process for creating an index. Well done. How often have you encountered an error during a critical activity, forcing you to begin the task from the beginning? This can be particularly stressful when you're working on many related queries at the same time. Thankfully, you can use MySQL transaction to roll your database back to a previous state. In this video, you'll learn how to manage database transactions with MySQL transaction statements. Lucky Shrub are updating new sales in their orders table and the stock levels in their products table. To carry out this transaction, Lucky Shrub need to create and execute several different queries. But they could encounter an error at any point in the process. For example, the internet connection could fail while inserting data into the table, and this could result in invalid data or an incomplete transaction. However, if such an event were to occur, Lucky Shrub can roll back their database and restore it to its original state using transaction commands. So, what are transactions in MySQL? As you just saw with Lucky Shrub, a transaction in MySQL is one or more queries that can be committed permanently to the database. And the database can be rolled back to its original state if any of the queries fail to execute as required. MySQL provides the following set of statements for managing database transactions: start transaction, begin or begin work, commit, and rollback. Let's explore each of these statements in more detail. Start transaction is the standard SQL statement for starting a transaction process. This syntax marks the point that you'll return to should you decide to roll back the process. So begin your syntax with start transaction. Then list your SQL statements underneath. For example, Lucky Shrub can begin their database updates with a start transaction statement, and then follow this with a list of the required SQL queries. However, start transaction isn't the only way to begin a transaction. With MySQL, you can also use the begin or begin work aliases as alternative ways to initiate a transaction. Whichever method you choose, once you've finished typing your SQL statements and you're happy with the result, then it's time to commit the transaction to the database. You can use the commit statement to commit the transaction changes permanently to the database. Just type the commit statement at the end of your code block. But what if you encounter an error during your transaction, like Lucky Shrub and their internet connectivity issues? Or maybe you typed incorrect code, executed the wrong statement, or entered incorrect data. You can use the rollback command to roll back the current transaction and cancel the changes made to the database. Just add the rollback statement to the end of your SQL statements to return to your start transaction point. However, it's important to remember that the rollback statement must be enacted before you commit your SQL statements. Once you've rolled back your code, you then need to type the correct SQL statements. And once you're happy with these statements, type commit to commit the changes to the database. So let's quickly recap the process. Begin your transaction with Start Transaction. Type your required SQL statements and use commit to commit your changes to the database. And should you encounter any errors or other issues, just use the rollback statement to return to your Start Transaction point. Now that you're familiar with MySQL transactions and the related statements, let's see if you can help Lucky Shrub update the sales and stock levels in their database tables. A client with an ID of CL1 has just placed an online order for 10 bags of artificial grass. This item has a product ID of P1 in the products table. There are currently 100 bags in stock. This number must be updated to 90 once the client's order is processed. First, type Start Transaction to determine the point you can roll back to if an error occurs. Now you need to add the required SQL statements. The first is an Insert Into statement. This statement inserts a new set of values into the required columns in the orders table for the client's order. Then type an Update statement that updates the number of bags of artificial grass in the products table by deducting 10 units from the current stock level. The next step is to use a Select statement that creates an inner join between the orders and products table using the product ID key, which is common to both tables. Execute this statement to check if the transaction was completed as you expected. Unfortunately, it looks like there was a mistake. These updates have been applied to the client with the ID of CL11. It seems you typed the wrong client ID in your code. No problem. You can restore the data by using the rollback statement. Now check the orders and products tables again using Select statements. All data has been restored to its original state. So let's type Start Transaction once again, followed by the same SQL statements as before. Only this time, make sure to update the correct client details. Once you've completed your new set of SQL statements, check that the output is as you expected. Great, this time all details are correct. You can now type commit to commit your changes to the database. You should now be able to manage transactions in your MySQL databases using transaction statements. Great work. When working with databases, you'll often need to write complex SQL queries. These can be difficult to manage. However, you can optimize these queries by compiling them into simple blocks using a common table expression, or CTE. In this video, you'll learn how to make use of CTEs to optimize your database queries. Over at Lucky Shrub, the finance department must calculate the average sale for each customer over the last 3 financial years. To carry out this task, Lucky Shrub need to create one select statement that contains several complicated SQL queries that include functions, strings, operators, and clauses. Fortunately, you can help Lucky Shrub to minimize the complexity of these queries using a CTE. Before you help them out, let's explore the basics of a CTE. A CTE is a method of optimizing complex database queries by compiling them into simple blocks of code. These blocks can then be used to rewrite the query by calling the CTE when required. This simplifies the query and makes it much easier to read and maintain. A common table expression can be created for one or multiple queries. It all depends on the requirements of your database. Let's begin with an exploration of the syntax for a single CTE. The syntax for a single CTE query uses the with clause to start the common table expression. This is then followed by the name of the CTE. This can be a custom name. The as keyword is then used to associate the query within parentheses with the CTE name. Finally, create a select statement to query the name of the common table expression. The syntax for creating multiple queries is a bit more complex. Start your code block using the with clause. Then list the queries underneath the with clause. Make sure that each query has a unique name and is separated by a comma. Finally, type your select statement. To execute a CTE, type its name after the select statement. Or you can execute multiple CTE at once. To execute more than one CTE, add a select statement for each CTE. Place a union operator in between your statements to return data for all statements in the output result. For example, Lucky Shrub can use multiple queries to calculate their average sale. Let's explore Lucky Shrub's use of CTEs in more detail. See if you can help them out using your new skills. As you discovered earlier, Lucky Shrub need to calculate the average sale over the last 3 financial years. Their current approach is to create 3 separate select statements, one for each year. The statements are combined using a union operator. Each statement calculates the average cost by using aggregate and string concatenation functions. The data is extracted from the orders table and the conditions are specified using a where clause. You can click Enter to execute these statements and return the average sale for each year. Although they work as intended, these queries are quite complex and difficult to manage. But you can use a common table expression, or CTE, to improve their readability. Start by using the with clause. Then rewrite the first expression as average sales 2020, followed by the required logic. You can use an as keyword to return it as average sale for improved readability. Then create the second and third expressions. Use the as keyword to associate the expression with the query and make sure that each expression is separated by a comma. Now you just need to type 3 select statements. Each statement uses an asterisk symbol to extract all data from each of the 3 expressions. Place union operators between the queries to combine the results. Finally, press Enter to execute the code. The output is the same as the last query you executed. However, this time you've created a query that is more optimal. All expressions are now contained within a simple block of code that is easy to read and maintain. You should now be familiar with how to use a CTE to optimize your database. Nice work. Each time you create a statement, it must be compiled and parsed by MySQL before it can be executed. This process uses a lot of resources. A more efficient method is to create a prepared statement that can be used repeatedly without requiring clearance each time. In other words, you can create a prepared statement that MySQL compiles and parses just once before it's executed. The statement functions as a template that holds unspecified values as parameters. These values can then be added as required. Each time the statement is invoked, MySQL knows it's safe to execute. This is a much more efficient and optimal way of executing statements without using valuable MySQL resources. Let's look at an example of how to create and execute a prepared statement from the Lucky Shrub database. Lucky Shrub need to extract data on customer orders from their orders table. Let's help them carry out this task using an optimized prepared statement. The prepared statement must return the following information from the orders table in the database for each specified record: client ID, product ID, quantity, and cost. The first step is to prepare the statement using the prepare command. Then type the statement name. This can be a custom name. In this instance, you can call the statement getOrdersStatement. Then type the from keyword. Follow this syntax with a select statement in single quotation marks. This select statement extracts the required data from the orders table against a specified value. However, you might have noticed that the value is currently unspecified because it requires an input value. Later, you can enter any value you like to process the statement with a new argument. You don't have to wait for MySQL to compile and parse the statement. Click Enter to execute the statement. The database returns the output result, a confirmation message that declares statement prepared. The getOrderStatement is now ready to use. Next, you need to declare a variable named order ID and assign it a specific order ID. Let's use an ID of 10. Now you can use this variable with the prepared statement. First, type the execute command followed by the statement name. This command is used to execute prepared statements. Next, type the using keyword followed by the variable name. The using keyword specifies the variable value to be passed to the parameter in the prepared statement. So this prepared statement is basically instructing MySQL to extract the client ID, product ID, quantity and cost data associated with the order ID 10 in the orders table. Click Enter to execute the query and return the results. Although this prepared statement targeted the order ID 10, you could also target any other order ID from the orders table. The statement can extract the related data and it doesn't have to wait until it is compiled by MySQL. You should now be able to create and execute a prepared statement in MySQL. Well done. As a database engineer, you need to work with many different types of data. This can place a lot of pressure on MySQL's resources as it compiles and parses through these different data types. One method of optimizing MySQL's use of resources is to store data using the JSON or JavaScript object notation data type. JSON is an easy method of communicating data between different database systems, and it stores data in a simple text format that doesn't require any special parsing. Here's an example of a line of JSON code from the Lucky Shrub database. Lucky Shrub used this line of code to store properties and assign them specific values. This line of code is placed within a pair of single quotation marks and curly braces within the insert into statement. Each property and value are typed in double quotation marks and separated by a colon. These are known as key value pairs. Each pairing is separated by a comma. Let's explore how Lucky Shrub makes use of this MySQL JSON code in their database. Lucky Shrub need to track the actions of clients who use the online store as they browse Lucky Shrub products and place orders. Lucky Shrub can capture this information and store it in JSON format in MySQL. MySQL can then quickly and efficiently process this data. First, create a table called Activity that stores client activity. Then create two columns. The first column is called Activity ID and provides a unique identifier for each client activity using an integer data type. The second column is called Properties. This is a JSON data type column. It stores the properties of each client activity, like client ID and product ID. It also records if the client has placed an order by placing either a true or false value next to the order property. The next step is to populate the table with data. Create 3 activity IDs and then log client activities using JSON code for 3 client IDs. 2 of these clients have ordered products. 1 client has not ordered a product. Now you need to retrieve data from the properties column. Since you're working with the JSON data type, you need to retrieve or access this data using a column path operator. Type a select statement that selects the activity ID and properties columns. For the properties columns, use the $ symbol and dot notation to denote each element inside the JSON property. Place the column path operator between the columns and their elements. Finally, execute the statement to return the output results from the activity table. You've now helped Lucky Shrub to create an optimal method of storing and accessing data from the activity table in their database. You should now be familiar with how to use JSON in MySQL to optimize the database. Great work! Congratulations! You've reached the end of the second module in this course. Let's take a moment to recap some of the key skills you've gained in this module's lessons. In the first lesson, you learned how to optimize database queries, and you now understand that database optimization is the process of maximizing the speed and efficiency of the database's performance when executing queries. You know that optimization focuses on 2 different kinds of statements: data retrieval or select statements, which return data from the database, and data change statements, used to alter data within the database. You learned that by optimizing a database, you can process data much more quickly and efficiently. During this lesson, you also learned how to implement different optimization techniques on select queries, including targeting only required columns in your select clause, avoiding the use of functions in predicates, and avoiding the use of a leading wildcard in predicates. You also learned to use inner join where possible, and make use of distinct and union clauses only when necessary. And you also explored the use of indexes to help maintain pointers that lead to sorted data. During your study of indexes, you learned that there are 2 types of indexes. The first is a primary index, also called a clustered index. The second is a secondary or non-clustered index. And you then reviewed the syntax for creating a secondary index. This involves using a create index statement, a custom index name, and the on keyword to target the required table and columns. In lesson 2, you explored further optimization techniques. Now that you've completed this lesson, you're able to make use of MySQL transaction statements to manage queries and roll the database back to its original state if any of the queries fail to execute as required. You can manage database transactions using statements like start transaction, begin or begin work, commit and rollback. You can start your transaction using start transaction. And you know that if you encounter an error with your queries, you can add the rollback statement to the end of your SQL statements to return to your start transaction point. As you worked through this lesson, you also learned how to optimize select queries using MySQL common table expressions. You can now use a CTE to compile complex queries into simple blocks of code. These blocks can then be used to rewrite the query by calling the CTE when required. This simplifies the query and makes it much easier to read and maintain. Start your code block using the with clause, then list the queries underneath. Finally, type your select statement followed by the query name. You can also execute multiple CTE at once using the union operator between statements. You then explored MySQL prepared statements. You can now make use of prepared statements to limit the number of times MySQL must compile and parse code. And you discovered how to interact with a MySQL database using the JSON data type. As you worked through these lessons, you also enhanced your understanding of the topics through reading items, tested your knowledge of optimization techniques in quiz environments, and demonstrated your ability to make use of MySQL optimization techniques in a lab environment. Having completed this module, you should now be able to make use of a wide range of database optimization techniques. You can deploy these techniques to make sure that your statements are compiled, parsed, and executed quickly and efficiently in MySQL. Great work! At this stage of the course, you should be familiar with the role that data analysis plays in databases, but it's also important to understand the close relationship between data analysis and data analytics. With data analytics, you can take the data collected during data analysis and convert it into useful information that can inform future business decisions. Over the next few minutes, you'll explore how this works and learn about different types of data analysis. Lucky Shrub have had a great holiday sales season. They've collected a lot of data around their sales. They now need to use this data to help plan for their next sales period. Lucky Shrub can use data analytics and related variables to make sense of this data and plan effectively for the future. So, Lucky Shrub's use of data provides a good base for understanding what the term data analytics means. Data analytics involves taking data analysis a step further by converting and processing the collected data into useful and meaningful information. This information is then used to inform and make predictions about future events. Data analytics also involves the use of special tools, which you'll explore briefly later in this lesson. So your next question is most likely, how do organizations make use of data analytics? Over at Lucky Shrub, they can make use of their data with data analytics tools to predict what products sell best and should be kept in stock, what kind of special offers attract the most customers, and how best to manage their online sales. However, before you can perform data analytics, you first need to analyze and generate insights into the data you've collected. This data is collected through data analysis and SQL queries. There are different types of data analysis that can be performed within a database. Let's take a few moments to explore these different types of data analysis and learn how they inform data analytics. Descriptive data analysis presents data in a descriptive format. In other words, it describes what happened. You can use the data extracted from a database to explain a particular event. For example, Lucky Shrub can analyze their sales over a specific period. They can then describe the period using this data by referring to top-selling products and profits that they made. Exploratory data analysis is the attempt to establish a relationship between different variables in a database. In other words, is there a relationship between variables A and B? Or can you establish a link between variables X and Y? Over at Lucky Shrub, they use exploratory data analysis to determine if there's any correlation between an increase in sales for a specific product and the season in which it's sold, like an increase in the sale of trees during the holiday season. Inferential data analysis focuses on a small sample of data to make inferences about a larger data population and draw general conclusions. Lucky Shrub often make use of inferential data analysis. Their data shows an increase in the sale of barbecue products over the summer months, so they can infer that this is the best period in which to sell these goods. Predictive data analysis uses existing or legacy data to identify paradigms and patterns. These patterns can then be used to make predictions about future performance. For example, Lucky Shrub's data show that the sale of gardening tools increases when these items are discounted. They can use this data to predict that further discounts will lead to more sales. And there's also causal data analysis, which explores the cause and effect of relationships between different variables. Did variable A cause B, or did variable X have any effect on Y? Lucky Shrub's data showed that many customers who bought gardening tools also bought outdoor lighting products. Causal data analysis is a great way for Lucky Shrub to try and identify the relationship between these purchases. Finally, know that database engineers often use the terms data analysis and data analytics interchangeably. Although separate concepts, they are closely linked. You can't have data analytics without data analysis. So be aware of this fact when working with data analytics. You should now understand the concept of data analytics and be able to recognize different types of data analysis. Well done. At this stage in the lesson, you should be familiar with the concepts of data analytics and data analysis and the differences between them. Over the next few minutes, you'll explore the relationship between MySQL and data analysis, along with the benefits and limitations of MySQL as a data analytics tool. Lucky Shrub make use of MySQL to host their data and carry out data analysis. Lucky Shrub's database processes a large volume of data every day, including online orders, client information, and data around the store's products. With MySQL, Lucky Shrub have an effective set of tools to host and work with this data. Over the next few minutes, you'll discover how Lucky Shrub can make use of MySQL to analyze this data. As you've progressed through these courses, you've learned how powerful MySQL is. And another advantage of MySQL is that it offers database engineers the tools required to perform data analysis on the data in their database. However, MySQL also has its limitations when compared to other more advanced data analytical tools. Let's take a few moments to explore these. MySQL databases are built using a relational database model. As you learned in a previous course, relational models structure data sets in related tables, and these related tables make it easy to access, retrieve, and analyze related information. With MySQL, Lucky Shrub can connect their database tables using foreign keys. This means that they can use one table to locate information in another. For example, the orders and products tables are both connected through the product ID key. This relationship helps Lucky Shrub identify the products that each client ordered. MySQL is also a free open source database management system, so there's no cost or intellectual property to consider when managing a database with MySQL. This is of great benefit to Lucky Shrub because it reduces the cost of doing business. And because of its capacity and accessibility, MySQL is a very widely used database management system. Large numbers of businesses, governments, and other organizations make use of MySQL to collect, store, and process data. This makes it easier for these organizations to communicate data and improve their data analytics. For example, Lucky Shrub suppliers also use MySQL to manage their data. So, Lucky Shrub can keep their suppliers up to date with information on their stock levels by sending them data from the products table in their database. However, despite all these advantages, MySQL also comes with limitations. MySQL's capacity to perform data analysis is much more limited than other more advanced data analytics tools. With these other tools, database engineers can perform much more complex data analysis backed by powerful artificial intelligence. MySQL also lacks data visualization features. Other database analytics tools offer database engineers visualization features like bar charts, graphs, and maps. These tools are a much more effective way of communicating information than just presenting data in the form of tables. With these visualization tools, Lucky Shrub could quickly spot trends in their data and identify any major issues. So, as you've just learned, there are a wide range of benefits to using MySQL as a database management system. It's free and open source, holds large amounts of data in a relational system, and is widely used across various organizations. However, its data analysis and visualization capabilities are limited when compared to other more advanced data analytical tools. Analyzing data in a MySQL database requires a good understanding of how to access data and extract relevant information using SQL queries. You should already be familiar with many of these, like subqueries, joins, and views. Over the next few minutes, you'll learn about the role that these SQL queries play in the data analysis process. Over at Lucky Shrub, they need to perform data analysis on the client orders within their database. However, the types of data analysis they need to perform are very different. They include simple data extraction tasks using basic SQL queries, and tasks that involve advanced subqueries, joining tables, and creating virtual ones. Once these tasks are completed and the required data is extracted, they can analyze it and prepare it for data analytics. Let's explore the relationship between SQL queries and the data analysis process to find out more about how they support Lucky Shrub's business. As you should already know, data analysis involves collecting and presenting the data in your database. The data can then be used to gather further insights to support the data analytics process in MySQL. Data can be collected from a database using a wide range of SQL queries. At this stage of the course, you should be familiar with many of these SQL queries. For example, you can extract or collect data using joins to join two tables together, subqueries to create a query within a query, and views to create virtual tables. You can also use functions to perform sophisticated operations and return different results, and filter required data using operators. So the basic process for performing data analysis in MySQL using SQL queries works as follows. You can extract the required data from your database using a wide range of one or more SQL queries. You can then use further SQL queries to present a description of the results of your data analysis. And you can then gain further insight from these initial results using data analytics. Let's explore an example of this process. Lucky Shrub need a list of all products that sold in quantities of 100 items or more. They can extract this data using a subquery that targets the tables that hold the data and filters the required results. Once they execute the subquery, MySQL returns the records that they need, a list of the top-selling products. Once Lucky Shrub identify their top-selling products, they can then use different types of SQL queries and data analytics tools to generate further insights and plan for the business's future. All these insights and potential strategies are made possible by the data collected through SQL queries. For example, now that they know what their best-selling products are, they can continue to buy more of them. And they can buy less of the products that don't sell as well. They could even offer discounts on certain items to try and increase sales. So, to recap this process, Lucky Shrub create a SQL subquery to target the data they require. They then extract this data from the database through data analysis. And this data can then be explored further using more sophisticated queries to generate business insights. Now that you're familiar with this process, it's time to put it into action. As you discovered a few moments ago, Lucky Shrub need to perform data analysis on their client orders. Let's see if you can help them out. The data that Lucky Shrub require is in the orders table in their database. They've extracted the data from the table, but they now need to target specific data that provides insight into the performance of the business. For example, Lucky Shrub need a list of all products that sold 10 items or more. You can extract this data with a select statement that targets the order table's product ID column. Then add a where clause that targets any product ID that has sales data. Next, add a subquery that selects product IDs from the orders table that sold in a quantity equal to or greater than 10. Execute the statement to extract the data. MySQL outputs a table that displays the required records. Joins are also a useful method of performing data analysis in MySQL. You can use different kinds of joins to explore the relationships that exist between data. Lucky Shrub need to analyze and extract data on their clients and the orders they placed over the last 10 days. However, the data exists in two separate tables. You can help them analyze the data in these tables using joins. Write a select statement to join the required columns from the orders and products tables using an inner join. Then use the between keyword to filter the client IDs and related orders from the required dates. Execute the statement to show the required data. Views are also helpful for analyzing data. They can be used to create virtual tables that focus on specific types of data. Lucky Shrub need to analyze their sales data and extract the top 5 best-selling products. You can use a select statement and a virtual table or view to help Lucky Shrub analyze their data for this information. Write a create view statement. Call the new virtual table top products. Then write a select statement that uses an inner join to combine the required columns from the products and orders tables. These tables hold all the sales data you need to help Lucky Shrub carry out their analysis. Finally, use an order by clause to order the extracted records in descending order. Then execute the statement. The statement creates a new virtual table called Top Products that shows the name, quantity, and cost of the top 5 best-selling products. You can use a select statement to extract all data in this virtual table to perform further data analysis. All these insights and potential strategies are made possible by the data collected through SQL queries. And what SQL queries you use all depends on what data you need to extract and analyze and what you want to achieve from this analysis. You should now be familiar with performing data analysis in MySQL using SQL queries. Great work! When analyzing data, there may be times you need to extract all records from 2 separate tables. You could use a join, but this would just return matching records. Sometimes you'll also need records that don't match. So the solution is to emulate a full outer join. This method extracts all records, even those that don't match. In this video, you'll learn how to emulate the full outer join or full join in MySQL to extract data from tables. Lucky Shrub need a list of all their new orders and the clients who placed them. They also need the data of clients who didn't place orders. This data is stored in 2 tables, clients and orders. MySQL supports inner, left and right joins, but these won't return the required data from both tables. So Lucky Shrub need to emulate a full join to extract this data. You can help Lucky Shrub to complete this task. But first, let's find out more about what a full join is and how it works. In SQL, a full outer join returns all records from a left and a right table when it identifies a match between the 2. This includes records that match and those that don't. However, MySQL doesn't support the full outer join, so you need to emulate it using a combination of the left join and the right join. You also need to use the union all operator to return duplicate records should they exist. Alternatively, you could use the union operator to retrieve unique records only. Let's take a few moments to explore the syntax for these methods. Here's how to emulate a full outer join using a union all operator. First, type a select command followed by the names of the columns that you require. Then use a from clause to target the first table, which is your left table. Next, use a left join clause to join the first table with the second table, the right table. Then use an on keyword and dot notation to equate the matching columns between the 2 tables. Now that you've scripted the left join, you need to create the right join. But you also need to combine these joins using a method that returns all duplicate records. It's at this point in your syntax that you can add the union all operator. Once you've added the operator, create the right join. As you should already know, the syntax is almost the same as the left join statement. The key difference is that you must use a right join clause. When executed, the union all statement returns all duplicate records, should any exist. But what if you only want unique records? To retrieve unique records only, you can use the union operator. The syntax is largely the same. You need to script a right join and a left join statement as before. But this time, place the union operator in between the 2 statements instead of union all. Then, when executed, the statement only returns unique records. For example, Lucky Shrub can use the union operator syntax to return unique records from the clients and orders tables. Let's see if you can help Lucky Shrub to emulate a full outer join using the union operator. As you learned earlier, Lucky Shrub need records of all new orders from the orders table and the records of the clients who placed these orders from the clients table. They also need the data of clients who didn't place orders. Start with a select statement. Then target the following required columns from the clients table using dot notation: client ID, full name, and contact number. Then target the following columns from the orders table: order ID, cost, and date. Then use the from clause to identify clients as the left table. Join it to the orders table with a left join clause. The next step is to use the on keyword to equate client ID as the matching column between both tables. Then add the union operator so that the syntax retrieves unique records only. Now it's time to script the right join statement. Again, the syntax is mostly the same as the left join statement. Just use a right join clause instead of a left join one. Finally, press Enter to execute the statement. The output shows all client IDs with their related order IDs. It also shows matching order IDs and client IDs, along with IDs that don't have a match. Lucky Shrub now have all the records that they require from their database, and you should be familiar with how to emulate a full outer join in MySQL using the union and union all operators. Good work. At this stage of the module, you should now be familiar with the data analysis process and how the results can inform data analytics. Now let's look at an example of how to perform data analysis in MySQL by querying multiple tables using joins. Lucky Shrub need to identify all clients who bought 10 items or more from a specific product line so that they can send them a special offer to make more purchases. The clients must have made their purchases after the 5th of September 2020, and there must be 50 units or more of the product currently available in stock so that all special offers can be redeemed. There are 3 tables in the database that contain the required data: the orders table with information on each order, the clients table which contains key information about each client, and the products table which holds the data on all products in the store. You can help Lucky Shrub to query these tables by using an inner join to target the following data: the client ID and contact number columns from the clients table, the order ID, quantity and date columns from the orders table, and the number of items column from the products table. Let's get started. Begin with a select statement, then use dot notation to identify the required columns from each table. Next, use an as keyword to create an alias for the product table's number of items column. Rename it as items in stock. Then target the clients table with a from keyword and use the inner join clause to join it to the orders and products tables within a pair of parentheses. The first join is created between the clients and orders table using the client ID column, which exists in both tables. The second join is created between the orders and products tables using their respective product ID columns. Next, add a where clause and parentheses. Within the parentheses, state the following: customers must have purchased 10 or more units of the item. All purchases must have been made after the 5th of September 2020, and there must be at least 50 units of the item currently in stock. Finally, click Enter to execute the query. MySQL extracts the required data from the tables and displays it on screen. You've now performed data analysis on 3 tables within the Lucky Shrub database, and through data analytics, you can use this data to identify clients that you can send special offers to. Great work! Congratulations! You've reached the end of the 3rd module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you learned how to evaluate MySQL for data analysis. You are now able to explain that data analytics involves taking data analysis a step further by converting and processing the collected data into useful and meaningful information. This information is then used to inform and make predictions about future events. You then learned about the main types of data analysis. These are descriptive data analysis, which presents data in a descriptive format; exploratory data analysis, used to establish a relationship between different variables; inferential data analysis, used to make inferences about a larger data population and draw general conclusions; predictive data analysis, which identify paradigms and patterns; and there's also causal data analysis, which explores the cause and effect of relationships between different variables. You also learned about the benefits of using MySQL as a database management system, particularly when it comes to supporting decision makers in an organization. The primary benefits of MySQL are that it's free and open source. It holds large amounts of data in a relational system. It's widely used across various organizations, and it also offers database engineers the tools required to perform data analysis on the data in their database. And you also know that there are limitations around MySQL's ability to perform data analysis. For example, it's less powerful than other tools and lacks data visualization tools. In Lesson 2, you learned how to perform data analysis in MySQL. Now that you've completed this lesson, you should be able to perform basic data analysis using SQL queries. In this process, you extract the required data from your database using a wide range of 1 or more SQL queries. These SQL queries are used to present a description of the results of your data analysis and to gain further insight from these initial results using data analytics. You then explore the different kinds of SQL queries that can be used to perform data analysis. You can emulate a full outer join to return all records from a left and a right table when it identifies a match between the two. This includes records that match and those that don't. You also learned that you could use the union all operator to return duplicate records, or the union operator to retrieve unique records only. However, MySQL doesn't support the full outer join, so you must emulate it using a left and right join. You can also use functions to perform sophisticated operations and return different results, and filter required data using operators. You can make use of subqueries to create a query within a query and deploy views to create virtual tables. And as you work through these lessons, you also enhanced your understanding of the topics through reading items, tested your knowledge of optimization techniques in quiz environments, and demonstrated your ability to make use of data analyzation techniques in a lab environment. Having completed this module, you should now be able to evaluate MySQL for data analysis and perform data analysis in MySQL. Great work! I look forward to guiding you through the next module in this course. In this course, you learned about advanced MySQL topics. Let's take a few moments to recap the key lessons you encountered during this course. In the opening lesson, you received an introduction to advanced MySQL topics. During this introduction, you learned about advanced database engineering. You discovered how Meta makes use of advanced database engineering techniques, and you learned how to make the most of the content in this course to ensure that you succeed in your goals. You then moved on to the next lesson, in which you learned about functions and stored procedures. In this lesson, you learned how to create and work with functions and both basic and complex stored procedures in MySQL, so that you can reuse or invoke code blocks to perform specific operations. You then learned how to make use of variables and parameters to create more complex stored functions and procedures in MySQL. And you learned how to develop user-defined functions for when MySQL's built-in functions don't meet the needs of your project. You then moved on to the final lesson in this module, in which you learned how to use MySQL triggers and events and automate database tasks. In this lesson, you discovered that a MySQL trigger is a set of actions available in the form of a stored program. These set of actions are invoked automatically when certain events occur. You explored different types of MySQL triggers like insert, update, and delete, and you learned how each type can be used to control the behavior of your triggers. And you also developed an understanding of how you can make use of scheduled events to ensure that your database tasks and events are completed at specific times. You also reviewed other aspects of the syntax used to create a MySQL trigger. You're now familiar with the create trigger command and defining the trigger name and type, and specifying the logic of a trigger by enclosing multiple statements with a begin-end block. You then moved on to the second module, in which you learned about the core rules and guidelines for database optimization. In the first lesson of this module, you explored how to optimize database queries, and you developed an understanding of the concept of database optimization and the advantages it brings to a MySQL database. You also reviewed techniques for optimizing database select statements so that they're executed quickly and efficiently. For example, targeting required columns or avoiding the use of complex functions. And you also learned how to work with indexes in MySQL to speed up the performance of data retrieval queries. The second and final lesson in this module presented an overview of further optimization techniques. You began by learning how to use MySQL transaction statements to manage database transactions. You then discovered how you can use common table expressions to manage complex SQL queries by compiling them into single blocks of code. You learned how to make use of prepared statements to limit the number of times MySQL must compile and parse code. And you discovered how to interact with a MySQL database using the JSON data type. In the third module, you explored the relationship between MySQL and data analytics. The first lesson in this module focused on evaluating MySQL for data analysis. First, you developed an understanding of the relationship between database analytics and MySQL. And then you discovered how to make use of data collected during data analysis by converting it into useful information that can inform future decisions. You also explored the different types of data analysis that can be performed within a database. You then moved on to learn about the relationship between MySQL and data analysis, including the benefits and limitations of MySQL as a data analytics tool. In the second lesson of this module, you learned how to perform data analysis in MySQL using SQL queries like joins, subqueries, and views. You then explored how to emulate a full outer join in MySQL to extract all records from two tables, including those that don't match. And finally, you learned how to extract data from multiple tables using the join method. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your MySQL journey, and you should now understand advanced topics in MySQL. You are able to demonstrate some of this learning along with your practical MySQL skill set in the lab project. You should now be able to deploy functions and triggers in a MySQL environment, optimize a database, and perform data analysis using SQL queries. The graded assessment then further tested your knowledge of these skills. However, there's still more for you to learn. So if you found this course helpful and want to discover more, then why not register for the next one? You'll continue to develop your skill set during each of the Database Engineer courses. In the final lab, you'll apply everything you've learned to create your own fully functional database system. Whether you're just starting out as a technical professional, a student, or a business user, the course end projects prove your knowledge of the value and capabilities of database systems. The lab consolidates your abilities with the practical application of your skills. But the lab also has another important benefit. It means that you'll have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses in this specialization, you'll receive a certificate in database engineering. The certificate can also be used as a progression to other role-based certificates. Depending on your goals, you may choose to go deep with advanced role-based certificates or take other fundamental courses once you earn this certificate. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.
Welcome to the Programming with Python course. Python is a versatile, high-level programming language available on multiple platforms. It's a language that's used by companies large and small to build a diverse range of applications. Areas that Python is used in include web development, data analytics, and business forecasting. The Python programming language syntax is very similar to English. It's intuitive and beginners will often quickly understand what's going on. It's also a great choice for experienced programmers who will appreciate its power and adaptability. Because Python is a very popular software development tool, it's important for you as a new developer to know how it works and to know how to code with it. This course covers the key points you need to know to begin programming in Python. Starting with Module 1, you'll get started with a Python programming language and associated foundational concepts. You'll learn to recognize common applications of Python, and you'll be able to explain foundational software engineering concepts, use operators to program output in Python, and use control flow and loops to solve a coding problem. And in Module 2, you'll build on what you've learned in the first module by learning about the core concepts that underpin the Python programming language, variables, and different data types in Python. And you'll get to use control flow and loops to execute code under specific conditions. This module also introduces you to working with functions and data structures in Python, recognizing errors, determining their causes, and deciding how to handle them, and creating, reading, and writing data in files. In Module 3, you'll learn about the programming paradigms of functional and object-oriented programming. You'll use functions to explore algorithmic thinking. Furthermore, you'll learn how to work with objects, classes, and methods in Python. Then you move on to dealing with modules, packages, libraries, and tools in Module 4. Here you'll learn how to find, import, and use popular Python modules and packages. Leverage powerful tools to optimize the programming workflow. You'll discover different types of testing and their features, and you'll be able to use testing tools to write a test. Module 5 is the graded assessment where you get to demonstrate your Python coding ability. You'll be able to exercise the skills and knowledge from this course, and you'll have the opportunity to reflect on the course content and the learning path that lies ahead of you. You may have encountered some concepts or terminology in this video that you don't fully understand. Don't worry about that right now. This course is designed to address all such issues and give you a solid coding foundation in Python. Enjoy the course.
The developer that wrote Python loved Monty Python's Flying Circus, a TV show. Instead of the snake, the python, he thought the name Python was short and cryptic, and he made it the language name. Hi, Hi, I'm Layla Risby. I am a backend software engineer on Instagram Calling in San Francisco. I've been coding in Python for 10 years. It was the first programming language I learned. I use Python every single day for my job at Meta. It's my favorite language to write in because it's so easy to use and simple. The first application I had to code in Python was to create a calculator. Since Python was the first language I learned, my first application in Python was a little tricky for me to build. Learning how to indent right, how to do spacing, learning the syntax, and learning what loops are, and all of these core computer science concepts was very hard for me. But I tried for a while and it worked out. Some important ways that you have interacted with Python in your day-to-day activities likely include using Instagram, using Facebook, using Google or Spotify. Python is such an ubiquitous language that you likely used it regardless of whether or not you know you've used it. Python is also used for TensorFlow, which is a machine learning framework that Airbnb uses to classify images, and some healthcare companies use to classify MRI data. At Meta, Python is used for the Instagram backend. It is used for our ads, machine learning algorithms. It is also used for our production engineers who keep our services alive and running. You should go through the process of learning Python, even though it might be challenging, because it's an easier language to learn. It's simple. It has a lot of libraries that support it. So it also makes it easier to build more and more features because there's a lot of engineers that use it already. So it makes it easier to develop features quickly and you can see results a lot faster with Python. Thanks for watching the video with us today and good luck on your journey as a software engineer.
Computers and their programs are integrated into our lives at a scale we could not have imagined. Over the past 20 years, we have seen dramatic jumps in technological gains in areas of distributed computing, cloud computing, and AI improvements such as voice and face recognition and self-driving cars. In the next few minutes, let me give you a brief overview of the history of programming, and you will also learn the basics of how programming works. Computing dates quite far back in our history. Charles Babbage in 1822, while studying at Cambridge University in Britain, was working on bettering calculating devices such as navigation charts and astronomical tables, which at the time were used by many ships at sea. Babbage came to the realization that all these calculating devices contained various amounts of human error, and he wondered if there was a better solution. His solution was the difference engine. The difference engine used mechanical gears with numbers 0 to 9 etched onto their gaps, separated by gears' teeth. Its key function was to carry out one operation that was computed by manually moving hand cranks until the final answer was revealed. After building a working prototype, Babbage spent many years working on further improving his designs and constructing improved versions of the original idea. He created another device called the Difference Engine 2, but ultimately produced a new and better concept called the analytical engine. The analytical engine is widely accepted as being the basics of modern-day computing. Babbage's friend Ada Lovelace published a document describing how the analytical engine could perform a sequence of calculations, which is essentially what a computer program does. However, the analytical engine was never completed, and Babbage, like a lot of developers, did not invest in good documentation. With the historical side of things covered, let's now delve into understanding what programming is. Before I explain programming, it's helpful to understand how computers work at the most fundamental level. Computers only understand binary code, which consists of 2 digits, 0 and 1. This may seem quite strange at first, but with a little explanation, it will all make sense. 0 and 1 relate to different electrical states, similar to a light switch. 0 is equal to off, and 1 is equal to on. For example, in programming, when you calculate numbers, cost, or any arithmetic, you mostly use decimal numbers. Every program written needs to be converted to binary code, or machine code. An example of decimal to binary conversion is decimal 1 is binary 1, decimal 2 is binary 1, 0, decimal 3 is binary 1, 1, and so on. A computer represents the binary code by using tiny electrical conductors called transistors. These transistors are housed inside the central processing unit, CPU, which is essentially the brain of the computer. When a program is written using any type of language, it needs to be compiled or interpreted. The outcome is to turn readable programming code for us into readable programming code for the computer. It's essentially extremely hard for humans to read and understand binary, and therefore using it is error-prone. It's far easier for us to read and write programming languages. So, what is programming? Programming is the ability to provide a computer with a set of instructions in a particular language that it can understand and perform those operations or tasks. In other words, you need to tell the computer what you want it to do in a format and language it can understand. Programming is a skill. The more you practice and learn, the better you become. At first, it can take quite a while to write straightforward programs. As you progress, you'll become more familiar with the language and how the logic and conditions should be applied. Programming is also a creative skill. That's because you can write computer programs to solve problems in many different ways. And that brings us to the end of this video. You now know the brief history of programming and how typical computer programming works. Would you like to be able to program on different platforms, for example, Windows, Mac, and Linux, in an easy syntax similar to the English language? Then Python is your solution. It's a high-level programming language that works on many different platforms. By the end of this video, you'll know the benefits of learning Python and understand where to use Python. Python was created by Guido van Rossum and released in 1991. It was designed to be readable and takes a lot of similarities between the English language and mathematics. Since its release, it has gained greatly in popularity and supports a rich selection of frameworks and libraries. At present, it's currently one of the most popular programming languages to learn today. It's widely used in all areas of business, such as web development, artificial intelligence, machine learning, data analytics, and various different programming applications. Python is also very easy to learn and get started with. Given that the syntax resembles the English language, it makes it easier to read and decipher. Programs that are written in Python also require less code in comparison to programming languages such as C or Java. One of Python's key advantages is that it makes developers very productive and allows projects to be completed more quickly. Creating good software that is used by many is hard and very time-consuming. The simplistic nature of Python abstracts a lot of complexity away from the developer to allow them to focus on the task at hand. Given the language is quite easy to understand and pick up, it can be an easier route to market for new programmers starting out to get something produced in much less time. Compared to some other languages, Python has a much easier learning curve. It lends well to the philosophy of write less, do more. Now that you can describe the benefits of learning Python and where it can be used, it's also good to know that Python developers are in high demand. Becoming a Python developer makes for a good career choice.
When you start using Python, it's important to make sure that it works correctly on your operating system with your chosen Integrated Development Environment, or IDE. In this case, Visual Studio Code, or VS Code. So, an essential step in using this software is to make sure that the right version of Python is used as the interpreter when running VS Code. In this video, I will demonstrate how to set up VS Code on Windows and make sure that it points to the correct Python interpreter. So, I start by opening the VS Code editor. To do this, I click on the Windows icon in the taskbar, which brings up a menu. I then type Visual Studio Code in the search bar. The best match for the search is the Visual Studio Code app, which I click on to open. VS Code is now open. Next, I select Get Started with Python Development. This is a useful guide to setting up Python on the VS Code IDE. The first step in the guide is to install Python. I already have Python installed, and I can verify it by typing Python --version in the terminal. To open the terminal, select the Terminal tab on the top menu and choose New Terminal. After I press Enter, it displays Python version 3.10, which is correct. The second step in the guide is to create a Python file. I do this by clicking on the Create a Python File option in the guide menu, and then clicking on the Create Python File button that appears. Next, I put in a print statement by typing print hello world. I will explain what a print is at a later stage, but for now, you just need to know that it's for printing out a value within the terminal itself. Now I save this as a Python file in my root level directory by clicking on File, Save As, and then entering the file name hello world.py. py is the file extension I have to use when saving a Python file. The next step in the guide is to select a Python interpreter, and I click on this option in the guide menu. And then I click on the Select Python Interpreter button that appears, which brings up all the versions of Python I have installed. I do this because I want to make sure that when I run the Python script, it will choose the correct interpreter. The version that comes up is Python version 3.10, and I set this as the interpreter because it is the most recent version. To test and verify that everything is working correctly, I have to run the Python file. In the top right of the screen, you'll notice a play button. I close the guide so that it displays better. The play button has a drop-down menu that has the option for running the Python file or running it in debug. I click on the Run Python File option. Note in the terminal window that it has run the file using Python 3.10 as the interpreter, and I get the output of Hello World. And that means that I'm now set up to use Python directly in the IDE so I can run and debug my scripts. You now know how to create and save a Python file and how to select the correct Python interpreter to run your files in VS Code. When you start using Python, it's important to make sure that it works correctly on your operating system with your chosen Integrated Developer Environment, or IDE. In this case, Visual Studio Code, or VS Code. An essential step in using this software is to make sure that the right version of Python is used as the interpreter when running VS Code. In this video, I will demonstrate how to set up VS Code and make sure that it points to the correct Python interpreter. On my Mac, when I open Launchpad, I type in Visual, or VIS for short, and it opens VS Code. VS Code provides a walkthrough guide for setting up Python. This can be found on the welcome screen. However, if I don't see it in the main view, I can click on More, and then I click on Get Started with Python Development. It brings up the guide I can use to verify that I have everything set up correctly. Next, I check that Python is installed by opening the terminal window. I click on the bottom left of the screen and then on the Terminal tab. Then I type Python space -- and the word version. When I hit enter, notice that it returns Python version 3.10, which is correct. By default, Mac comes with Python version 2.7, but this is not the version I want to use. Instead, I want to use the most recent version. Next, I create a simple Python file. To do this, I click on Create Python File in the Get Started with Python Development guide. I put in a print statement by typing print hello world. I will explain what a print is at a later stage, but for now, you just need to know that it's for printing out a value within the terminal itself. Now, I save it by clicking on File, Save As, and then entering the file name, hello_world.py. py, or pi, is the file extension I have to use when saving a Python file. Now I have to check that I can run that file, and to do that, I need to set my Python interpreter. So, I go to the Get Started with Python Development guide again, and I click on Select Python Interpreter, which opens up the Python interpreter screen. Here I can choose which version to use from the drop-down menu. Notice that I have different versions of Python installed, but the one I want to use is the one I installed through Homebrew, and it is also the recommended one. To bring up the Python interpreter screen without the Get Started guide, I can press the Command key, Shift, and the letter P. Then, I type in Python, followed by a colon, and I choose Python Select Interpreter from the top of the menu. Then, I press Enter. When selecting the version of Python, it's best to choose the recommended one, but make sure that it's the latest version that you have installed on your operating system. Next, I'll run the file. First, I close the Get Started guide. Then, in the top right of the screen, you'll notice a play button with a drop-down menu, which has the option for running the Python file or running it in debug. I click on the Run Python File option, and then I click on the play button. Note that the output appears in the terminal. I have now validated that I have VS Code pointing to the correct Python version that I want to use, and that I am able to run and execute scripts directly on the IDE. You now know how to create and save a Python file and how to select the correct Python interpreter to run your files in VS Code.
Did you know that Python can be run directly in the command line on Windows or Terminal in Mac and Linux? In this video, you'll learn more about the core differences of running code from the command line via the IDE, as well as exploring ways in which you can run programs through Python. Let's explore the two main ways to run Python's programs. The first way is using the Python shell, and the second way is to run a Python file directly from the command line terminal. The Python shell is useful for running and testing small scripts. For example, it allows you to run code without the need for creating new .py files. You start by adding snippets of code that you can run directly in the shell. Let's explore the second main way to run Python's programs, which is running a Python file directly from the command line or terminal. Note that any file that has the file extension of .py can be run by the following command. For example, type Python, then a space, and then type the file name with a .py extension. VS Code is a better choice than using the Python shell or running it directly from the terminal because, besides including both of these options, it comes with a plethora of additional improvements that make coding in Python a better experience. Visual Studio Code also offers features such as auto-completion, debugging, and code syntax, highlighting whitespace and indentation helpers. I'm now going to demonstrate the different ways that you can run Python programs in VS Code. There are two options to run programs through Python. One is to run directly from the command line or the terminal if you're on Mac, and then the other option is to run directly from the IDE, which in this case is Visual Studio Code. Let's find out how to do this. First, I open the terminal window or command line window from within the IDE by clicking on the terminal menu and selecting New Terminal. Now I run the hello world.py script directly from the terminal. So I can run this by typing the command Python and then the name of the file hello world.py, followed by the name of the file. Then hit the Enter key. The result is hello world. There's a second option using the terminal, which is entering it into the Python shell. So if I only type the Python, hit the Enter key, it opens the Python shell approach. Here I can write code and run it directly within the terminal window. I can, for example, use the same code that I have above the print hello world code. I hit the Enter key, and that will print out the words hello world directly in the shell. Let's say I want to exit from the shell. I then type in the word exit. As this is a function, I must add the parenthesis, hit the Enter key, and now I'm back in the command window. To do the same from within the IDE, I just close the terminal window. Here I can run any Python scripts from the IDE directly by using the buttons in the top right-hand corner of the screen, by selecting from the drop-down either the Run Python file or the Debug Python file. Now I click on the Run button, and the terminal should open automatically. The result is Hello World that is printed. You have now explored the two options that are available for running Python code directly from the terminal or command line and from the IDE. That brings us to the end of this video. You now know the core differences of running code from the command line via the IDE. You are also able to demonstrate ways in which you can run programs through Python.
In this video, you'll explore Python syntax and learn how both whitespace and indentation can impact a program when used incorrectly. In VS Code, I create a new file called python_syntax.py. I start by using a print statement to generate a line of text. Don't worry if you're not familiar with print or variable declaration at this point, as that will be covered later in the course. I type print followed by the string hello. When I click on the Run button, the text hello appears in the terminal panel. Now let's say we want to use another print statement on the same line, which will output the text value world. So I add a space and then type another print statement with the string world, and we expect this to give us the words hello world. But when I click on Run, we actually get an error. Specifically, it says syntax error, invalid syntax. This happens because the interpreter doesn't know when the new line or statement occurs. There are two ways to solve this problem. One is to move the second print statement to another line. I do this by placing the text cursor before the print statement for world, and then pressing the Enter key to move it down one line. When I click on Run this time, there is no error and I get the words hello and world on separate lines. Let me undo the edits I made to my code by pressing Ctrl and Z or Command Z on a Mac, and then try the second method, which is separating the two print statements with a semicolon and a space. When I click on Run again, it also runs both statements as expected. Next, you'll cover the impact of whitespace in Python syntax. I first clear my screen and then declare a variable and assign it a value by typing x equals 1 plus 2. On the next line, I will add a print statement for x. Before I click on Run, however, I'll go back to my variable assignment and add a random number of spaces around the plus symbol. Doing this will not cause any problems with this line. However, issues will arise if I add a new line or an end statement. To demonstrate it, let's input a new line and type +3. Running this code then returns a value of 3. What has happened is that the interpreter has executed our first line of 1 plus 2 correctly, despite the extra whitespace, but it did not account for the +3 on the second line. There are a few ways to work around this issue. The simplest approach is to use a forced line. To do this, I type a backslash at the end of the first line. Now, when I click on Run, it returns a value of 6, which means that both lines have been accounted for. To summarize, any amount of whitespace or indentations on a line is fine, but keep in mind that if you are combining it with additional lines, then you will need to give clear indicators of where a new line has occurred. Next, you will explore indentation in Python. I start by clearing my screen and declaring the new variable name with a string value of John. I want to write an if statement which will return John only if the name variable has a new value of John. I do this by typing if name double equals John, and then on a new line, I input a print statement for name. To make this program work, I need to have an indentation before the print statement, which VS Code added automatically. When I click on Run, I get back John as expected. But what happens when the indentation isn't there? If I delete the indentation from my code and then run it again, I get the error indentation error expected in indented block. This tells us that an indentation was not found where it should have been. Fortunately, the error message directs us to the specific line where the issue was detected. I could then edit my code and fix it. When writing programs in Python, it's a good habit to read the output whenever you encounter an error, as you are often given the specifics of what went wrong and where it happened, as you noticed here.
Variables are an essential part of programming, and they are used to store all different types of data. You might even say they are the cornerstone of programming. This is because they allow you to work with and manipulate data. Therefore, it's important that you can identify variables and recognize how they are used. Declaring variables in Python is very straightforward. All you need to do is declare a name and assign it a value. The word variable refers to something that can be changed. To do this in Python for a variable that has already been declared, you only need to reassign or redeclare it. Let's explore an example. Let's say the variable x has been assigned the value of 10. To change this, you only have to redeclare it, so it will have the value of 20. The examples so far have relied on simple naming conventions such as X, Y, and Z. When working on a project with other developers, it will become increasingly difficult to know what these variables mean or refer to. As a programmer, you will write a lot of code over time. And if it's been a few months, you'll most likely not remember exactly what the code was supposed to do. Using generic variables like X and Y doesn't give any information about that variable and where it is used. Giving meaningful names to your variables that make sense in the given context will allow you and other programmers to easily understand what's going on. As a programmer, it's important to understand that data will change throughout the life cycle of your program. Whether it's getting user input via a web form or working with variables inside a code itself, the key function of the variable is to keep a reference to some sort of value. Now that you have a basic grasp of variables and their role in Python, let's move on to a more practical demonstration of the variables and how to use them. I'll demonstrate how to use variables in Python, but first, I want to briefly talk about naming conventions. There are different options available to you as a developer when it comes to naming your variables. One option is called camel case. The first letter of the first word is lowercase, and the first letter of every word after that is uppercase with no spaces between words. For example, if I have a variable called my name, I'll put the M of my in lowercase and the N of name in uppercase, with the rest of the letters in lowercase and no space between the words. I can take a different approach with snake case. When using snake case, you keep everything in lowercase letters, but you use an underscore between words. So if I want to make the variable my name, my underscore name would be the result of this approach. Although you have different options as a developer, it's a good idea to be consistent when you are creating variables across your programs. Let me clear the screen so I can begin. So I create a variable in Python by initializing a variable and assigning it a value. All I have to do is name the variable. For example, if I type x equals 5, I have declared a variable and assigned it a value. I can also print out the value of the variable by calling the print statement and passing in the variable name, which in this case is x. So I type print x. When I run the program, I get the value of 5, which is the assignment that I gave the initial variable. Let me clear my screen again. You have several options when it comes to declaring variables. You can declare any different type of variable in terms of value. For example, x could equal a string called hello. To do this, I type x equals hello. I can then print the value again, run it, and I find the output is the word hello. Behind the scenes, Python automatically assigns the data type for you. You'll learn more about this in an upcoming video on data types. You can declare multiple variables and assign them to a single value as well. For example, making a, b, and c all equal to 10. I do this by typing a equals b equals c equals 10. I print all three values separately, and when I click on the run button again, I find that all three of those assignments have 10 as their value. Again, I clear my screen before I move on to the next example. Yet another option you have is to do multiple assignments. For instance, I type a, b, c separated by commas equals 1, 2, 3, also separated by commas. In this way, I have assigned each of those values to the corresponding letter. So a equals 1, b equals 2, c equals 3. To test this out, I can print all three variables. Click Run, and I'll find that the values 1, 2, 3 correspond to the declaration above. Another important point that you should be aware of is variable assignment and how you can change it. A variable is subject to change. Throughout the life cycle of your program, you will make changes to the value or the assignment of the variable itself, so you need to know how to do that. Let's explore another example. I type a equals 10, and I print that value. After this, I change the value of a to 5, and I print that value too. When I click the Run button, a prints out as 10 on the first line and as 5 on the line below, because the value was reassigned. Finally, you need to know how to delete a variable. My variable is a, its value is 10, and I've printed it out. And then on a new line, I type the delete command, or del for short, followed by a space and the letter a, which represents my variable. I then print the variable by using the print function, and then I click the Run button. The value is first given as 10 because the variable still existed, but after the deletion, it shows an error saying that a is not defined. You just covered variable naming conventions. Now you know how to declare a variable and assign it a value, and you know how to declare any different type of variable in terms of value. You can declare multiple variables and assign them a single value, and you can do multiple assignments. Finally, you also learned how to delete a variable. That brings us to the end of this video. You can now identify variables and recognize how to use them in Python. Computer systems need to interpret different data values. In programming, data can come in different types. By the end of this video, you'll be able to describe the different data types in Python. A data type is an attribute associated with a piece of data that tells a computer system how to interpret its value. Knowing what data types to use ensures that data is collected in the preferred format. It also ensures that the value of each property is as expected. Python offers raw data types to allow data to be assigned to variables or constants. The 5 main types which are classed as literals consist of numeric, sequence, dictionary, Boolean, and set. Some of these data types can be extended. For example, the numeric data type can consist of types integer, float, and complex number. For now, let's just discuss data types in more detail, starting with numeric. In programming, you need to decide on what type will suit your needs. For example, when working with currency, you are most likely going to use the numeric type of float, as it allows decimal places to be counted. To determine a type of variable, Python also provides a function named type, which will provide the class type based on the variable being passed. Python offers 3 different kinds of numeric types, which are integers, floats, and complex numbers. The integer class represents any non-fractional number, that is, whole numbers with no decimal places. These numbers can be positive or negative, for example, 10 or minus 10. Floats are numbers that contain decimal places and are represented by the float class. Examples are 10.5 or 6.7. The complex class is used to represent complex numbers which are made up of both real and imaginary numbers. A equals 10 plus 10j. Next, let's explore the sequence data types. Sequence types are classed as container types that contain one or more of the same type in an ordered list. They can also be accessed based on their index in the sequence. Python has 3 different sequence types, namely strings, lists, and tuples. Let's explore each of these briefly, now starting with strings. A string is a sequence of characters that is enclosed in either a single or double quotes. Strings are represented by the string class, or str for short. Lists are a sequence of one or more different or similar types. They are essentially an array and hold any type inside square brackets. Each item can be accessed by its index. Tuples are similar to lists in many ways. They contain an ordered sequence of one or more types, but the main difference is that they are immutable. This means that the values inside the tuple cannot be modified or changed. Tuples are represented by the tuple class and hold data types wrapped in parentheses. The next data type is dictionary. Dictionaries store data in a key value object structure. Each value can be accessed directly by its key. Dictionaries can also store any data type. For example, suppose you declare a variable named ed and assign a dictionary to it. The dictionary contains a grouping of key value pairs. The first pair is A, 22, where A is the key and 22 is a value. The second pair is B, 44.4, where B is a key and 44.4 is the value. You can then output the value of 22 by accessing its key, which is A. Next, let's explore Boolean data types, which are simply represented as true or false. Combined with logical operators, Booleans are used to check whether a condition is true or false. In this example, I'm checking the underlying data type of the values true and false. The class bool is returned, meaning it is Boolean. The last data type is set, which is an unordered and non-indexed collection of non-repeated values. Let me demonstrate an example of this data type. Suppose I assign a set of 4 items to the variable named example set. I then check the type of the value stored in the example set variable by passing it to the type function. Python reports that the underlying data type that the example set variable holds is a set. In programming, data type is an important concept. Variables can store data of different types, and different types of data can do different things. Let's explore these in further detail. Whenever you declare a variable in Python, the data type is automatically assigned for you based on the value of that variable. Let me demonstrate this by typing a variable called a and assigning it a value of 10. To check the data type that has been assigned by Python, I select print and use the type function. I then pass in the variable a as the parameter and click on run. From the output on the terminal, I can see a class of float was assigned because there is a decimal place. Here is another example. I'm using the variable b and I assign it a decimal value of 2.3. To check the data type assigned by Python, I print out type b and click on run. From the output on the terminal, I can see a class of float was assigned because there is a decimal place. This is a different assignment than the standard integer. These are the numeric data types offered in Python. To declare a variable as a string, I wrap the text with single or double quotes. Again, I run the print statement with the function type and pass the variable c as the parameter. When I click on run, the output in the terminal now displays the classes int, float, and str for string. This sequence is also applicable for other data types. For example, I can create a list of numbers by using the variable d and assigning it the numbers 1, 2, 3, 4. When I run the print statement with the function type and pass the variable d as the parameter, the class list displays after I click run. Each time I assign a value to a particular variable, Python behind the scenes is automatically assigning the correct data type for that variable. In this video, you learned about the different data types in Python. I encourage you to start experimenting with these data types in your practice code. You may recall that Python can work with several types of data. In this video, you'll learn how to declare and use strings in Python. You'll also gain a general understanding of sequences and how to access individual items in a sequence. In Python, a string is a sequence of characters enclosed in either single or double quotes. As you may know, computers only understand binary code, which consists of ones and zeros. This means that characters need to be converted to a form that computers can interpret, a process known as encoding. Python uses a type of encoding called Unicode to communicate with computers. Strings in Python can be declared in several ways. For example, for a single line, you can type the variable name followed by an equal sign, and then the characters encased in quotes. If your string is too long for one line, you can add a backslash at the end of each line to create a multi-line declaration. When you run print on your variable, all those strings will be combined and appear on one line. If needed, you can reassign the value of a string. Say, for example, the variable name has a string value of John, but you want to change the value to Paul. This can be done simply by typing name equals Paul. Now, when you run print on name, this update should be reflected. It's important to know that a string is just a sequence of characters, which in turn means it is essentially an array. Each character in the sequence can be accessed based on its index. For example, Python strings use zero indexing, so you can access the first character with the number 0 in square brackets, or the number 2 to access the third one. If you need to check the length of a string, Python has functionality to assist you. You can apply the len function to a variable with a string value. This will then return a number that represents how many characters are in the string. Now that you've learned what strings are in Python, let's explore some code examples of strings in action. First, let me demonstrate the two ways to declare a string. The first method is by placing the characters inside of single quotes. So I type A equals and then hello in the quotes. On the next line, when I type print followed by A in parentheses and then click the run button, my code returns the string hello as the output. The second method is similar but uses double quotes. So I would enter it as B equals hello with double quotes. When I run the print function again, it also returns the string hello. Both quotation types are equally valid declaration methods. The choice is a matter of personal preference, but it's best to pick one option and use it consistently throughout your code. In addition to the quotation types, you can declare single line or multi-line strings. An example of a single line string can be A equals this is a single line. I asked to print out the value of A. When I run it, the value is printed out as I declared it. However, there may be cases in which a string is very long and you want to break it up into segments to make it more readable. To do that, I can use the backslash key to create a multi-line string. To declare a multi-line string, I type B equals followed by the string this is a multi. Before continuing, I add a backslash at the end of this line. On the next line, I type the continuation of my string, line string example. Note that I enter a space before the word line, so that it's separated from the last word of the string on the previous line. And now when I run print on B, the backslash has the effect of joining both segments so that the output appears as a single string. Another thing you can do with strings is concatenation, which is the joining of separate strings. To demonstrate this, I first create two new variables, A equals hello with a space at the end, and B equals there. When I run print this time, within the parentheses, I type A plus B and get back both strings joined together. The plus symbol is usually used as an arithmetic operator, but when applied on strings, it combines them instead. And one more thing to know about strings is that they are considered collections of characters. What this means is that, much like an array, you can access individual characters based on an index, and you can also check the length of a string using the len or len function. To give an example, I create a name variable with the string value John. Now I want to print only the first character of this string. To do so, I run print on name, followed by the character index number inside square brackets. Strings in Python are zero indexed, meaning that the sequence count begins from 0. So 0 is the number that I place in the brackets. When I click on run, I get back the letter J. If I change the number to 3 and run it again, I get back the letter N, the fourth character in the string John. Next, let's check how many characters are in this string by using the len function. I start a print function, and in it I type len followed by name inside of parentheses. When I run it, it returns 4 as the length. In this video, you've learned about strings in Python. Specifically, you now know how to declare and use them, and understand that they are sequences of characters. See you in the next video. Python uses different data types to process and use information effectively. Sometimes you need to change the data type of a variable after you've collected values for it. Let's say, for example, a user submits a form on a website, and one of the fields was an integer, but the data was passed as a string. This is a problem because the only way to perform calculations with the number saved as a string is to convert it to an integer data type. To do this, you can use typecasting in Python. In this video, you'll learn about 2 different typecasting methods in Python. You will also learn to apply typecasting using the provided Python functions. So, what is typecasting? Typecasting is the process of converting one data type to another. Python has 2 different types of conversions, implicit and explicit. Let's explore each now in a little more detail, starting with implicit. Implicit data type conversion is performed automatically by Python's compiler to prevent data loss. It will convert, for example, an int to a float if it picks up that the inserted value is a decimal. It's important to note that Python will only be able to convert values if the data types are compatible. Int and float are compatible, but strings and int are not. So if data types are not compatible, Python will throw a type error. Alternatively, developers can perform typecasting with the explicit data type conversion. You do this by using the provided Python functions. There are many functions, but some of the most common are string, integer, and float. Let me take you through some of these functions and how to use them. First is the string cast function. This is used to convert any data type into a string data type. To use this function, you type str followed by the value that you want to convert between parentheses. Next is the int typecasting function. To use this, type int followed by the value that you want to convert between parentheses. The float function is another common type of casting function. Once again, you type the word float and add the value that you want to convert in between parentheses. Python has many more typecasting functions, and they also have a similar structure. They are odd, which returns an integer representing the underlying Unicode character. The hex function, which converts a given integer to a hexadecimal string. And oct, which takes an integer and returns a string representing an octal number. There are also tuple, set, list, and dictionary, which you will learn more about later in the lesson. In this video, you learned about typecasting in Python. It's important to remember that data types are not unchangeable. You can convert data types using the provided Python functions if you need to. Like other programming languages, Python focuses on taking inputs from users or other services and providing output. Python has many helper functions that make it easy to perform both of these actions. You may recall that you use the print function to output variables and other values. In this video, you'll learn more about the print function and how to use another new function called input. The input function is designed to get data from a source of input, and it can be used in different ways. For example, one of its most basic uses is when you use the input function to get data that the user types in the keyboard. This input can then be printed to the screen. In many cases, you want to get input directly from a user. For example, When you ask for a user's email address, let's say you want to use the input function to prompt the user to enter their email address, and then save that input to a variable called email. If you run this code, the user will be presented with a prompt to enter their email. The email variable will then contain the email address. Okay, let's switch back to the print function, which is used for output in Python. It can be used to print all different types of data, and it allows for more complex formatting. The print function itself accepts any number of arguments. For example, comma separated to print numbers in sequence, arithmetic to print the outputs of an equation, and string concatenation to join or concatenate two strings together. Python's print function also has reserved keywords that can be passed as additional arguments. These include objects, that is, values that are printed on screen, sep, which defines how the objects being printed are separated, and end, which defines what gets printed at the end. There's also file which specifies where values get printed to, and by default it is stdout. And lastly, flush, a Boolean expression to flush the buffer, which essentially just moves the data from a temporary storage to the computer's permanent memory storage. For example, suppose you can pass 3 parameters to the print function: the word hello, which is a string, the word you, which is another string, and sep, which is a built-in parameter whose value is set to a string containing a comma and a space. This will be used as a separator between the hello and you strings, and the output is hello, you. Often while programming, you need to know the value of a variable and output it onto the screen. Python allows for direct formatting inside the print statement. You can also control the order by specifying the numbers inside the curly brackets. For example, if you print the same statement twice but with the numbers switched, the output will differ. Let's move on to a more practical application of what you've just learned using some code examples of input and output. I'll demonstrate how to use input and output in Python. I'll begin by demonstrating the input function. I start by typing input, opening parenthesis, and closing parenthesis. I then click on the run command, and you'll notice that it runs the input function. And I'm provided with a console where I can actually type an input. So I type hello there, and I press enter. Nothing happens because I'm not actually collecting data. I'm just triggering the input function. And by default, it'll open up access to the command line or the console and allow me to input data. I can also add a prompt to the input function. For example, I can ask a question to the user such as, please enter a number. So I type, please enter a number in between the parentheses after the word input. First I clear the console, and then I click on run again. You'll notice that the output now asks me to enter a number. I type 5 and press enter. Again, nothing shows up from an output perspective. This is because I haven't actually done anything with the input value. I'm just demonstrating how the input function works. If I want to get the value of the input, I need to assign a variable. So I type in num equals input. Please enter a number. I clear my console screen again, and I click on the run button. It asks me for a number in the console, and I enter the number 6 this time. Now the num, or number, value will contain the number 6. But in order to see that, I have to output that variable to the screen. I can do this by using another function called a print function. So in this case, I print the number after the input itself by typing print, opening parenthesis, the abbreviation num, and a closing parenthesis. I clear my screen again and click on run. This time I type the number 7 when asked to enter a number. I press enter, and you'll notice that the output prints 7. Now I want to show you that you can collect more than one input as part of the input because inputs work in a sequential manner. So I call this variable num1, and I enter another variable called num2 on the next line. The input for this variable is please enter a second number, and I just change the first variable's input to please enter a first number so that the instructions are clearer. I print out the value of num1 and num2. The print statement accepts both variables because they are separated by a comma, and it'll print out each one in that order. Again, I clear my console and I click run. I type 4 as the first number. I press enter and type 5 as the second number, followed by the enter key again. You'll notice 4 and 5 are printed out. You can also do arithmetic within the print statement. In other words, you can do addition, subtraction, standard multiplication, and division. So instead of using commas in the print statement, I type num1 plus num2. I clear the screen once more and I click run. I enter the numbers 5 and 4 again, and I get back 54. Now, this isn't exactly what I intended to do, and the reason is because both variables are strings. This goes back to what you've learned previously with data types. If I want to do the arithmetic calculation, I'll need to convert each variable into an integer first. So I can use the integer function on num1 and num2. I click on the run button once more and I enter the same two numbers, 5 and 4. But now what I get back is 9. If I want to see what type the input is, I can check the data type by using the type function. To do this, I type print, opening parenthesis, the word type, opening parenthesis, num1, followed by 2, closing parentheses. Let me just clear the screen. I click on run and enter the numbers 5 and 4 again in the console, and it says that the class is string and not integer, which is the type I actually want to do arithmetic. So just be mindful when you are using input that you will get a string. You'll most likely need to use the explicit data typecasting to convert it to the data type that you need. The print statement can also be used for concatenation. So instead of num1, I change it to str1 or string1, and I do the same with num2 by changing it to str2. Then I amend the input to read, please enter your first name for string 1, and please enter your second name for string 2. After that, I print out hello, and then use concatenation so that the user can be greeted by their first and second name. Now I want to run this program. I'll just clear the terminal quickly, and then I click on run. In the console, I type Tom for the first name and Jones for the second name. And the result is the output of hello Tom Jones. So concatenation can be used with a print statement as well. Finally, you can also change how you assign variables. You don't have to use concatenation, you can just use string replacement. I'm going to use a function within Python called format for this. Based on the order of the brackets, you can pass in the variables that you want it to be replaced with. In this case, string 1 and 2. Once more, I click run and I enter the username of Tom Jones, and hello Tom Jones gets printed. In this video, you've expanded your knowledge by learning about the input and output function in Python. An operator is a symbol that tells Python to perform a certain operation. You can think of them like road signs in real life. For example, suppose you're driving on a dangerous road and you spot an alert sign to reduce speed. Then you encounter a stop sign, and finally, a sign instructing you to turn right. You may not have realized that you were on a dangerous road. These symbols help keep you safe by instructing you to perform a specific operation. Similarly, when Python comes across an operator that you place in your code, it will also perform that specific operation. These operations can be mathematical, logical, and comparison. In this video, you'll learn about math and logical operators in Python. Most of the time, operators work on two values. Math operators are used for simple and complex calculations. It's essentially all the same options as the calculator would have. Let me explain this with examples of math and logical operators. The first operator I want you to know about is the addition or plus operator. The plus sign is a symbol that you must use when adding numbers together. For example, 2 plus 3. To subtract numbers from each other, you use the subtraction or minus operator. Use the minus sign to subtract numbers. An example of this is 3 minus 2. The division operator is next, and the symbol you use for it is a /. Division is an operation in which one number is divided by another. For example, 35 divided by 5. The last operator you need to know about is the multiplication operator, and the symbol you use for that is the star or asterisk key. Use this to multiply numbers with each other. For example, 7 multiplied by 4. Okay, now let's explore logical operators. Logical operators are used in Python on conditional statements to determine a true or false outcome. Let's explore some of these now. The first logical operator is named AND. This operator checks for all conditions to be true. For example, A is greater than 5 and A is less than 10. The second logical operator is named OR. This operator checks for at least one of the conditions to be true. For example, A is greater than 5 or B is greater than 10. The final operator is named NOT. This operator returns a false value if the result is true. For example, A is not greater than 5. Operators are usually combined with conditional statements to control the flow of a program that meets specific criteria. For example, let's say a restaurant gives discounts based on the following two conditions. Is the customer part of the loyalty program? And did they spend over $100? To determine this, you can write code using logical operators to check if the customer is in the loyalty program and if they spent over $100. You'll learn more about conditional statements in a later lesson. Now, let me demonstrate how to use Python, math, and logical operators. Math operators basically give you the same functionality as what you have on a standard calculator, so you can perform operations like addition, subtraction, division, and multiplication. I start with a simple addition example. I'm using the print statement, so the output displays on my console. I type print, and in parentheses, I add 2 plus 2. The value I expect back is 4. When I run the statement, the value of 4 displays in the terminal. For subtraction, I change the plus sign to a minus sign. I click on the run button and the value displayed is 0. If I subtract 2 minus 2, the answer is 0. For division, I change the minus sign to a forward slash. I type 35/5 in the parentheses. I click the run button and the result is the value of 7.0. Just a note on this, the value returned is a float instead of an integer. Now let's cover multiplication. I change the forward slash to a star sign that represents multiplication. I type 25*5. I click on the run button and get back the value of 175. That was a short introduction to the math operators. Next, you'll explore logical operators. Logical operators are used to control the flow of your application. The logical operators are AND, OR, and NOT. Let's cover the different combinations of each. In this example, I declare two variables. A equals true and B also equals true. From these variables, I use an if statement. I type if A and B colon, and on the next line, I type print, and in parentheses and double quotes, I type all true. You'll learn about the if statement shortly, but for now, just know that this print statement will only be executed if both A and B are true. The print statement of all true is displayed in the terminal. If I change the value of B to false and I run the statement again, nothing gets printed out. The reason for it is that the AND statement as a condition needs both A and B to be true so that it will print out the statement. Now let's cover the OR operator. So I'm changing AND to OR and I click on the run button. The all true value has been printed out again. The reason for it is that with the OR operator, if either A or B is true, the if statement is true. If I set the values of both variables to false and click on the run button, nothing gets printed out. This is because A is false and B is false, so the condition in the if statement has not been met. In this last example, I'm going to demonstrate the NOT operator. I'll keep the OR operator. Before OR, I type if not A in parentheses, then OR, then not B in parentheses, followed by a colon. I click on the run button and the value returned is all true. And what that's doing is it's looking for a negation against A, so not A is not false, which is true, and the OR, a negation of B, which results in true. The OR condition checks to see if either is true. Now I change the A and the B to be true. I click on run and nothing gets printed out. The reason for that is that it's checking again for if not A, essentially if A is not true. In this case, A is true and its negation is false, so it's not going to meet that condition. Or not B also results in false and does not meet that condition as well because both are the negation of true. This is still not going to print out any value because, again, none of the conditions are being met. And that's a brief introduction to using both math and logical operators in Python. Congratulations. In this video, you learned about math and logical operators. Great job. If you'd like to learn more about math operators in Python, there's an additional reading at the end of this lesson. In programming, it's important to understand how to control the order in which your code is executed. For example, suppose you're invited to an event. You have to consider whether you need to dress formally or informally. Another example of a control flow is to consider a light switch. The flow is represented by the electrical current and the control as the switch itself with the two states of on and off. The order in which you make decisions matters, and the same applies to writing effective programs. In this video, you'll learn how to use conditional statements to control flow in Python programs. So, what is control flow? Control flow refers to the order in which the instructions in a program are executed. All programs have decisions that need to be made. As a result of this, the program will take different actions or directions. In Python, there are two types of control flows. First, you can use conditional statements such as if, else, and elif, or else if. And second, you can use loops such as the for loop and the while loop. Let's explore these a little further now. The if keyword states that if the condition proves to be true, a function is performed. The else keyword catches anything which isn't caught by the preceding conditions. The elif or else if keyword is Python's way of saying, if the previous conditions were not true, then try this condition. The for loop checks for specific conditions and then repeatedly executes a block of code as long as those conditions are met. The while loop repeats a specific block of code an unknown number of times until a condition is met. Let's explore conditional statements in more detail with some practical examples using the if, else, and elif. I'll now write some code for a restaurant that wants to apply different discounts based on the amount its customers spend. To start off, I define a variable for the customer's bill. I'll call it bill total and assign a value of 114 to it. Now I apply a condition with an if statement. If bill total is greater than 100, print the statement bill is greater than 100. Next, to apply a discount to bill total, I need to create a second variable. I'll do this above the if statement in my code, call it discount1 and assign a value of 10 to it. The condition also has to change. So inside the if statement, I add bill total equals bill total minus discount1. At the very end of the code snippet, outside the if statement, I'm going to print out what the value of the total bill is. To do this, I type a print statement that says total bill and then a plus sign. To add the value of bill total here, I need to convert the integer to a string. I use the str typecasting function to do this. Let's click on Run. Great. In the terminal, two strings are printed. Bill is greater than 100 and the total bill is 104. But what happens if the bill is less than 100? I change the value of bill total to 95 and press Run. Notice that this time, because the if condition is not met, it only prints the statement total bill is 95. But I'd like to print a statement that says the bill is less than 100. To do this, I add an else statement below the if statement. I type else, colon, and in the next line, I print the statement bill is less than 100. Let's run the code. The output in the terminal now says bill is less than 100 and total bill is 95. Up to this point, you've learned how to use the if and else statements to control the order in which values are assigned and printed. You are now ready to take program flow one step further. Say this restaurant wants to add another discount for bills over 200. How would you do that? Once again, I first need to create a new variable above the condition that I name discount2, which I set equal to 20. If I run the code now, it will still print out the same output because I haven't changed any of the conditions or values yet. Let's change the value of bill total to 210 and click Run. Notice that both statements are printed, but discount1 is still applied. It's clear that the if statement is still executed. Since the value is 210, the condition is still met. To change the program flow for values over 200, I need to add an AND condition to the if statement. I change the statement to if build total is greater than 100 and build total is less than 200. Let's run the code and see what happens. Now the discount wasn't applied. The output just says build total is 210. Why? Because the condition is not met. Now this is where it gets really interesting. To add a second condition for builds above 200, I'll use an else if statement. In between the if and else statements, I type elif, which stands for else if, and then build total is greater than 200. Print the statement bill is greater than 200. In the next line, I apply the new discount. I type bill total equals bill total minus discount 2. First, let me clear my screen so you can focus just on the results. Now I press run. Notice how the program flow has changed. The first condition was not met, so the code went to the second condition where the value of bill total was compared to 200. And since it was greater than 200, the statement bill is greater than 200 was printed. The code then proceeded past the else condition because the previous elif condition was true. Remember, the else condition only executes if none of the preceding conditions are true. Finally, it printed the statement at the end of the code snippet, namely, total bill is 190. This proves that discount 2 was applied. Congratulations! You now know how to control program flow with if, else, and else if. Once you become proficient in using conditional statements, programming becomes a lot of fun. I encourage you to test it out. In this video, you learned how to use conditional statements in Python. Writing conditional statements is an essential part of programming, and I encourage you to practice them in your code. The next time you need to make a decision, think about the conditions involved and how they can be represented if you were to code them in Python. You may recall how to use the if, else, and else if statements to test a variable against a few conditions. But on some occasions, you will have to test a variable against many conditions. To deal with this, you can use something called a match case statement. In this video, you'll learn how to use a match statement as an alternative to an if statement. Now let's consider an example to compare the match statement to the if statement. Say you want to write code to print HTTP error messages according to error codes. To do this with the if statement, you would have to write the if condition, all the alternative if-else conditions, and finally an else condition. Conditional statements like if, elif, and else work well over a small number of conditions, but over a large number of conditions, your code can get large, complex, and messy. Fortunately, there is a cleaner way to achieve the same result using the match statement. The match statement in Python was introduced in version 3.10. Using the match statement, you can achieve cleaner, more readable code that allows all the same functionality as the if controlled statement. When using match statements, there are a few things to remember. You can combine several conditions by using the OR operator in the conditional statement. The default is essentially the final outcome if nothing is found in the case checks. It's the equivalent to the else in the if blocks. Let me demonstrate this example now using VS Code. Okay, so I've written a simple if statement that checks for an HTTP status code. If the value of the variable HTTP status matches one of the conditions, it will print out the equivalent message. I'm now going to add a match statement below the if statement. For a clear comparison, I will test the same variable against the same values. I type match and then the variable HTTP status and a colon. On the next line, I type case, which is the equivalent of the word if and the value of 200. On another line, I repeat the action used in the if statement for 200, which is to print the word success. So in other words, the variable is matched against the value of 200 and the if values are equal. It will print out the word success. Notice that the value of HTTP status is indeed 200 at the moment. So let's run the code to test how the if and match statements are processed. In the terminal, the word success is printed twice because the value of HTTP status is matched twice in my code run. once for the if statement and once for the match statement. Now let's change the value of HTTP status to 201 and run the code again. In this case, success is only printed once. Why do you think that happens? Because there is an OR condition for the value of 201 in the if statement, but none in the match statement. To do the equivalent in the match statement, you use the OR operator. So I place my cursor in between 200 and the colon and add an OR character and the value of 201. I clean my screen by using CLS and then click on Run again. Now success is printed twice again. So in the match statement, the pipe command is shorthand for if, or. The great thing is that you can add many case statements in a match statement. But what if none of the values match the variable's value? Now let's change the value of HTTP status to the value of, say, 550 and explore what happens. I click on Run, and this time the word unknown is printed. You may be wondering why that is. Because the else statement is like a catch-all. If the value does not match anything within the if or the elif statements, the default will be the else statement, which in this case has a print function for the word unknown. Well, the match statement also has a default class, and you add it by typing the word case _ colon, and on the next line print unknown. Let's run the code again. Great, the output is unknown, which means that the default statement in both the if as well as the match statement was actioned. My match statement is coming along well, but it still needs a few tweaks to make it act exactly like the given if statement. To do that, I'll add a few more case statements that will test for the same values as the elif statements. I type case 400 colon, and then I add a print command with the words bad request. I add another case and the value of 500, and I also need to test for 501 like in the elif statement above. So once again, I add an OR character and type 501 colon. On the next line, I add the error message that I want to print, which is server error. The match saves a bit of space by combining the OR statement, so you don't have to do a comparison against a variable each time like in the if statement. Let's change the value of HTTP status one more time to 501. I just clear the screen again and click on Run, and server error is printed for both statements. Now you know that there are some differences between the two, but the match statement does exactly the same as the if statement. In summary, the match statement compares a value to several different conditions until one of these conditions is met. So you now know how to use the match statement as an alternative to the if statement to test a variable against many possible values. The match statement is relatively new to Python. Prior to version 3.10, developers had to get creative and code their own solutions. You'll learn more about those alternative methods later in this lesson. Have you ever come across a song that you like so much you want to listen to it again and again? You select the loop option so that you can listen to it repeatedly. This action of repetition is known as looping and also exists in Python. In this video, you'll learn to use looping constructs when the same set of steps must be carried out many times. Python has two different types of looping constructs for iterating over sequences, the for loop and the while loop. Looping is used to iterate through the sequence and access each item inside the sequence. Let's start with a basic example of looping using a string. First, you declare a variable called str, which is of type string. Recall that a string in Python is a sequence, which means you can iterate over each character in the string. A sequence is just an ordered set. Now let's break apart the for loop and discover how it works. The variable item is a placeholder that will store the current letter in the sequence. You may also recall that you can access any character in the sequence by its index. The for loop is accessing it in the same way and assigning the current value to the item variable. This allows us to access the current character to print it for output. When the code is run, the output will be the letters of the word looping, each letter on its own line. Now that you know about looping constructs in Python, let me demonstrate how these work further using some code examples to output an array of tasty desserts. Python offers us multiple ways to do loops or looping. You'll now cover the for loop, as well as the while loop. Let's start with the basics of a simple for loop. To declare a for loop, I use the for keyword. I now need a variable to put the value into. In this case, I am using I. I also use the in keyword to specify where I want to loop over. I add a new function called range to specify the number of items in a range. In this case, I'm using 10 as an example. Next, I do a simple print statement by pressing the enter key to move to a new line. I select the print function, and within the brackets, I enter the name looping and the value of I. Then I click on the run button. The output indicates the iteration looped through the range of 0 to 9. It's important to note the 3 main points. The iteration starts at 0 based on the index of the item itself. Every for loop usually starts with 0. Most arrays start at 0. The reason for that is that it's the first item in an array or the first item in the index. In this case, the last item in the array or index will be 9. Now I want to change what I loop through. As an example, I'll enter a simple array above and call it favorites. To do this, I start by removing the hash sign in front of favorites. Next, I replace the range function in the current for loop with favorites to loop through. The I that I declared as part of the for loop can change to any value, and in this case, I'm using item. I now change my print statement to include item in my print loop. I also change the text to I like this dessert. I click on the run button to print the value stream. In this case, item calls each of the 5 desserts titles in turn, and our print statement combines them into a sentence. The next looping option I'm discussing is the while loop. The while loop differs slightly from the for loop. To demonstrate this type of loop, I first comment out the for loop on my screen. Let's start by using the while keyword. As in the for loop, I need to specify a condition to make the loop over n times, depending on the value itself. First, I need to declare a counter. I do this by typing count equals 0 above my looping statement. Next, I enter count after the while keyword, followed by the less sign and the word favorites. Now I insert the function len to provide the length of favorites. This means the loop will run while the count is less than the length of favorites. In other words, while it is less than 5. To print the value of the looping statement, I press the enter key to move to a new line. Then I select the print function, and within brackets, I enter the text, I like this dessert. The key difference here is that I need to use the index to access the items within the favorite array. To do this, I type favorites and add count to represent the index. It's important that I now increment count so that it will essentially match the loop statement. If I do not increment count, I'll end up with what is called an infinite loop. This means it will just keep looping and looping until the compiler stops it from running out of memory. To increment the count, I press enter to move to a new line and add count plus equals to 1. I clear my screen and click the run button. I get the same print output as the for loop. It's important to note that in a standard for loop, I don't have access to the index, but I can use the enumerate function to do that. So I change my current for loop statement by adding idx, and it becomes for idx item in. Then I call the enumerate function with favorites in parenthesis. On the next line, to print the output, I replace the text I like this dessert with idx and click the run button. The results display the index and the value of the item within the array. Congratulations! In this video, you learned about looping constructs in Python using the for loop. In Python, nested loops can be used to solve more complex problems. For example, the nested for loop is written by indentation inside the outer loop. Let's explore this further now and break down how a nested loop works. First, the outer loop will start and then step into the inner loop. Then the inner loop will run until its range limit is met, 10 in this case. Once the inner loop completes, it will come back to the outer loop for the next iteration and then step into the inner loop again. This will happen until the outer loop has reached its limit. Now let's explore an example using nested loops to iterate over 2 lists. For example, suppose you have 2 lists of integers from 1 to 9 and a count variable that is set to 0. You again have 2 loops, the outer loop which will iterate over list 1, and the inner loop which iterates over list 2. If you run this code, it gives an output of 90. Let me break it down for you. The outer loop runs a total of 9 times. The inner loop runs a total of 9 multiplied by 9, which is 81 times. And 9 plus 81 gives a total of 90. To help visualize how this would look, you can make some minor changes to the loop to output what it looks like. Okay, so you now know that the number of times a loop is run is based on the size of the list. Now that you've learned about nested loops, let me demonstrate some code examples of nested loops. So I have VS Code open, and first let me start with a simple example and write a for loop. I type for I, and I use the range function, so I have in range 10. Above the loop, I label it with a comment outer loop. This first for loop is considered an outer loop, and inside I will have an inner loop. I write a comment inner loop right under the first for loop. Now I type for j in, then I use the range function again, and I pass in a 10 and end with a colon. The 10 indicates the number of times the loop will iterate or repeat. In this example, I print out 0, and then I use end equals and a string with space in double quotes to ensure it prints out in an even manner. And lastly, I'm going to print out an empty line so that it goes to a new line in each iteration. If I run the for loop, the system prints out a 2D array grid. This is just to demonstrate how the for loop works. If I want to print out a single line, I can change the outer loop to 1. I clear my screen, run it again, and this time a single line of zeros is printed out because the outer loop only iterated once. This is all based on the outer loop only. It runs once, but when it goes to the inner loop, that it runs 10 times and prints out a 0 for each item on the same line. Every time the outer loop starts, it will go into the inner loop. The inner loop must finish before it comes back to the outer loop to start on 2, 3, 4, and so on. I can showcase that by simply changing the outer loop range to 2. In this case, only 2 lines are printed. So the first when I equals 0, it comes into the inner loop and prints out 10 times. When that's finished, it comes back to the outer loop. Then I is incremented again to 1, and then it'll be printed out from J's inner loop and another 10 zeros again. The other issue to consider with nested loops is the complexity, or what is commonly known as time complexity. The larger the array, the more time it's going to take to run my code. Let me showcase this by running a for loop for a larger range, but also putting a timestamp on it. I import the time module to put a timestamp in what's printed out. I class it as the start time equals time.time, which is the function that I want to call. The start time is initialized the moment I run the script. I also want to print out how long it took to finish. I do that by putting a print statement outside the for loop. I then calculate the time as in the time it took to finish and then subtract that from the start time above. This is going to print out many decimal places, so I use another function named round, which rounds numbers to a decimal of my choice. In this case, I round it off to 2 decimal points. Let me clear my screen one more time. I click on Run, and it outputs the time of 0.0 seconds. This makes sense because the time my code takes to run is really short. Now let me increase the range in the outer loop to 100, and I also increase the range in the inside loop to 100, and I click on Run one more time. The time now goes up 0.01. In this case, it's not a big difference, but when you're dealing with large data sets, this will have a huge effect on the running time of my code. This time, let's say, for example, that I keep the outer loop to 100, but I increase the inner loop to 1000. I clear the screen and click on Run. The time increases to 0.04. If I increase the inner loop one more time to 10,000, and I clear the screen and click Run, now the time goes up to 0.45. So the larger the array or the larger the range, in this case, the more time it's going to take for a program to complete. It's always important to remember how you can optimize code to make it run more efficiently, and consider the amount of time your code will take to run. You just covered nested for loops and learned about the issue of time complexity. In this video, you learned about nested loops and how they work. Congratulations on reaching the end of control flows and conditionals and the end of the module on getting started with Python. Let's recap what you've learned. So now you know how to explain the history of programming and how it works in a general sense. Describe the benefits of Python and where it's used. Evaluate if your system is set up correctly for Python development. Identify the differences of running code from the command line via the IDE. Explain the importance of syntax and space in Python. Describe what variables are and how they are used. Identify data types in Python. Explain how to declare and use strings. Describe the two types of casting and how to apply them. Describe the basics of user input and console output. Recognize math and logical operators in Python. Use conditional statements to control the flow of programs. Use match case statements as an alternative to if statements. Explain looping constructs and how to use them. And explain nested loops and how they work. You've learned a lot about the structure and rules that guide Python, and now you're ready to create programs. Great work. See you next time. So, what are functions? At the most basic level, you can think of functions as a set of instructions that take an input and return an output. For example, the primary task of the print function is to print a value. This value is usually printed to the screen, and it's passed to the print function as argument. In the example we have here, the string hello world is the value passed to the print function. By the end of this video, you'll be able to declare a function in Python, pass data into a function, and return data from a function. A Python function is a modular piece of code that can be reused repeatedly. You've used some Python functions already in this course, such as print and input. Both are functions, and each one has a specific task or action to complete. The input function will accept parameters too, but will also accept input from the user. So, how do you declare a function? A function is declared using the def keyword, followed by the name and task to complete. Optional parameters can also be added after the function name within a pair of parentheses. Here's an example of creating a function to add two values. Type the def keyword, followed by the function name of sum, then enter x and y as parameters. And finally, enter return x plus y as the task to complete. I'll now give a practical demonstration of functions, how to declare them, how they're used, and how they can also simplify your code by putting it into a reusable structure. Let's start with a short example that explains how to calculate a tax amount for a customer based on the total value of that bill. I'll start by declaring two variables. I type the first variable called bill, and I assign it the number, let's say 175.00. I know this is going to be a data type known as floats because I'm using decimal points, as is the norm for currency. The second variable is the tax rate, which is the percentage tax rates that should be applied to the bill. So I put in 15, and then what I want to do is calculate the amount of tax for the bill itself. What I do is add this into another variable called total tax. I then do the calculation, which is the bill multiplied by the tax rate and then divided by 100 to get a dollar amount. To output the value, I print the total tax and pass the total tax variable and then run the program. Total tax is 26.25, which is 15% of 175. In the real world, the bill value will be different for each customer, and the tax rates may also change. Updating each variable every time is inefficient. To overcome this problem, I'll create a reusable function. To start creating a function, I use the define command, or def for short. Then I'll give it a name that relates to the task it's carrying out. So in this case, it's going to be calculate tax. With functions, you can pass in arguments, and the purpose of that is to make it more dynamic. So consider the arguments that I need to take in. I'll take in a bill, which would be the total value of the bill itself, and then also a tax rate. And then, like I've done before, I will calculate the total tax by taking the bill, multiplying it by the tax rate, and then dividing it by 100. Okay then, I do a return, wrap bill in parenthesis, multiply it by tax rate, and divide by 100. Now I can remove the declaration I made earlier for the variables and the calculation. With a function, if you run the current code as is, it will come back with nothing because a function is only ever run when it's actually being called. I'll demonstrate this. If I do a print, I can calculate tax and then I pass it as I've done earlier. 175 is the total bill, and then the tax rate will be 15. I'll also put in just a total tax and then click on run, and the total tax rate is 26.25. If I want to change the rate, I can reuse the same function, total tax. I'll call the function again, calculate tax. I'll give it a different value for a bill, say 164.33. This time I'll change the tax rate to 22%. Clear the screen, and then click on run, and my total tax for the second item is 36.1526. To clean the output up a bit and make it more visually appealing, I'll put in a round function which allows control of the number of decimal places that I want returned. In this case, I'll do 2 and then rerun the code. This is a lot neater with 36.15. One of the nice things about a function is that you can update it once, and any part of the code that calls that function will get those changes as well. In this video, you've explored basic functions in Python, how to declare functions, and pass and return data to and from them. The concept of scoping in Python allows for greater control over elements in your code, which reduces the chances of accidental or unwanted changes. By the end of this video, you'll be able to understand the basics of scoping in Python and identify the 4 types of scope. Before you explore scope and its intricacies, it's important to know that Python has different types of scope. You'll examine each one in detail, and I'll demonstrate them with coding examples. In order of ascending coverage, the 4 scopes are local, enclosing, global, and built-in. Together, they are referred to as LEGB. Variables within the built-in and global scope are accessible from anywhere in the code. For example, if there's a variable A in the global scope, it can be called in code at the local level. The purpose of scope is to protect the variable, so it does not get changed by other parts of the code. For instance, let's say you've declared variable B in the enclosed scope and variable C locally. While B can be called in local code, it doesn't work the other way around. As a rule, global scope is generally discouraged in applications as it increases the possibility of mistakes in output. Now I'll explore using the 4 different types of Python scopes in this practical demonstration. The first one I want to use is global scope. I declare a variable called myGlobal and then give it a value of 10. So the next thing I do is declare a function and I call it fn1. And inside this function, I'll declare another variable, which I'll call local variable or local v, and give it a value of 5. To show that my global variable is accessible from anywhere, I can do a print statement, say access to global, and then print out the value of the myGlobal variable. And if I want to run that function, I need to specifically call it, so fn1. Click on run, and then the value of 10 is printed out for the global variable. But if I try and print out the local variable inside fn1, outside the function, it will return an error. So I access to local and then put out local underscore v. I then clear the console, click on run, and I get an error saying name error. Name local underscore v is not defined. That's because it's only accessible from within the local scope of the function fn1. Next, to illustrate an enclosing scope, I'm going to declare a second function inside fn1 called fn2. I then declare an enclosed variable, which I call enclosed v, and assign it the value of 8. The local v will be local to the fn2. I'll now explain how enclosed scope works. Within fn2, I've got access to the enclosed v, which I can demonstrate by doing another print statement and printing out the enclosed v variable. I'll just test that this all works by calling the fn1 function and then making sure that I call our fn2 function inside fn1. I must physically call a function to make it run. So I clear the console, click on run, and then print out access to global 10 and access to enclosure 8. The way scoping works is that the innermost function has access to almost everything from the outside. You can access the enclosed variable at this level, and then also access the global variable at the outer level. The same rules still apply from the outside. So if I try and access the variable of enclosed v, or try and access the variable of local v, I get the same error that the variable enclosed v is not defined. The nested items have access to both the global and the enclosed, but from the outside, it can't be accessed from a nested or an enclosed scope, both for local and enclosed. The last scope is built-in scope, which you've been using when writing code in Python. Built-in scope refers to what's called the reserve keywords, such as print and def. Built-in scope covers all the language of Python, which means you can access it from the outermost scopes or the innermost scopes in the function classes. That's a brief demonstration of scope in Python, including examples of global, local, enclosed, and built-in. By completing this video, you've gained a broad understanding of why scoping is important in Python programming, and you are now able to identify the 4 types of scope. Lists are a sequence of one or more different or similar data types. A list in Python is essentially a dynamic array that can hold any data type. Let's move to the console and I'll demonstrate some practical examples of Python lists. First, I'll go through a few examples of declaring lists. So I create my list by typing list1 equals and then the numbers 1, 2, 3, 4, 5 within brackets and separated by commas, because you use commas to separate items in a list. List2 is a list of strings A, B, C. I can also have a list of different data types. For example, in my list3, I can have a string, an integer, a boolean, and a float. So the type doesn't necessarily matter. It's just going to be stored in the same way. One thing to keep in mind with lists is that they are based on an index. For example, let's suppose I wanted to access the number 3 from my list1 example. Since the index always starts with 0, I'd have to write list1 open square bracket 2 close square bracket. This gets the third item in the list, which is number 3. So if I do print that, I get the value of 3 being printed out. An important option with lists is that you can also have nested lists. So if I declare another list, for example, list 4, and I put in 1, and then I can have a nested list of 2, 3, and 4, and then get back to a 5 and 6. That's completely valid as well. So any data type can be stored within the list itself, just to keep that in mind. Let's see what else lists can do. I've got a few different options to add items to a list. One is to use the insert function. So just before I do that, I'll just do a print. To print out the entire list, there are a couple of different ways I can do it. I can use the *sign list1, click on run, and I get the entire list printed out. To print it the way it is displayed in my code, I can use the print statement type in list1 and just put in a separator, equals, and then comma, or just single space. I click on run and I get this type of print returned. Right, back to adding something new to the list. The first option that I have is what's called the insert function. I can do list1.insert, and what it looks for is the index of where to insert to. Here I can use the len or len function to get the length of the list1. Then I put in what the next value should be. So in this case, I put in number 6. I do the same print statement directly underneath that. Then click on run, and I find that I get 6 added to the end list. I can also use another function called append. Instead of having to specify the index or where the item should be placed, I can just put in the append keyword. So I type append 6 and click on run, and it's added in without having to specify the index. There is another function I can use if I want to add one or more items to the list. It's called extend, and this will accept a list as well. I can put in extend 6, 7, 8, 9, and then click on run, and then my list is extended with 6, 7, 8, and 9. To remove something from a list, there are a few different options. The first way is to use pop and then specify the index or location of which item I want to remove. To demonstrate pop, I'll say pop4 for index 4. I click on run and the last item from the list is removed. Remember, within a list, the index always starts at 0. So index 4 means the fifth item being the value 5, and that's what has been removed. Another option is the delete or del keyword. I can say del list 1 and then specify the index to delete. In this case, I put in the index of 2, click on run, and the index 2 is removed, which in this case is the number 3. 0, 1, 2 is the number 3. Lastly, I can iterate through a list. One of the main reasons I use lists is that I can iterate through the values and gain access to large amounts of data. So to iterate, I can use a simple for loop. So for x in list 1, and then I can do a simple printout. I'll just remove this one underneath. I'd like to print out the value of x, so I just put in print value and then x. When I click on run, it'll print all values of the list. That's a brief demonstration of what you can accomplish using lists in Python. You just covered how a list in Python works as a dynamic array. You explored lists and learned how to use inbuilt functions of a list to access the list items, modify them, add to the list, and remove items from the list.
In this video, you will learn about tuples and how they can be used to store different types of data. They are used as data structures and help to create solid, well-performing code. To declare a tuple, I declare a simple variable. I'll name it my_tuple, and then I do the assignment operator of equals. Then, to declare the tuple itself, I use parentheses. A tuple can accept any mix of data types, and it can range from integers, like 1, to strings, to a double, such as 4.5, to a boolean, like true. To access any of the items within the tuple, I can use methods similar to those used with a list by referring to an index. So, in my_tuple, if I want to get access to the string, which I know is going to be on index 1, I just print out the value. So I write print my_tuple brackets 1. Remember, index always starts with 0. I click on run, and I find that it returns the value of strings. If I want to determine the type of the tuple, I can use the type function that Python provides. I click on run, and I get a class tuple. We could also declare a tuple without using the parentheses. It has the same effect and will still be classed as a tuple. However, it's best practice to use the parentheses. Tuples also provide different methods of count and index. I can do my_tuple.count and pass in the value of strings. I click on run and I get back the count of 1. What it does is it looks for the number of occurrences of that value within the tuple. Before I move on, I'll type clear into my terminal to clear the previous output so we could start fresh and see what's going to happen next. The other method is index, which should give me back the index of where the value lies in the tuple. I'll change the print statement to look up the index of the double 4.5. When I click on run, I get back 2. This means that the double 4.5 is at index 2 in the tuple. I can also do a loop on a tuple. That is, iterate through the values and print them out. I can write a loop for x in my_tuple and then print out the value of x. I click on run and I get back 1, strings, 4.5, and true. So all of the values of the tuple itself. The one key difference of a tuple over a list is that tuple values are what's called immutable, and this just means that they cannot be changed. So I'll prove this and demonstrate how this works. Let's say that I want to change the value of the very first item in the tuple being the value 1. I'll use 0 to access it based on the index, and let's say that I want to change it to be 5. If I run this, I'll get back an error, and it gives me the error saying, type error, tuple object does not support item assignment. That's because anything that is declared in a tuple is immutable. In this video, you learned about tuples, including how to declare them and work with their contents. In this video, you will learn about sets and how they can help with storing certain types of data in different types of formats. First, I declare a set. I can start by declaring a simple variable called set A equals, and then use curly braces to define the set itself. Then the values go inside the brackets. I put in 1, 2, 3, 4, and 5. I'll do a simple printout to prove that we have a set. I click on Run to get the values 1 to 5 printed out. Sets differ slightly from lists in that they don't allow duplicate values. I can demo this by putting in another 5. When I click on Run, I find that the second 5 is not printed out in the list. Sets also have methods that we can use. I can use a method to add new content. If I use set.add6, I can add in the number 6. I click on Run to find that the value 6 is added to the set. I can also use the remove method. I'll remove the number 2. When I clicked on Run, I found that the number 2 was removed from the set. There's also discard, which essentially does the same thing as remove. Using discard, when I click on Run, I'll find that I get the same output. Let me clear the console before we go any further. There are also a few useful methods that could be used with sets to perform mathematical operations. Let me demo some of them now. First, I will create a new set, set B. I will put in 4, 5, 6, 7, and 8, and reset the values of set A to the original values. There are two ways I could use mathematical operators. For instance, for a union join, I can do set A dot union and then pass in set B. Then I can click on the Run button to see what happens. I discover that it joins the two sets together minus the duplicate values like 4 and 5. Union merges them into one. So you have a set 1, 2, 3, 4, 5, 6, 7, 8. For the other options for union, I can use the vertical line symbol or the OR symbol, and that works in the same way. Let me clear the console before we go on. Another operation I can use is the intersection. I can apply this to set A by writing set A.intersection and passing set B as the argument. When I click Run, I get back all the items that match in both set A and set B. Here we have 4 and 5. The intersection can also be represented by the ampersand and will work in the same way. When I click on Run, I also got back 4 and 5. Let me clear the console again before we continue. Another mathematical operation I can use is the set difference. To use this, I'll print set A dot difference set B, and this should give me back all the elements that are only in set A and not in set B. When I clicked Run, we got the correct output of 1, 2, and 3. I could also represent difference by using the minus symbol. When I click on Run, I'll also get back the same values. 1, 2, and 3. The last operation I'll discuss is what's called symmetrical difference. This is represented by the symmetric difference function, which is used in a similar way. When I click on Run, I get back 1, 2, 3, 6, 7, and 8. In other words, all of the elements that are present in set A or set B, but not in both sets. Symmetrical difference can also be represented by the caret operator. When I click on Run, I get back the same values. An additional important thing about sets is that a set is a collection with no duplicates, but it's also a collection of unordered items. Unlike a list where I can print out content based on index, if I try to print out set A brackets 0 to get the 0th element in the set, I'll get an error. Let me clear my console before we attempt to print this output. When I click on Run, I get back a type error saying that the set object is not subscriptable. This means that the set is not a sequence. It doesn't contain an ordered index of all elements inside. Okay, that concludes our gentle introduction to sets. Great job.
So, what is a dictionary in Python? In many ways, it's very similar to how an actual dictionary works. In a normal dictionary, to locate a word, you look it up by the first letter and then use the alphabetical ordering system to find its location. Likewise, Python dictionaries are optimized to retrieve values. You may remember how useful Python lists are to access an array of values. Dictionaries access values based on keys and not an index position. Therefore, they are faster and more flexible in operation. By the end of this video, you'll be able to explain the purpose and function of dictionaries in Python and identify the performance benefits of dictionaries. With a Python dictionary, a key is assigned to a specific value. This is called the key-value pair. The benefit of this method is that it's much faster than using traditional lists. To find an item in a list, you need to keep reviewing the list until you locate the item. But in a Python dictionary, you can go straight to the item you need by using its key. A dictionary is also mutable in that the values can be changed or updated. For example, you could declare the number 1 as the key and coffee is the item, and then change these to any other number or drink item. But how does this work? How do you access or locate the item you need within a Python dictionary? With the use of the keys. To demonstrate this, I'll access the coffee item within a Python dictionary. First, I declare my dictionary name as sample dictionary, then an equals with a series of key value pairings or keys and items in a pair of curly braces. I also make sure to separate each pairing with a comma. I then type the print function, followed by the name of my dictionary. I need to access coffee item, which has been given a key of 1. So I insert the number 1 in square brackets. I run the print function and it returns coffee as a result, just as I intended. I can also update a dictionary by replacing one item with another. I just need to use the key to reference it while using the assignment operator of equals to assign the value. For example, I can change item 2 in my dictionary from T to mint T. I just write a new line of code that starts with the name of the dictionary followed by the key I want to change in square brackets. Then I add an equals operator followed by the name of the new item. What the coding says is to take item 2 in the sample dictionary and change it to mint T. When I run this function, it changes the item. I can also delete an item from the dictionary. To do this, I write a line of code with the delete function followed by the name of my dictionary. Then I add the key for the item I want to delete in square brackets. In this instance, I want to delete item 3, juice. When I run this delete function, it will remove the juice value from my dictionary. Finally, I can also use 3 different methods to iterate over a dictionary. I can use the standard iteration method, the items function, or the values function. Let's explore these iteration methods and the other dictionary operations functions in more detail. To create my dictionary, I'll start by declaring a simple variable called my_d, and then use the assignment operator and then curly brackets. It can be the same as a set, but by default, that's classed as an empty dictionary. I can print that out by using a print statement, using the type function, and then passing in the my_d variable, clicking on run. The class has actually come back as a type dictionary. So next, I'll add some values into the dictionary, and I need to do it in 2 parts. A dictionary holds what's called a key and a value. The key can be numeric, it can be string, but to signify the assignment, I use a colon and then put in whatever value that I want. In this case, I'll put in a simple string value of test. To signify that I can change or have different keys, strings, integers, or ints, I put in a string key of name and then the value Jim. I print out my dictionary using the print function. I now have a basic dictionary setup with a key of 1, name, and then 1 being test, name being Jim. If I want to access a key in the dictionary, I just have to use the square brackets and then pass in the key value. So in this case of 1, I'll pass in the numeric 1. In the case of the string value, I just need to pass in the actual string value itself, so name. Click on run and I get back both test and Jim, which are the values for each corresponding key. If I want to add a new key into the dictionary or update it, I can simply do my D and then add a new assignment, 2 in this case. Test 2, click on run. The key is then added with the current dictionary. To update a key, I have to call out the value that I want. I'm just going to update the first key, which is number 1 with a value of not a test, instead of test. Click on play and it's updated on the screen. The other thing to note about the dictionary is that if I try and put in a duplicate key, it doesn't allow this. So if I put in a number 1 and then not a test, click on run, and the key will actually be overridden with the latest one. So number 1 only appears once in the output and it doesn't allow the 2 keys to be printed out, because it won't allow duplicate values to be set. If I want to delete a key from the dictionary, I use the del operator. Now I type my D and then specify which key I want to delete. In this case, number 1. It's then removed from the dictionary. With a dictionary, I can also iterate though. For example, I can use the for x in my dictionary and then print out the value of x. Click on run and I get 1. This only prints out the keys. In a lot of cases, I may need access to both. To do that, I use a method called myItems. With that, I can then gain access to the assignment of both the key and the value. So I do a printout here, key plus value. I'll use some concatenation to print out both the key and the value. Click on run. I have to be mindful because I'm using an integer with a string. So I wrap that with a type str, click on run again, and I get the value of the key and the value for each of the items in the dictionary itself. You should now understand the purpose and function of dictionaries in Python and their benefit in terms of performance.
In this video, you'll explore args and also kwargs, or keyword args. Using these has the advantage that you could pass in any amount of non-keyword variables and keyword arguments. To start with the short example, I'll define a sum of function that accepts 2 parameters, a and b, and then return back the addition a plus b. If I do a print statement, call the function sum of with the 2 values 4 and 5, I should get back the value of 9, which I do. That all works fine, but let's say I want to add in another value, 6 for example. If I click on run again, I get back an error, and it tells me that the sum of function takes 2 positional arguments, but 3 were given. If I want a way around this, this is where args are useful. To define args, I use the star symbol, and I call it args for naming purposes. Instead of passing in just 2 arguments, args will allow n arguments to come through, any number of arguments. When dealing with more than one argument, there may be many to iterate through. To calculate the total sum, I'll have a variable called sum, assign it to 0, then I'll create a simple for loop, and then I'll loop through the argument parameters that's been passed in. Then I'm going to add all the values that come in as part of args, which is assigned to the x variable using the plus equals, and then finally return the value of sum. So again, if I run the statement, I get back the value of 15. As I mentioned, you could pass in any number of arguments and the total sum should be returned for each. In this case, it's 30 with the number of arguments that have been passed through. That's a simple intro to args, so now I'll demonstrate kwargs. Let's clear the terminal and switch to my kwargs file. I'll copy the code from the args file to start. Let's say, for example, you wanted to calculate a total bill for a restaurant. A user got a cup of coffee that was $2.99. Then they also got a cake that was $4.55 and also a juice for $2.99. The first thing I could do is change the for loop. Let's change the argument to kwargs by adding another star and then update the variable in the for loop. Next, I get the key and the value, and then I extend the kwargs with the items function. And then I can simply change the sum to add all the items that are passed through on the value because adding the key makes no sense. It's just a string and it won't give you the actual value you intend to get. When I run this, I get back a value of 10.53 with a bunch of extra zeros. Now I can change the decimal place for the final return statement by using the round function, and I limit it to 2 decimal places. When I click on run again, I get back a total of 1053. To summarize, with args, you could pass in any amount of non-keyword variables. With the kwargs, you can pass in any amount of keyword arguments. That's a simple intro to both args and kwargs.
In this video, you'll learn about errors and exceptions, 2 very important aspects of learning Python as a new developer. You'll cover the difference between errors and exceptions and explore what happens when something goes wrong with your code. Errors are a part of coding and they happen for many reasons. Let's start by exploring 2 types of errors. Syntax errors, which are caused by human error, and exceptions, which are known errors that need to be handled. Syntax errors are usually caused by the developer. It could be the result of a misspelling or a typo in the code. Generally, these types of errors have minimal impact because most IDEs, like Visual Studio Code, will warn the developer and give clues about how to fix them. A common error for new developers learning Python is not adding the colon at the end of conditions or statements. If you're using a code editor with syntax checking, errors like this may be highlighted at the point of the error. For example, a missing colon will be highlighted in the code. The output will indicate the file name and the line where the error occurred, with a caret character pointing to the error. Running the code will result in an invalid syntax error, informing that there is a syntax problem. Other common mistakes include indentation problems, which are also syntax errors. For example, if there is an indentation problem, the error code will be indentation error. The more you learn Python, the less you'll have to deal with these types of errors because you'll become better at creating and analyzing your code. Now let's move on to exception errors. They happen during code execution and they can easily go unnoticed by the untrained eye. But exceptions need to be handled by the developer. They need to deal with any potential issues in the code base to keep the application from failing. Let's explore an exception being thrown. As an example, your code can be syntactically correct, but if it attempts to divide 5 by 0, it doesn't make mathematical sense. Therefore, when you run this program, the zero division error exception is thrown. Luckily, by default, Python includes many exception errors that you can use to pick up potential issues in your code. In this video, you explored the basics of errors and exceptions, which is a step in the right direction to becoming a better Python programmer.
In this video, you'll explore how to handle exceptions in Python. You will learn how to change error messages and how to wrap your code within try and except statements. As an example, I will write a simple math function. I define a new function called divide by and allow it to accept two parameters, a and b. The purpose of this function is to return the value of the division of both numbers. So, in the next line, I'll type return a divided by b. Now, I add a print statement for the divide by function. Inside the print statement, I'll also add a new set of parentheses with the value of 40 and 4. These are the values that will be divided by the function. I click on run, and the value returned is 10, which is correct, because 4 goes into 40 10 times. Now let's test what will happen if I pass in the values of 40 and 0. Now when I click on run, I get an error or an exception. The exception in this case says, 0 division error, division by 0. It gives this error because in math, you can't divide a number by 0. You might agree that getting cryptic errors could upset users. So, the question is, how can you handle errors in a more user-friendly way? How can you prevent a user from seeing the actual exception being printed out? You do this with Python's try and except statements. Simply type try, colon, and in the next line, except, colon. You add the code that you want to run within the try statement. So, I delete the print statement at the bottom and cut the divide by 0 function. Within the try statement, I type ans equals and paste the function. Now, in the except statement, I will add my own error statement. I add a print statement for the string something went wrong. Let me just clear the terminal so you can focus on the output. I click on run, and now the error statement is printed. So, what's happening? The try statement will try and execute the code that you added inside it. If an exception occurs, it will trigger the except line and execute any code added underneath the except statement. But Python allows you to make the except statement more specific. If you want to trap the exception itself, you could add the base class exception right after except. The base class exception is used for all exceptions that are written within Python. You can gain access to the exception information by using the as e after exception. The e variable acts as an alias for the exception. I can use e to print out the exception in the print statement. So, let's edit the print statement. I add e at the end of the error message. I press run, and what happens? Our custom message is printed out, but the contents of e are also printed. So, this time it reads, something went wrong, division by 0. In Python, you could also get access to the actual type or class of exception that's occurred. To do this, I add another print statement of e dot underscore underscore class underscore underscore. I run this statement one more time. This time, the output includes the class of error as well, namely class 0 division error. Let me clear the terminal again. Let's take this one step further to provide even more specific feedback to the end user. In the except statement, I replaced the base class exception with the actual error that was printed out, namely zero division error. I will change the print statement so that it first prints the actual error by adding E at the start of the statement. And now I'll add some user-friendly text saying we cannot divide by 0. I click on Run, and now the output is division by 0, we cannot divide by 0. Up to this point, you've covered how to wrap your code with the try and except statements and how to optimize the message that a user sees. But how can you handle more than one exception without knowing what they are ahead of time? Fortunately, you can chain the except statement by adding another except statement. Say the code doesn't trip the zero division error in the first except statement. You could add another except statement that tests for a generic exception. Now I will add the base class exception. Again, I add a print statement with E and a message with some general information. I'll click on Run, and in this case, because there is still a math error, the function will still trip at the first except statement. But this gives you a good idea of how you can test for more exceptions. Congratulations! You now know how to wrap code in the try and except statements to handle all potential exceptions in your code.
File handling is an essential part of learning Python. Python has several built-in functions to create and manipulate files. File handling includes opening, reading, and writing files, amongst other operations. As a developer, you'll probably work with large amounts of data, and file handling makes that easier. This is why it's important to learn how to work with files. Whether you're working with data on your computer, on the web, or in the cloud, it will most likely be saved in some type of file. There are two file handling functions in Python, open and close. Let's explore the open function first. The open function is used for reading, writing, and creating files. The open function accepts two arguments. The first is the file name and/or the file location, and the second argument is the mode. The mode indicates what action is required, such as reading, writing, or creating. It also specifies if you want the file output in text or binary format. Let's explore the modes of file handling you can use in Python. First, you have R, which is used to open and read a file in text format, and RB opens and reads a file in binary format. You'll learn more about this later. R+, on the other hand, opens the file for both reading and writing, and W opens the file for writing. Note that W will overwrite the existing file. Lastly, A opens files for editing or appending data. Next, there's the close function. The close function is used for closing the open file connection. Note that it does not take any arguments. There is one more way to open and close a file in Python, and that's with the withOpen function. The advantage of using it is that it closes the file automatically. The withOpen function will be demonstrated shortly. By now, you understand how to open files for certain actions, but you might be wondering what the difference is between opening a file in text and binary format. In Python, you generally handle files in two ways, either in text or binary format. The text format is more user-friendly because humans can read it. You'll not be able to read files in binary format, but they are much more compact and therefore result in better performance. Now let's cover how to specify the type of file handling in Python. Python uses text as the default format for file handling, so just passing in any mode for reading or writing a file will automatically set it to a text format. To set the file handling to binary, you need to pass the letter B along with either the read or write option. For example, you write open the file name and RB to read a file in binary format, or AB to append or add to a file in binary format. You'll now explore file handling in code. First, I declare a simple variable called file and assign the open function to it to gain access to a file. But before I can use the open function, I first need to create a new file for testing. Let's call it test.txt. Inside this text file, I add a simple line of text. Hello there. Good. Let's go back to the Python file. Inside the parentheses of the open function, I can now add the first argument, namely test.txt between quotation marks, since it's a string. For the second argument, I type in the word mode, $, and then I will just use R for read, also between quotation marks. So far, the variable called file will have access to the contents of the test.txt. But to actually read the file, you need to add a readline or readlines function. Readline will just return the first line of the file, while readlines will output an array with multiple lines. Since we only have a single line of text in this file, I'll just use the readline function. I type file.readline and parentheses. I assign the line of code to a new variable named data. Then I add a print statement to print the contents of data. Lastly, I add a close function that will close access to the last text.txt file. I simply close with a set of parentheses. I click on Run, and the content of the file is printed out, namely, hello there. Next, I'll demonstrate another way to gain access to a file in Python. I'll change the open function to the withOpen function. I'll just clear the screen. To assign a variable to the withOpen function, you need to add as after the parentheses and then the variable name. Why would you use the withOpen function? The withOpen function is better at exception handling and will automatically close the file for you. Just like before, I create a second variable data, readline, and then print the content of data. I'll click on Run, and just like before, the contents of the file are printed. You've covered how to work with files in Python. This includes the built-in functions to create and manipulate files, and the functions to open, read, and write files.
In this video, you will learn how to create files in Python and explore methods of inserting content into a new file. Files are used to permanently store data. Anything stored in the variables of your code exists in random access memory, or RAM. Since RAM loses its data when the computer is turned off, it's important to be able to create files so data is available for future use or as a permanent record. In Python, we can create new files using the open function and enabling the write mode. Let's start with a short example. I'll use a with statement with the open function and pass in the following parameters. Our file will be new file.text, and we'll set the mode by passing mode equals w. Now I assign this file to a variable by typing as file. A shorthand way to assign the mode is to enter a single character that represents the mode you need. In this case, I can replace mode equal to w with just the letter w, and it means the same thing. Now that I have access to the newly created file as a variable, I can begin to add content to the file using the write function. On a new line, I type file.write, and I'm going to add some simple text. This is a new file created. When I click Run, the Explorer pane on the left-hand side of VS Code displays that my file, called newFile.txt, has been generated as a new file. Clicking once on the new file to select it displays its content and confirms that the text I pushed through using the write function is now present in the file. If I choose to write multiple lines of content to the file instead of a single line, I can use the writeLines function. The writeLines function accepts a list. A list in Python is represented by square brackets and then a comma for each line. I edit my file.write to say file.writeLines. Then, within square brackets, I add a comma after the sentence and type the next sentence. This is another line to be added. I click on Run, and the new file.txt now has the two lines created by my writeLines function. But it's not exactly the way I need it to be. Python will add the contents of the list exactly as it's specified within the list. If I want the content to break on a new line, I need to specify a new line by putting in a backslash and the letter N, no space. So, just inside the open quote of the second sentence, I add \n. Now, when I click on Run, the content of newFile.txt is more readable with each sentence on a separate line. One thing to note is that every time I run my script, it's replacing the current file. For example, if I insert the number 2 into the first line of text, click on Run, then check my text file. That has now replaced the previous file with one where I just added the number 2 in the first sentence, thus overriding the existing file with a fresh newFile.txt. On the other hand, if I want to add to the file, as opposed to replacing it each time, I just need to change the action of mode. To do so, I replace the letter W and put in a letter A, which stands for append. Now I click on Run 3 times Then I check my new file.txt to find that the contents have been added. It now has multiple lines. However, it has not pulled in exactly the way I wanted it to be. And the reason for that is I don't have a new line specified at the very beginning. So I add a \n before my first sentence. Since I need to replace the file, I change the mode back to W to ensure I am overwriting the last file. I click on Run, and that replaces the existing lines that were there. Now I want to add to the file again, so I change the mode back to Append by changing the W to an A, and I click Run 3 times. I check the file and confirm that the new lines were appended each time. The final part of my code will be to trap exceptions. Always keep in mind the necessity to deal with any exception by using the try and except statements. I add a new line above my existing code, and there I type try : As an example, I use file not found error, which is an error that occurs often. This needs 2 new lines added to the end of my code. So I type except file not found error as E and press enter for a new line. Then to print out the error, I type print error, E. Now, to force the error to happen, let's say I ask for a directory that I know doesn't exist in my current directory. So the faulty directory is called sample. I edit my code to read sample/newfile.txt. Now, I'll clear my terminal and run my screen again. I get the error generated by my print command, no such file or directory. So, take care when you are creating files that the directory where you want to place the file actually does exist. In cases like that, you must ensure the directory already exists, or create a directory from within Python and then create the file inside it. In this video, you learned about creating files within Python using the append and write modes and inserting single or multi-line content into the file.
You already know how to handle files in Python, but do you know how to read the content of a file? Being able to read files is essential when working with stored data in Python, and Python offers several built-in functions to make this easier. The 3 methods we'll explore in this video are read, readline, and readlines. Let's start with read. The read method returns the entire content of the file as a string that will contain all the characters. You can also pass in an integer to return only the specified number of characters in the file. The second method to read files in Python is readline. Let's explore this method. The readline function returns a single line as a string. If, for example, you have a file with 2 lines of text that say, this is the first line and this is the second line, the read file function will return as the output only the first line of text, this is the first line. The readline function can also include an integer argument for returning a specified number of characters on a single line. Let's say you use the same testing file, but pass an integer of 10. Your output will be the first 10 characters of the first line. In this case, the words this is and the letters th for a total of 10 characters. The third method to read files in Python is readlines. Let me demonstrate this method. The readlines method reads the entire contents of the file and then returns it in an ordered list. This allows you to iterate over the list or pick out specific lines based on a condition. If, for example, you have a file with 4 lines of text and pass a length condition, the read files function will return the output, all the lines in your file in the correct order. Files are stored in directories and they have paths. Reading files from the same directory is straightforward. You only need the name of the file. When working with different locations, however, it's important that you know the difference between absolute and relative paths. Let's start with absolute paths. Absolute paths contain a leading / or drive label. An absolute file path includes all the information you need to locate a file, whether you are in that file's directory or not. Relative paths normally don't contain any reference to the root directory and are normally relative to the calling file. A relative file path only includes the information you need to locate a file in your current working directory. I'm now going to demonstrate how you can read files in Python. I start with a simple sample txt file. It just has some text with a couple of lines that I'll use to demo some of the options there are for reading in files. I start by using with, open, and I pass in my file name, which is sample.txt. I just want to read in the contents, so I set the mode to be R, and I assign it to a file variable. The first option to read a file is to print the entire contents of the file. To do this, I use the function printFile.read, and I click on the Run button. Notice that the entire contents of the file is printed out as is. The second option allows me to print out only a certain section of the file. For example, let's say I only want to print out the quick brown fox jumps over the lazy dog. That's 44 characters. I can pass in a parameter to the read function, which tells the function to read in the first 44 characters. To do this, I enter the number 44, and you notice that it prints out only the first line when I click Run. The way this works is that it starts at the very beginning based on the index of 0, and 44 is the last character that needs to be printed out. In this way, I can control what sections are printed out. The third option I have is to read in a line. So the function I want is .readLine, and it will only take in the very first line from the file. I click on Run, and it prints out only the first line of text within that file. The fourth option is to use the .readLines function that will return a list of lines. I click on Run, and you notice that the text in the file is now wrapped in square brackets. Lastly, because it's a list, I can assign it to a variable. For example, I can say data equals file.readLines, and then I can write a for loop for x in data. I print the value of x, and then when I click on Run, you'll notice that the list items are printed out line by line. Something to note is that when you use the with open and you get as file, it returns a list by default. I can just change the for loop so that it points to the file variable. When I click Run, the same option is returned. These are just some of the methods you can use in Python for reading in files. You should now be able to describe how to read files in Python and demonstrate how to output different formats using the read, readline, and readlines functions. You've reached the end of this module on basic programming with Python. During this module, you've received an introduction to Python functions and data structures, and explored how Python deals with errors, exceptions, and file handling. Now it's time to recap the key points of this module. As with most programming languages, functions are the basis for creating actions in Python. And by completing the first lesson in this module, you should now be able to declare a function in Python, pass data into a function, return data from a function, and explain scoping at a basic level. In order to use functions efficiently across a project, it's important to determine their accessibility across different levels of code. In this lesson, you also learned how to identify the 4 scopes, describe how functions control scope at different levels, explain data structures, and describe the concept of lists in Python. Python has several built-in data structures to help you to organize and store your data for easy access, and you've learned about the most common ones. On successfully completing the second lesson, you should now be able to identify list methods, explain what types can be stored in a list, describe how to iterate over a list, and explain the main uses of tuples, sets, dictionaries, and quargs. Python file handling and exceptions were topics in the final lesson in this module. Having completed this lesson, you should be able to identify how to create and manipulate files with the open function, describe how to read files in Python, and demonstrate how to output different formats and store file contents in data structures. This module gave you the opportunity to get started with basic Python programming. Well done. That's one more step towards becoming a Python developer. Developers can structure their code in many different ways. Python allows for object-oriented, procedural, and functional programming models, or as they are often called, paradigms. In this video, I'll focus on procedural programming, which is like writing step-by-step instructions that a program executes. It's an important stepping stone to object-oriented programming. Therefore, as a new developer, it's important to learn more about it. The main purpose of a programming model is to structure your code. That structure makes it easier to update the code and create new functionality within the code. But there's no one perfect model that's a solution to coding structures, and sometimes a combination of approaches works best. Procedural programming structures code into procedures, sometimes called subroutines or functional sections of code. Because of this approach, the code is made up of logical steps to complete a specific task. For example, adding two numbers to return their sum. I can add together the numbers 5 and 10 with a short piece of code. Now I want to add together the numbers 8 and 4. However, the code I wrote was specifically to add 5 and 10. For my new numbers, I must create another similar piece of code to do the calculation. That would not be a very efficient way to code. Instead, I change the code into a function that will accept two numbers as arguments and return the sum. With this function, I don't declare the actual numbers as variables. Instead, I use the parameters a and b. Less code is needed. But something more important has happened. I now have the function called sum, which can be reused as many times as I like, with many different sets of numbers. In programming, there is a principle called DRY, don't repeat yourself, and it's all about reducing duplication in code. The original code I wrote to add two numbers together to return their sum is a good example of what not to do, because I had to write the code twice to accommodate the second set of numbers. A guideline to keep in mind is to create functions that can be reused throughout your application. Let's examine another example, this time for calculating the total of a bill and adding tax to it. The code will be presented in 4 sections to help you focus on what each procedure does. First, the bill total function accepts a bill as a parameter and loops through it to calculate the total bill and return its total. The calculate tax function accepts 2 parameters, the percentage and the bill total. Then it returns the total amount of tax to be added to the bill, which is also rounded off to 2 decimal places. The food bill, which contains its items, represents a customer's bill which is static, but could also be changed to an input to accept data from the user to dynamically create a bill. The last few sections will call the 2 functions to calculate the bill and tax, and then print each out along with the overall total. Could you identify the subroutines or functional sections of the code? And did you note how these sections reuse one another? Now, let's put the 4 subroutines together to examine the 4 ways in which the footprint of the code is reduced by procedural programming. It's best to inspect the code by starting at the end. Tax total reuses food total. Food total reuses bill total and food bill. Calculate tax reuses bill total. And bill total reuses food bill. In summary, the advantages of the procedural paradigm are: it's easy for beginners to learn and get started. Procedures can be reused by other parts of the code. Code is easy to understand because each procedure is broken into specific tasks. Procedural programming does have some disadvantages, including it can be harder to maintain and extend. In some cases, it doesn't relate well to real-world objects. Data is exposed throughout the whole program. Procedural programming has both its advantages and disadvantages. As you learn more as a new developer, you will be better able to decide if it's the best approach to a specific piece of coding or not. In this video, you'll learn about algorithms. An algorithm is a series of steps to complete a given task or solve a problem. On a day-to-day basis, you use algorithms all the time to complete tasks. One such example is following a recipe to make an egg omelette. First, you have the list of ingredients to use in your omelette. This can be called your input. Next is the method or the instructions to follow step by step to create your dish. Finally, you complete the omelette, your output. The steps to make the omelette are the same every time. An algorithm in programming works in a similar way. In programming, algorithms are used to solve a multitude of problems that range from simple to very complex. The key to understanding and creating an algorithm is to break the problem into smaller parts, just like the egg omelette recipe. That way, you build up the steps to complete the algorithm that will resolve the overall problem. Now, let's explore a practical application of algorithms in coding. I'm going to demonstrate a particular algorithm that checks if a word is a palindrome, A palindrome is a word that can be spelled the same both backwards and forwards. For example, the word race car is a palindrome because I can spell it forward as R-A-C-E-C-A-R, and backwards it's still the same, R-A-C-E-C-A-R. To be able to check if a word is a palindrome, I need to use an algorithm. As mentioned earlier, an algorithm is a series of steps to solve a problem. Let me break down the problem. I know the string in my example race car has an index, and I need to check if the index at the front of the string is equal to the index at the end of the string. In this way, I can compare the two values at the indexes. So I print str0 because that's the first index. And I also print str6 because that's the last index. I can just count that up to double check. 0, 1, 2, 3, 4, 5, and 6. And then I click on Run. The output is the two values I need to compare, both of which are the letter R, at the beginning and at the end of race car. Now I'm going to break down our problem into smaller steps. First, I need to check if the value of index 0 is equal to the value of the last index 6, which in this case is R. Then I need to check that the next or second character, which is index 1, is equal to the second last character, which is index 5. Finally, I need to check if character 2 is equal to character 4. What I need to do is to check if these conditions are true or false. So let's check how I can write this out in some code. I begin by creating a function def is palindrome, and I know that it will accept a single parameter called string, which I've entered. Now I want to get the starting index as well as the end index. I put the start index into a variable that equals 0. Every string will always start at the index 0, and then the end index is going to be the length of the string. So I enter end index equals len function, str, and then -1. This is because a string always starts at 0, and I have to think about the last index. Next, what I want to do is iterate through the string itself and compare the starting index with the end index characters to validate that they are the same. To do this, I create a for loop by typing for x in str, and I'll make the comparison within the for loop. I can check if the first index is equal to the last index, and since the two characters R and R are the same, it'll continue to be true. But it would be quicker for me to check if it's false because then I'll know straight away if it's not a palindrome. So I do an if statement and I use the string being passed in as the parameter. Then I use the start index to get the character, and then I check if it's not equal to the string within the end index. If this condition is met, it will return false, which confirms that it's not a palindrome. But if the condition is never met outside the for loop, then it returns true, which confirms that it's a palindrome. I've done all the checks across the starting index and the end index, and it returns back to the condition of true to confirm that it's a palindrome. Now I'm going to test the algorithm to verify that it works. I use a print statement. I call the isPalindrome function, and I pass in race car because I know that it's a palindrome. I click on run and it returns the value of true. If I change race car to race cars and I run it again, the condition of false is returned. This is an example of creating an algorithm in code to solve a problem. It has a series of steps that have to be followed to resolve the problem in code to give back the condition of is the string a palindrome or not. Now you know how useful algorithms can be as a step-by-step way to solve a problem with coding. An algorithm can be used to solve problems whether small or complex. Once the steps of an algorithm are created, they will then execute the same way each time the algorithm is used. As a developer, your main task will be to write code to suit business needs. That code will have to go through what's called refactoring. This means that you rewrite or rework the code to make it easier to manage or to run more efficiently. Refactoring is a standard part of the software development cycle. Making code easier to manage may be straightforward, but what about making it faster or making it perform better? To determine how to make code faster or perform better, you must be able to measure it. Code is measured by time and space. Time is measured by how long it takes, and space is about how much memory it uses. Big O notation has different complexities or categories ranging from horrible to excellent, and it's used to measure an algorithm's efficiency in terms of time and space. Let's explore the different kinds of time complexities. First, constant time. This is an algorithm that will always run under the same time and space regardless of the size. Take a dictionary, for example. To get the value of an item, you need to have the key. The key is a direct pointer to the value and does not require any iterations to find it. It's considered constant. Second is a linear time algorithm. This will grow depending on the size of the input. For example, if I have an array of numbers with a range of 100, it will run very fast. But if it's increased to 1,000,000, it will take a lot longer to complete. The size in this case affects the running time of the code. Third, a logarithmic time algorithm refers to the running time of the input against the number of operations. I can take a linear approach to try to find a number out of 100. Let's say the number is 97. In a linear equation, it will take 96 iterations before it's found. This is because it must iterate through each item one by one until it finds the target value. Using a binary search, I can drastically cut down the iterations and find it under 7 iterations. This is measured by logarithmic time. The binary search works by splitting the list into 2 parts each time to check if the target is less than or greater than 1. Fourth, quadratic time refers to a linear operation of each value of the input data squared. This is often a nested list, as in this for loop. This for loop is considered quadratic time as the outer loop will need to iterate in a linear way 10 times. But it also has to iterate the inner loop the same 10 times for each single outer loop. This means its total iterations are 10 times 10, which is 100. Fifth and last is exponential time, which is an algorithm that doubles with each iteration. The Fibonacci sequence is a prime example of this. Refactoring code can be a big task, but understanding algorithmic complexity and how it's calculated makes it easier to optimize code. Now that you know about constant, linear, logarithmic, quadratic, and exponential time, you are one step closer to your goal of being a developer. Perhaps you've heard of functional programming. It uses a different paradigm than other models such as object-oriented. It's particularly adept at processing large amounts of data at high speeds. This video will get you started with what functional programming is. Later in the lesson, you'll explore topics such as pure functions, recursion, reversing a string, and useful Python functions such as map and filter. Let's start by exploring the role of a function. Functions take some input, process it, and then produce some output. There are 2 types of functions, traditional and pure. Pure functions will always do the same thing and return the same result, no matter how many times they are called. There are several differences between traditional and pure, so let's list them. Traditional functions can access and modify variables on the global state, but pure functions cannot. Both traditional functions and pure functions can access variables in the local state. Traditional functions can change args, whereas pure functions cannot. And lastly, the output of traditional functions does not depend on input. However, the output of pure functions does depend on input. Functional programming, in essence, is a programming paradigm that utilizes functions for clean, consistent, and maintainable code. Compared to object-oriented programming, which we'll learn about later, functional programming differs by design. Functional programming does not change the data outside the scope of the function. This simply means that the function should avoid modifying the input data or arguments being passed. Instead, it should only return the completed result of the intended function being called. Functions are considered standalone or independent, and this aids the clean and elegant nature of the code. In fact, many of the strongly typed object-oriented languages have incorporated functional programming into their structure. In order to support functional programming, the language itself needs to allow functions to be passed as an argument and also return a function to its caller. In Python, functions are what is known as first-class citizens, which essentially means they have the same level of strings and numbers. They can be assigned to a variable, passed as an argument, or returned to its caller. Let's explore a few examples of functions available in Python. Take, for instance, the sorted function. The sorted function accepts a list of items and then returns that list in a sorted order. You can use a sorted function to list items in alphabetical order. By passing a list of coffees to the sorted function, the return sorts the list in alphabetical order. The great thing about functional programming is that the logic behind certain tasks is already built in for you. Functions are reusable and thus save a lot of development time. But did you know that you can also create your own functions specific to your own requirements? Let's look at a simple example. Imagine you want to spell the names of the coffees backwards. This might not be entirely useful, but it's a good showcase of functional. You can create your own simple reverse function to do this. Define the function. Let's call it reverse and assign the variable str to it. Now return the value of str with a slice function. You'll learn more about the slice function later in the lesson. Then assign a variable to get the result to the map function. The map function accepts as its first argument the reverse function and then the iterable, coffees. It will then automatically handle the iterations to go through each coffee and apply the reverse function to it. In this video, you have learned what functional programming is, and you were introduced to examples of built-in functions in Python. A good coder will try to keep code clean, make it easier to debug, and ensure it's extendable. The great thing is that pure functions can help you do all that. In this video, you'll learn what pure functions are and how you can use them in functional programming. It's important to understand that there is a clear difference between traditional and pure functions. A pure function is a function that does not change or have any effect on a variable, data, list, or set beyond its own scope. For example, if you have a list with a global scope, a pure function cannot add something to that list or alter it in any way. Let's explore an example function and then determine if it is a pure function or not. This code includes a list on the global scale and a function called add to a single parameter called item. The value of item is then set to 4. The output is 1, 2, 3, 4. What do you think? Is this a pure function? No. It's not a pure function as it changes the global list by appending the item which is passed as an argument. In order to change it to a pure function, you need to think how to extend the function to accept a list as an argument, add the item to the list without modifying the original list, and how to return a new list with a newly added item. The solution is to create a new list and copy or clone the data from the original list. Let's revisit the code to make some changes. This time, you make a copy of the original list. The new item is added to the new list. Then the new list is returned to the caller. Now that you have a better idea of what a pure function is, let's review a few benefits of pure functions. Firstly, with pure functions, you always know what the outcome will be. Pure functions are consistent snippets of code that do exactly what they are intended to do. Thirdly, pure functions include the ability to cache since you know the return is always going to be the same. Lastly, pure functions lend themselves well to a multi-threaded program. In multi-threaded programs, more than one process could run concurrently, which creates many threads of data. Pure functions will help prevent changes on the global scope, ensuring data stays reliable. Now I think it's time to offer you a step-by-step demonstration in VS Code of how to alter a normal function to a pure function. Pure functions are especially useful because they are easier to read, better to debug, and more consistent. I'll now take you through a simple example to demonstrate how to create a pure function. I'll start by creating a function that does not behave like a pure function, and then I'll tweak it until it's a pure function. First, I create a list called myList, and inside it, I add 3 numbers, 1, 2, and 3. Then I add a simple function called addToList, which takes a single variable called item. This function will return my list and append the new item that is being passed through. Below that, I call the function addToList and assign the value of 4 to the variable item. Finally, I add a print statement of my list so that I can focus on the output in the console. I click on the Run button and the numbers 1, 2, 3, and 4 are printed out. This means that my list now contains the inserted number 4 as well, because the function appended it to the existing list. What do you think? Is this a pure function? No, it's not, because the data has been manipulated at the global scope from inside the scope of the function. Let's try to turn it into a pure function. The first thing I'm going to change is how the function is being called. I want to pass in a new argument. I type new list equals add to list. I keep the value of 4, and I'll also print out the new list below the first print statement to compare the output. Now let's make some modifications to the function itself. I add a simple append to my list, which is going to take in the item variable. I type mylist.append and item in parentheses. Then I want to return back the list. I type return my list. Now I click on run, and the output in the console indicates that both my list and new list include the values of 1 to 4. It's clear that the function is still not a pure function. Why? Because even though it's returning a new variable, it still has a reference to the mylist variable. Let's try something else to turn it into a pure function. This time, I'll accept a parameter called lst for the variable item. I type lst, comma, in front of item in the parentheses. I also change the append statement to lst.append item. And I also change the return action to return lst. Finally, I change the call action by passing in mylist, comma, inside the parentheses before the value of 4. Let's run that. And once again, both lists contain the values of 1 to 4. The reason for this is that the function is still using the list as an argument, and it's still being updated from within the function. So ultimately, in order to create a pure function, the problem that I have to solve is how to create a new list. And then I need to solve how to get all the values from the list that's being passed through and then return the new list back to the calling action. Let's give it another try. This time I create a new list by creating a copy. In the function, I type the name of the new list nl equals lst.copy and a set of parentheses. Now, instead of putting the passed values into the lst, I'll put it into the copy. So I type nl.append, and then I also change the return action to return nl. I clear the console screen so that I can focus on the output and click on run. And finally, I get 2 different results. My list is printed with the values 1, 2, and 3, but the second print statement for new list includes the values of 1 to 4. This function is now a pure function because it adds a value to a list, but it doesn't manipulate the original list outside the function. In this demonstration, you've learned what a pure function is and what you need to do to change a function that's affecting a list on the global scope to a pure function that does not interfere with the original list. It's likely that you'll use pure functions regularly in your programming career because pure functions will keep your code cleaner, easier to debug, and easier to extend. In programming, recursion is used for solving problems that can be broken down into smaller, repetitive problems. It's especially good for working on things that have many possible branches and are too complex for an iterative approach. One good example of this would be searching through a file system. So, what is recursion? Recursion is essentially a function that calls itself. Recursion creates a pattern of repeating itself over and over and over. So what does that mean from a coding perspective? In this example, a function accepts a single argument, and inside the function, it has some logic to deal with the problem it's trying to solve. The key part is the return. In the code, the return statement is returning the same function. Recursion is quite similar to a for loop. It will iterate, or in the case of a recursive function, call itself multiple times. But a warning, when you create a recursive function, you must always consider the result. If you don't, it will spin into an infinite loop and suck up all the memory until the program eventually crashes or gets terminated. Let's compare how to use a looping and a recursive solution to find the factorial of a number that can be solved. Let's start with the looping solution. The looping function accepts a single integer called n as an argument and first checks if the number is less than 0. If it is, it returns 0 as you can't have a factorial negative number. The else condition sets the factorial to 1 and then loops through the range of the argument, which is 5 in this case. The loop will calculate 1 times 2 times 3 times 4 times 5, which will give the answer as 120, the factor of 5. Now let's explore the recursive solution to the same problem. The recursive function is simpler and more compact. The main reason for this is that you no longer need the for loop to do the iteration of the n argument. The first line of the function verifies that the number is 1 and returns 1 if true. The else condition multiplies the argument n by calling the find factorial recursive function and passing in n minus 1. Recursion can be difficult to understand. By way of explanation, let's demonstrate exactly what happened as the function calls itself. The function is being called over and over, and the part that changes is the value being passed into the function each time. The argument of n, or 5 in this case, is decreased by 1 each time until it finally is 1. This stops the function from being called again and exits out of the recursive process. So how exactly did this code get the result of 120? This is provided by the return statement. It keeps a reference to the incremented value, and this is the final return after it has been completed. Right. It's time to review the advantages and disadvantages of recursion. First, the advantages are recursive code can make your code neater and less bulky. Complex tasks can be broken down into easier to read subproblems. Generation of sequences can be easier to understand than nested loops. But there are disadvantages. It can be harder to follow the logic in recursive code. In terms of memory, they are expensive and sometimes inefficient. It can also be difficult to debug and step through the code. You should now be able to explain what recursion is and how it can be used to solve problems. I believe you'll benefit from using recursions in your code in the future.
One of the basic ways to test a Python developer's problem-solving skills is by asking them how they would reverse a string. Knowing how to do this is very useful in the production environment. Some programming languages have a built-in function to reverse a string. Python doesn't have such a function, but fortunately, due to the language's flexibility, there are several ways to do this. In this video, I will show you 2 ways to reverse a string in Python. First, I'll demonstrate how to do this with the slice function. To start off, I create a file called stringreversal.py. The format or syntax of a slice function is that it always starts with the name of a string, open square bracket, the start parameter, colon, the stop parameter, another colon, and then the step parameter, followed by a close square bracket. I'll add a hash symbol in front of this line to indicate that it is a note. This is called the extended slice syntax. The start and stop parameters are the indices between which the function manipulates the string. The step parameter is the hops or jumps the function makes while it traverses a given string. I will now first define a string, then manipulate the string with the slice function, and finally print the string. I'll call the string trial and assign the word reversal as its value by typing trial =, and the word reversal between double quotes. To manipulate the string, I create a new string called newTrial. Now, I assign a value to newTrial with the slice function. I type an =, trial, and open square bracket. To instruct Python to use the entire string, I leave the value of the start and stop parameters empty. I simply type 2 colons and then add the value of the step parameter as the number -1, followed by a closed square bracket. The negative value of the step parameter indicates that the string needs to be traversed from the right, 1 index position at a time, instead of the conventional method of starting from the left. Finally, I print the manipulated string to test if it works. I type print, and between parentheses, I add the string name newTrial. I click on run. Great! In the terminal, the string has successfully been reversed. In summary, the entire string is traversed from right to left, 1 index position at a time. This new sliced object is then copied to another string, which is then rearranged and printed. It should be noted that you can use the slice function to manipulate the same variable. I only used a second variable in this example for clarity. The slice function is the simplest way to reverse a string. I will now demonstrate another way you can use the slice function to reverse a string, this time using recursion. I start by creating a new file and saving it as stringreversal2.py. Next, I define a function and pass a string variable to it, namely str. I type def and the function name string reverse, and str between parentheses, followed by a colon. This function will act as a conditional if statement. I type if len, open parenthesis, str, close parenthesis, two equal signs, the number 0 followed by a colon. On the next line, I'll return the value of str. Now let's add the else statement. The else statement will recursively call the slice function, but with a modified string every time. On the next line, I add else and a colon. Then, on the next line, I type return string reverse str. But before I close the parentheses, I add a slice function by typing open square bracket, the number 1, and a colon, followed by the closed square bracket. This time, the string is traversed from the front, skipping the first character in every loop. And this first character skipped is appended to the remaining string. So, I now add a plus sign, str, and the value 0 in between brackets. Outside the function, I give str the value of reversal. Then, I create a second variable that will store the value of the returned string. I'll call this variable reverse and assign to it the value of the function. Finally, I add a print statement for the variable reverse. Let's run the code. Success! The string displays in reversed order in the terminal. Essentially, the function calls itself by passing a different string in each recursion and appending the element it has kept right after it. In this video, you learned two different methods to reverse a string in Python. The first by just using a slice function, and the second by using a slice function with recursion. Let's say I want to generate a list using an existing list. The general process would involve applying some sort of operation to each element of the existing list, and using those outputs to generate the new list. There are many ways you could do this in Python. In this video, you will learn how to process a list with the map and filter functions. My file contains a list called menu, and it contains a list of various coffees. I want to filter this list for specific coffees. Say I want to print all coffees that start with the letter C. I will do this by creating a function through which I will pass the list to compare it to the letter C. Then, I will demonstrate how to get the output, first as a map, and then as a filter. Before I start, let me talk you through the format of a map function, but keep in mind, the filter function follows the same format. To create a map, I type map, and then need to define its arguments. The map function accepts two arguments. The first argument is an actual function. In this case, it will be the function that I will use to match values based on a condition. The second argument is the articles that will be passed through that function. In this case, the coffees from my menu list. Now, let's create the function with the condition. I press enter twice to move the map function down. I type def and the name of the function, which is find coffee. I then add a single parameter coffee between the parentheses and a colon after the closed parenthesis. The coffee parameter I added will be the coffee from my list. I now need to check if the first character of the items in the list matches the letter C. To do this, I will create an if statement by typing if coffee and pass in 0 to set the action on the first letter of the coffee variable. I then type the equal sign twice, followed by the letter C and a colon. I press enter, and on the next line, I type return coffee if the statement is true. To use the map function, I'm going to assign it to a variable called map coffee. I follow that by entering an equal sign and the map. Now I can pass in the arguments for the map function. Remember, the first argument is the function itself. I enter the function name findCoffee. It is important to note that I am not calling the function. I'm just passing it in like an argument. I add a comma after findCoffee, and then the second argument, the article, in this case, menu. Finally, I want to print out the value of mapCoffee so you can focus on the results in the terminal. I click on run, and in the terminal, I receive a map object as output. The next step is to iterate through the map object. I type for x in mapCoffee, print out the value of x. I click on run again, and now I get the output as a map. In the terminal, a list appears with a lot of values that say none, except cappuccino and cortado. And that is because cappuccino and cortado are the two matches for the letter C in the function. The great thing about the map function is that I did not have to create a for loop to go through the list. The map function takes the function as an argument and passes the menu list values into the function one by one. So, that handles the iteration for me, which makes it quite useful. Next, I'm going to demonstrate how to get the output with the filter function. To start, I'll comment out the section of the code related to the map function and clear my terminal. The filter function works much the same as the map function. I declare a variable called filterCoffee and assign the filter function to it. Again, I add the two arguments, namely the findCoffee function and menu. Then, I print out the variable filterCoffee. I click on Run and receive a filter object as output. Now, I will iterate through the filter object just like I did with the map object. I type, for x in filterCoffee, print out the value of x. I'll clear the terminal now and click Run. This time, only cappuccino and cortado are returned. Why is that? Let me explain the difference between a map and a filter function. A map takes all objects in the list and allows you to apply a function to it. A filter also allows you to take in all objects in the list and runs through a function, but it creates a new list and only returns values where the evaluated function returns true. That is why there are no none values displayed in the output for the filter function. You now know how map and filter work in Python and should be able to also explain the difference between the two functions.
Programming languages are built upon certain models to ensure that code behaves predictably. Python primarily follows what is known as an object-oriented paradigm or model. As you'll soon discover, object-oriented programming, or OOP, relies heavily on simplicity and reusability to improve workflow. By the end of this video, you'll be familiar with the object-oriented programming paradigm. You'll also be able to identify the four main concepts that define object-oriented programming. Programming paradigms are a strategy for reducing code complexity and determining the flow of execution. There are several different paradigms such as declarative, procedural, object-oriented, function, logic, event-driven, flow-driven, and more. These paradigms are not mutually exclusive, so programs and programming languages can opt for multiple paradigms. For example, Python is primarily object-oriented, but it's also procedural and functional. In simple terms, a paradigm can be defined as a style of writing or program. OOP is one of the most widely used paradigms today due to the growing popularity of languages that use it, such as Java, Python, C++, and more. But the OOP's ability to translate real-world problems into code is arguably the biggest factor in its success. OOP has high modularity, which makes code easier to understand, makes it reusable, adds layers of abstraction, and allows for code blocks to be moved between projects. To help you better understand OOP, I'll first clarify some of its key components, which are classes, objects, and methods. A class is a logical code block that contains attributes and behavior. In Python, a class is defined with a class keyword. The attributes can be variables, and the behavior can be functions inside of it. You can create instances from these classes which are called objects. In other words, a class provides a blueprint for creating an object. In more practical terms, let's say you want to record the attributes of employees at Little Lemon, such as their position and employment status. You could create a class called employee and conveniently bundle those attributes in one place. Next, let's discuss objects. As mentioned, an object is an instance of a class, and you can create any number of them. The state of an object comprises its attributes and behavior, and each one has a unique identifier to distinguish it from other instances. The attributes and behavior of the class are what define the state of the object. For example, you can create the object emp1 by calling the employee class. Once called, you can define the position and employment status attributes as shift lead and full-time, respectively. In code, this would be written as emp1 equals employee, followed by shift lead and ft in parentheses. This is a case of instantiation or creating an instance of a class. Finally, there are methods, which are the functions defined inside a class that determine the behavior of an object instance. Let's say you want the employee object to output a string that states their position. You would first declare their function intro in the employee class, and then call it on an object to get the output. Now that you know about classes, objects, and methods, let's explore the concepts that OOP hinges upon. The first one is inheritance, which is the creation of a new class by deriving from an existing one. The original is called the parent or superclass, while any derivatives are referred to as the subclass or child class. The next concept is called polymorphism. It's a word that means having many forms. In the context of Python, polymorphism means that a single function can act differently depending on the object that calls it. For example, the built-in plus operator works differently for different data types. In the case of integer data types, the built-in plus operator performs addition operations such as 3 plus 5 equals 8. On the other hand, in the case of string data types, the built-in plus operator performs a concatenation or combining two strings together. This ability of modifying functionality is called polymorphism. The third concept is encapsulation. Broadly, this means that Python can bind methods and variables from direct access by wrapping them within a single unit of scope, such as a class. Encapsulation helps prevent unwanted modifications, in effect reducing the occurrence of errors in output. And finally, there is a concept of abstraction. This refers to the ability to hide implementation details to make data safer and more secure. Note that Python does not support abstraction directly and uses inheritance to achieve it. This is something that you'll explore in more detail later. There are some other important concepts in OOP, such as method overloading, method overriding, constructors, and more, which you'll learn about in more detail later. In this video, you became familiar with OOP paradigm and the four concepts that support it: inheritance, polymorphism, encapsulation, and abstraction. See you next time.
Classes have the ability to combine data and functionality, which is a very useful feature when you are coding. By the end of this video, you'll be able to explain what classes, instances, and objects are in Python. You'll also be able to create a class, instantiate it, and access its variables and methods. You may have also heard of classes discussed in terms of attributes and behaviors. In general, attributes refer to variables declared in a class, while behaviors are associated with the methods in a class. Creating a class creates a new type of object from which you can create instances. An important thing to keep in mind is that everything in Python is an object, or derived from the object class. To demonstrate how this all works, I'll create a class that I can then derive objects from. In a new VS Code file, I first type the keyword class, followed by the name myClass and a colon. I do need to take one more step so that Python doesn't throw an error, and that is to type the pass keyword on the next line. The pass keyword plays the role of a placeholder when nothing needs to be executed. In practice, this tells Python that I won't do anything with this class just yet. Next, let's create an object for this class. I create a variable called myClass, and then assign the class to it by typing equals myClass, followed by parentheses. If I run this code, the output shows that it has executed without errors. However, just to check that it's working as expected, let's add a print statement to the class. So that would be print followed by the string hello in parentheses. When I run the code again, the word hello appears in the output. Let me clear the terminal before continuing. You may have noticed that I use the same name for both the class and its object, but the object name can really be anything. For example, if I change the object name to myc and run the code once more, it will execute the same as before. Everything I've typed is part of the instantiation process in Python, which involves 3 key steps. 1. Class definition. 2. Creating a new instance. And 3. Initializing the new instance. Since everything in Python is an object, it makes sense to follow naming conventions to make things less confusing later. In this case, I have myClass for the class object and myc for the instance object. There is a third type of object called the method object, which you can use to call a method whenever it's needed. Classes mainly perform 2 kinds of operations: attribute references and instantiation. I've already written an example of the latter, so let's try building an attribute reference this time. First, I create a variable a for the class object and assign it a value of 5. To print this variable, I first need to refer to the class. So, under the instance object, I type print and then myClass.a. When I run the code, it returns 5 in the output. To confirm that the class reference is necessary, I delete my class from the print statement and run the code again, and Python throws an error. So I'll correct the code and put my class back in. Let me clear the terminal quickly before continuing. So, you know what happens if you reference a class object, but what if you reference an instance object? Let's find out by typing a print statement for myc.a and then running it. In the output, I get 5, which shows that attribute reference still works with instance objects. Finally, let's finish up by creating a method inside this class. I'll use the def keyword and follow it with hello, a pair of parentheses, and a colon. On the next line, I type a print statement for the string hello world. I'll also delete the first print statement to avoid confusion. To call this method, I add a new print statement at the end of the document for myc.hello, which uses the instance object. This should work just as I successfully called a variable through an instance object, right? Running the code results in an error, so methods are not quite as simple. Fortunately, I can resolve this by adding the keyword self within the parentheses of the method as defined in the class. Running the code again produces the words hello world in the output. You'll also find the word none printed below, as there is no return value from the given function. That's a brief demonstration of classes, instances, and objects. I created a class, then I was able to instantiate it and access its variables and methods. Code reusability is the use of existing code to build new software. Reusability is a core programming concept. By the end of this video, you'll not only be able to create a class and instantiate it with variables and methods, but you'll also discover how referencing the same variables and methods in separate instances can produce different outcomes, meaning that the code is reusable. I'll start by creating a new file called recipes.py, where I'll also create a class called recipe. Before continuing, let's also explore two special methods in Python. The first one is the new method, which is responsible for creating and returning a new empty object. To write it, I start with the def keyword, followed by _new. It then appears as a suggestion, so I click on it to fill out the rest. The CLS here is not a keyword, but rather a convention. It acts as a placeholder for passing the class as its first argument, which will be used for creating the new empty object. The second method is the init method, which is similar to what is known as a constructor in some other programming languages. It takes the object created using the new method, along with other arguments, to initialize the new object being created. I write it with the def _init, and then choose the first suggestion that pops up. The init method takes the new object as its first argument. The self keyword here is another convention. It has no function itself, but serves as a placeholder for self-reference by the instance object. So let's delete the two example methods and then write some code that demonstrates how to use the state of the object to your advantage. I begin with an init method, which I then use to initialize a few values. I do this for the value dish by typing self.dish equals dish. I then do the same for the values items and time. Before moving forward, I want to check that the arguments in the initializer will match those of my instances. To do so, I add dish, items, and time after self. Imagine a real-world scenario where a restaurant chef wants information about the recipes they have been using. So, let's write a class that will help them with that. I have the variables dish, items, and time, in which items will hold the recipe ingredients. I now write a function to produce a string out of this information. I type def contents and then self in parentheses. On the next line, I write a print statement for the string the plus self.dish plus has plus self.items plus and takes plus self.time plus min to prepare. Here we'll use the / character to force a new line and continue the string on the following line. For this to print correctly, I need to convert the self.items and self.time references to strings by appending str at the beginning and encasing each reference in parentheses. Now that I have a class set up, let's use it to create a pizza instance. I write this as pizza equals recipe, opening parenthesis, the string pizza, comma, opening square bracket, cheese, comma, bread, comma, tomato, closing square bracket, comma, and 45 to represent the time followed by the closing parenthesis. I also want a pasta object, so let's copy and paste the code for the pizza object and change the object name to pasta, the ingredients to penne and sauce, and the preparation time to 55. Now that I have a class and two instances, let's see if I can access the instance attributes and methods. I write two print statements for pizza.items and pasta.items. When I run the code, I find that despite passing the same function and variable items, the two instances produce different contents. So next, let's try printing the instance method contents over pizza. Before we move forward, let's clear the terminal so we can more clearly see what the output will be. I type another print statement for pizza.contents and empty parentheses. I run the code once more, and the output uses the class method to print a line stating, the pizza has cheese, tomato, and bread, and takes 45 minutes to prepare. That's a demonstration of creating a class and instantiating it with variables and methods, then referencing the same variables and methods in separate instances to yield different outcomes.
Let's try to solve a problem that may occur for managers at a restaurant. Because the managers are busy running the restaurant, they have limited time to deal with the needs of employees. The current system for paying wages requires managers to update each other every time an employee requests payment. Because this is cumbersome, they would like to implement an automated approach. So what can be done? Fortunately, there's a way to reduce the number of steps using instances. By the end of this video, you'll be able to explain what instance variables and methods are. You'll also know how to use them to change the state of an instance object. So let's write some code to help those busy restaurant managers. Let's start a new file called paymentinfo.py. In this file, I'll create the class payslips and initialize three variables in it called name, pay status, and amount. I start by typing class payslips, and then on the next line, I call an init function with def_init, and then select the triggered suggestion. For the variables, I type each one in the format self.variable equals variable. Next, I'll create two functions, one to display the status of the payment and another to update the status. The first function is written as def_pay with self in parentheses, followed by self.payment equals yes on the next line. The second function is def_status and contains an if-else statement. If self.payment equals yes, return self.name plus is paid plus self.amount with str appended to the beginning. The second part of the statement is else, return self.name plus is not paid yet. Finally, let's create instances of this class for the employees. I'll call them Nathan and Roger. I type the first instance Nathan equals payslips, and in parentheses Nathan for name, no for payment, and 1000 for amount. For Roger, I copy and paste this instance and set the values to Roger, no, and 3000 respectively. I also need to make sure to pass these values inside the init method, so I type name, payment, and amount after self. Now I'm ready to call the instance method status to check the status of the payments. I write a print statement for Nathan.status parentheses and for Roger.status parentheses. When I run the code, the output all appears on one line, which is not very presentable. I add a new line character between the items in the print statement, which is \n. This time, the output is much cleaner. The output states that neither Nathan nor Roger have been paid. But let's say that one manager decides to pay Nathan, so I'll use the pay function to update the status. Remember that the pay function is set up to update the value of the payment variable. I type Nathan.pay parentheses and then copy and paste the last print statement. Above this line, I type another print statement with the string after payment. I run the code once more, and it now tells me that Nathan was paid 1,000, whereas Roger still has not been paid. That's a demonstration of instance methods in action. Now I'll describe the code to you in more detail. Now let's discuss what happened in that coding example in more detail. The two instance objects, which are Nathan and Roger, each have their own states. You may have noticed that when the instance method pay was called to change the state of Nathan, Roger was not affected. This is because the method inside the class is not affected. Rather, it provides a separate blueprint to each instance, which can then be updated for that instance only. In the coding example, I didn't print the variable values after calling the pay function, but if I did, it would show that the payment instance variable for Nathan changed from no to yes, while Roger remained no. Now let's imagine that this code is the basis for an online payment system. It would allow either manager to click on the paid button for an employee, which then updates that employee's status. No more back and forth calls. In this video, you learned how to use instance variables and methods to change the state of an instance object without affecting any other instances. When instantiating objects from a class, you may find that the class is missing some properties that you use frequently. In that case, you could decide to make a new class that replicates the first one, but also adds a few more properties. It would be cumbersome to write everything from scratch, but thanks to inheritance, you don't have to. By the end of this video, you'll become familiar with inheritance in terms of child classes being derived from a parent class. Inheritance is a core concept in object-oriented programming generally, and in particular in Python, and it's a major part of code reusability. You may know that everything in Python is an object, but let's explore that idea more closely. It specifically means that every class in Python inherits from a built-in base class called objects, which is found in built-ins.objects. In other words, a class declaration such as some class with empty parentheses implies some class with object as its argument. When speaking of class derivation, the originating class is known as the parent class, superclass, or base class. The class which inherits from it is the child class, subclass, or derived class. Any name pairing is acceptable, but the important thing to know is that the child class extends the attributes and behaviors of its parent class. This allows you to do two things. You can add new properties to the child class, and you can modify inherited properties in the child class without affecting the parent. So now let's explore an example of how this is done in Python. Here you have a parent class P, which holds the variable a with a value of 7. Then there is the empty child class C, in which class P is passed as an argument. And finally, a lowercase c represents an instance of child class capital C. If you write a print statement for c.a and run the code, the output is 7. So even though C itself is empty, it still holds the attribute inherited from P. Keep in mind that any changes in the parent class will also affect any child classes. Now that you have an idea of how inheritance works, let's explore an example that demonstrates the flexibility it provides. I begin by creating a new file called employment.py, and my first step is to create a parent class called employees, where I'll define two variables for first and last names. I do this by typing class employees colon and on a new line def double underscore init to trigger and select the init method suggestion. For the first variable, I type self.name equals name on a new line, and for the second, I advance another line and type self.last equals last. I then add name and last to the init argument on line 2 after the word self. Next, I'll create two child classes that both extend the employee class. The first one I create is supervisors, and to call the employees class, I type class supervisors, open parenthesis, employees, close parenthesis, and a colon. I then need to modify the init method of the supervisors class so that I can add another variable named password. Again, I trigger and select the init method, but this time it already includes the name and last variables. By calling the employees class, the super method has automatically been applied to access the variables there, and initialize them within the supervisor's class. I proceed with adding the third variable, password, inside of the init method. I then make it an instance variable with the line self.password equals password. Now I'll write another child class called chefs. Again, I extend the employees class by adding employees as a method inside this class. I want this one to contain a new function called leave request. So I type def leave request and then self and days as the variables in parentheses. The purpose of the leave request function is to return a line that specifies the number of days requested. To write this, I type return the string may I take a leave for plus str open parenthesis the word days close parenthesis plus another string days. Now that I have all the classes in place, I'll create a few instances from these classes, one for a supervisor and two others for chefs. First, I type Adrian equals supervisors, followed by the values Adrian and A in parentheses. I can then copy and paste this instance 2 more times to serve as a template for the chef's instances. The first chef is Emily and will hold the values Emily and E, while the second chef Juno has the values Juno and J. Finally, as an instance of the supervisor's class, Adrian needs another value for the password variable, so I'll assign Apple here. Next, let's call the instance method over Emily and pass a value to it. She wants to request 3 days off, so I type print emily.leave_request and the number 3. I'm also going to add another print statement that will check the value of the instance variable over the supervisor Adrian. I type print adrian.password. The third print statement prints the value of Emily's name variable. Now I run the code and get the following outputs. The words, may I take leave for 3 days from the first print statement, the word Apple from the second one, and the word Emily from the third print statement. Note that both the instance variables and methods inside the individual inherited classes are present along with the variables from the parent class. In this video, you've learned how inheritance in Python helps to make code reusable, organized, and less redundant. In this video, you'll learn about abstract classes and methods. If you have an abstract class, you can ensure the functionality of every class that is derived from it. For example, a vehicle could be an abstract class. You can't create a vehicle, but you can derive a car, a tractor, or a boat from a vehicle. The methods we put in the abstract class are guaranteed to be present in the derived class because they must be implemented. If a vehicle has a turn-on engine method, then we assure that any method calls to a derived class that is looking for turn-on engine will find it. This could be for reasons of interoperability, consistency, and avoiding code duplication in general. In object-oriented programming, the abstract class is a type of class for which you cannot create an instance. Python also does not support abstraction directly, so you need to import a module just to define an abstract class. Furthermore, methods in an abstract class need to be defined before they can be implemented. With all these limitations, one might wonder why you would use abstract classes at all. One of their key advantages is the ability to hide the details of implementation without sacrificing functionality. Implementation in abstract classes can be done in 2 ways. One is that as base abstract classes lack implementation of their own, their methods must be implemented by the derived class. Another possibility is that the super function can be used, but that's a topic for another time. For now, let's focus on the module for defining an abstract class. You may not be familiar with modules right now, but they will be covered in more detail later. For now, it's okay just to follow along. The module is known as the Abstract Base Class, or ABC, and needs to be imported with some code. After that, you can create a class called SomeAbstractClass and pass in the ABC module so that it inherits that class. The next step is to import the abstract method decorator inside the same module. A decorator is a function that takes another function as its argument and gives a new function as its output. It's denoted by the @ sign. You may not be familiar with decorators. But for now, it's enough to know that decorators are like helper functions that add functionality to an already existing function. Finally, here you'll define an abstract method which cannot be called on an object of this class. You will be able to call this method over objects of classes that inherit from this class. Similarly, we can define abstract methods with the help of what we call an abstract method decorator present inside the same module. Any given abstract class can consist of one or more abstract methods. However, a class that has abstract class as its parent cannot be instantiated unless you override all the abstract methods present in it first. With that in mind, imagine a scenario in which an employer wants to collect donations from employees for a charitable cause. With your newfound knowledge, let's write some code to make that possible. First, I import the ABC module and its abstract method. Then I create the employee abstract class that calls abstract method to define a method called donate. Note that there's no implementation for this method here. After that, I create the class donation, which derives from the abstract class. Note that this class also overrides the abstract method. I write an implementation for the donate function, which takes a user input, stores it in variable A, and returns it. Next, I create two employee instances called John and Peter, and call the function over each of them. I also create a list amounts to which the returned values will be appended. Finally, I have a print statement for amount, which will give the value of the total donations from both employees. In this video, you learned about abstract classes and methods and how to implement them in your code. Up to this point, you've explored class relationships that were relatively straightforward. But what happens when things get complex? How will you know which classes inherit from which? Fortunately, Method Resolution Order, or MRO, provides rules that can help make sense of that. By the end of this video, you'll know how to explain the basic rules of method order resolution and how they apply to inheritance classes. Explain the concept of code linearization with respect to multiple inheritance, and deploy method order resolution functions in Python. You've likely encountered some examples of single inheritance where a child class only inherits from a single parent class. But it's important to know that Python has many types of inheritance. The categorization types are based on the number of parent and child classes, as well as the hierarchical order. Including simple inheritance, there are broadly 4 types of inheritance. The first type is called simple inheritance, which you've already dealt with. There is also multiple inheritance, which involves a child class inheriting from more than one parent. Next is multi-level inheritance, which is inheritance taking place on several levels. Then you have hierarchical inheritance, which concerns how several subclasses inherit from a common parent. And finally, you could say that there is a 5th type called hybrid inheritance, which mixes characteristics of the others. As these inheritance types demonstrate, inheritance becomes increasingly complex as the number of classes in a project grow and become more interdependent. So how do developers solve this issue? With the use of MRO. MRO determines the order in which a given method or attribute is passed through in a search of the hierarchy of classes for its resolution, or in other words, from where it belongs. The order of the resolution is called linearization of a class, and MRO defines the rules it follows. The default order in Python is bottom to top and left to right when imagining the inheritance of these Python classes in a tree structure. Let's take the simplest example of single inheritance. The object is first searched in the class of that object, and then in its superclass. What about in an example where class Z is inheriting from 2 classes? Let's say Z is inheriting from classes X and Y. In this instance, the MRO will be Z, Y, and then X. In other words, the MRO works its way bottom to top and then from left to right. But things become much more complicated when more levels are added to the hierarchy. So developers rely on algorithms to build MROs. Old-style classes used in-depth first search algorithm, or DFS. From Python version 3 onwards, Python versions have moved to the new style of classes that rely on the C3 linearization algorithm. The implementation of the C3 linearization algorithm is complex and beyond the scope of this lesson. But for now, here's an overview of a few rules that it follows. The algorithm follows monotonicity, which broadly means that an inherited property cannot skip over direct parent classes. It also follows the inheritance graph of the class, and the superclass is visited only after visiting the methods of the local classes. This logic will make more sense later when you explore more complex class relationships in a future lesson. Next, let's take a moment to explore some methods of finding the MRO of a class. First, I'll begin with a demonstration of the MRO attribute or function. Let's take a multi-level inheritance example comprised of 3 classes: Class A, Class B, and Class C. Class A is the parent class, with B and C the respective child classes. In other words, B inherits from A, and C inherits from B. When I print the return for calling the MRO function over Class C, the output indeed confirms that this is the order that is followed. So why is this important? Well, imagine that Class A has a variable num with value of 5. And then Class B also has a num variable with a value of 9. Here, the MRO function tells you quickly that Class C will inherit the 9 value from Class B. Finally, let's examine one more function, which is the help function. If I take the code from earlier and replace the MRO function in the print statement with a help function, it provides a much more detailed output with MRO information at the top. It also contains information about the data descriptors and types used inside the code. In this video, you received a brief introduction to method resolution order and how it affects inheritance in different scenarios. These are both very broad topics, but hopefully it helps you understand the complexity of code that is possible in Python. Well done. You've reached the end of this module on programming paradigms. In this module, you explored procedural programming, functional programming, and object-oriented programming. We started the module by saying that procedural programming is considered the easiest and a basic stepping stone to object-oriented programming, and the first choice for new developers. Next, you explored functional programming, which in essence is a programming paradigm that utilizes creating functions for clean, consistent, and maintainable code. Lastly, you learned that object-oriented programming is about creating objects that contain both data and methods. These concepts should now make sense to you. It's now time to recap the key lessons you learned and the skills that you gained. With that in mind, let's summarize the key points you learned in this module. You should now be able to describe the concept of procedural programming, describe what algorithms are and how they can be used to solve problems, identify how algorithmic complexity is calculated, and recognize how algorithmic complexity can help in improving performance. You should also be able to describe Big O notation, explain what functional programming is, explain how pure functions are used in functional programming, and explain recursion and how it can be used to solve problems. What you have learned, however, did not stop here. You should therefore also be able to use different methods to reverse a string in Python. Explain the difference between the map and filter functions. Explain object-oriented programming and the 4 concepts it is built upon, and describe the relationship between classes and instances in Python. Finally, having studied the remaining key points in this module, you should now be able to create classes, instantiate classes, access their variables and methods, and change the state of instance objects by using instance variables and methods. This module gave a comprehensive introduction to different programming paradigms in Python. This is essential knowledge that prepares you to be able to create even better programming code. Cars are a major part of our lives that make it easier to move around. But if you needed your car to do more, such as handle driving in the snow or carry large objects, well, you'd probably modify it by adding winter tires or hitching a trailer to it. In a similar way, Python is a powerful language that allows developers to build amazing things, but it can gain even more functionality with the use of modules. In this video, you'll learn about modules in Python and why they are used. You'll also explore the different types of modules and be able to explain where they can be found. Now, you may wonder what a Python module is. Imagine that modules work like instructions to make a pie. Instead of trying to figure out what the steps are to create your pie, you follow the instructions. Modules work in the same way. They are building blocks for adding functionality to your code, so you don't need to continually redo everything. A Python module contains statements and definitions. So a file like sample.py can be a module named sample and can be imported. Modules in Python can contain both executable statements and functions. But before you explore how they are used, it's important to understand their value, purpose, and advantages. Modules come from modular programming. This means that the functionality of code is broken down into parts or blocks of code. These parts or blocks have great advantages, which are scope, reusability, and simplicity. Let's delve deeper into these. Everything in Python is an object, so the names that you use for functions, variables, and so on become important. Scoping means that modules create a separate namespace, so two different modules can have functions with the same name. And importing a module makes it a part of the global space in the code being executed. Reusability is the most important advantage of modularity. So when you write a piece of code, modules help you avoid the need to write all the functionalities that you may need. Duplication of code duplicates your efforts, uses more computer memory, and it's less efficient. Let's say, for example, you want to import a math package. You automatically get access to a lot of functionalities, such as factorial, the greatest common divisor, used as GCD, and so on, that are reused without defining them. One other feature that using modules brings is simplicity. When modules have a little dependency on each other, it helps achieve simplicity. So each module is built with a simple purpose in mind. Modules are defined by their usage. So you can also use a regular expression or RE module for managing regular expressions. Simplicity also helps in avoiding interdependency among these modules. So if you're working on data visualization, import of a single module like matplotlib is sufficient for visualizing your data. There are different types of modules that exist in Python. The main difference between these modules is the way the modules are accessed. Let's cover built-in modules. Some modules are already built into the standard Python library. When you use a statement like import math in your Python code, for example, the interpreter first tries to find built-in modules. So, how do you import and execute modules in Python? The first important thing to know is that modules are imported only once during execution. If, for example, you import a module that contains print statements, print, open bracket, close bracket, you can verify it only executes the first time you import the module, even if the module is imported multiple times. Since modules are built to help you, standalone modules hold all the functions, but will most likely not contain functions that execute without calling. It's only when the user executes the different functions inside that module that they will find the utility of those functions in the code. The module is normally defined at the beginning of the code, but you can define it at any point in the code. Since code execution in Python is serial, you must import the module first before you execute any function inside of it. Modules can also be executed from within the function. This means that the code inside that module can only be used once the function is executed. In this video, you covered modules in Python. You learned about the different types of modules and how they can be used to save you time and make your work more efficient. In Python, you can access different types of modules, such as built-in modules and user-defined modules from different locations. Think of the built-in modules as a house that you want to build using pre-built and packaged floors, walls, and a roof that you can just assemble. This means you don't have to try and find hammers, bricks, plaster, and tiles to build walls and floors, saving you time and making your work more efficient. Accessing built-in and user-defined modules in Python works in the same way and helps to save time and build efficiency while you're coding. Remember that any Python file can be a module. The modules are searched by the interpreter in the following sequence. First, the current directory path. Second, the built-in module directory. Third, the Python path. an environment variable with a list of directories. And finally, it investigates the installation-dependent default directory. Let's explore this in greater detail. In this video, I'll demonstrate how to access different types of modules, such as the built-in modules and user-defined modules from different locations. Let's write some code and learn how to access some built-in modules. I begin by creating a new file called myCalendar in Visual Code. I then use the sys.path function and return the values that I get from it in a variable called locations. I finally print the values using the print function. I now try running this code. Unfortunately, this does not work as Python has no idea what sys is. To resolve this, I'm going to try and import the built-in sys function. I'm going to run the code again. The print function returns all the possible locations that the interpreter is going to look for when searching for modules, including the current working directory. But this doesn't look very clean. I know that I have a list of values, so I'll run a for loop that loops through every location in turn. This returns a much cleaner result by printing each location on its own line in the terminal. Now, it's always good practice to import all the required modules right at the beginning, but I can do this in a different way. I'll import a module here in the middle of the code. I'll import another built-in module called calendar. I'll now use a couple of functions that the calendar has. I'll now use a function called leap days, which has two inputs, year 1 and year 2, and it will be returning another integer value. So what I'm going to do is write the leap days function, write 2 input years, and return the value in a variable called leap days. I'm going to print the value of the variable. I get a return value of 13, which means there are 13 leap days in between 2000 and 2050. Now I'll use another function. This function is called isLeap. It takes one of the years as an input and returns a Boolean value. It tells you if a given year is a leap year. So let's try 2036 and return the value in another variable called isItLeap. This time I get the value of true because 2036 is a leap year. If you decide to explore a little bit, you can hover over calendar. If you use a MacBook, press the command key, or if using Windows, press the control key, which will take you to the calendar file by clicking on it. Note how the calendar module itself has imported a few other modules, and other than that, it contains all the functionalities. I now find the location of calendar inside the Python 3.9 package, which is one of the locations listed in the terminal by the print locations loop I ran earlier. You just learned how to access built-in modules and user-defined modules from different locations. I encourage you to start using modules in your code to make your work more efficient.
In this video, you will learn how to use import statements for accessing modules from different directories. You will also learn how to create packages from the Python package index using pip. Every Python file, which means any file with a .py extension containing a script, is effectively a module. The check imports file I am currently creating is therefore a module for some of the files. The code that you are working with is generally called the main module. In this case, check imports is the main module present in the current working directory, also called the scope of the project. You can import any Python file that is present in the current scope. For example, I can import the sample.py file by typing import, followed by the file name without the extension. I then click on Run in the top menu. The system returns a message in the terminal pane that the import was successful. If I try to import a file with a .txt extension, the import will not be successful. For example, if I type import followed by sample text and click on Run, the system will return an error message in the terminal pane as it is not a Python file. Python has a library of standard modules called built-in modules. These modules are directly built into the Python interpreter and don't have to be installed separately. I can import a module like JSON by typing import JSON. Once I execute the command, I can start using its functions directly. The list of built-in modules can be found in the Python standard library. You can think of packages as the structuring of Python modules as a collection. Special files called init.py files are required for Python to treat directories containing the file as packages. Python has a rich collection of community-built packages that I could find on the Python Package Index, or PyPI. pip, or pip3, is the default package installer for Python and helps with the installation of packages from PyPI. Since I have already installed NumPy, I can import it directly in Python. I do this by typing import NumPy, clearing my terminal, and clicking Run. If I try to import a package that is not installed, I will get an error message. For instance, if I type import Seaborn and click Run, the message module not found error is returned. If the package Seaborn were installed, I could run the command again in Python without any error messages. To do this, I would run pip install Seaborn in the terminal to download the package from the PyPI index. I can also import files I have created in one of the folders within the current working directory. I have a folder called Workplace, containing a file called trial.py. The file consists of a list with the variable names and 2 entries inside it. I am going to import this file and access its contents. I start by importing the sys module. Next, I use a path function in sys by typing sys.path.insert. Now, I must enter the path name to my workplace package in the first index location. To do this, right-click on the workplace directory and select Copy Path. I enter this path name as the first index location. When passing the path as an argument, I must use single quotes and type the letter R in front of the path string. The sys.path list now has a new directory where it will look for modules. Now I must import my trial file here by typing import trial and pressing enter. A squiggly line appears below the word trial. This is because the IDE does not know about the path I've added inside sys.path. However, I can still proceed as the interpreter will know about this path. To print the output, I type print followed by trial.names and click the run button to execute. The values of Adrian and Maria from the names list variable are printed. In this video, you learned how modules can be imported from anywhere within your system. Inserting the path name can, however, be very specific and often tricky and confusing. Don't worry about this too much for now. It is more important to focus on importing files from your current directory. It is nice to know that importing modules from other directories is an option if you need it. It is good practice, though, to move the required files into the directory that you are working in. Let's explore how to use modules with the import statement. I have already created a file called imports.py. I will now import the built-in math module by typing import math. Just to make sure that this code works, I'll use a print statement. I do this by typing print, importing the math module. After this, I'll run the code. The print statement has executed. Most of the modules that you will come across, especially the built-in modules, will not have any print statements, and they will simply be loaded by the interpreter. Now that I've imported the math module, I want to use a function inside of it. Let's choose the square root function, sqrt. To do this, I type the words math.sqrt. When I type the word math, followed by the dot, a list of functions appears in a drop-down menu, and you can select sqrt from this list. I pass 9 as the argument to the math.sqrt function, assign this to a variable called root, and then I print it. The number 3, the square root of 9, has been printed to the terminal, which is the correct answer. Instead of importing the entire math module as we did above, there is a better way to handle this, by directly importing the square root function inside the scope of the project. This will prevent overloading the interpreter by importing the entire math module. To do this, I type from math import sqrt. When I run this, it displays an error. Now, I remove the word math from the variable declaration and I run the code again. This time, it works. Next, let's discuss something called an alias, which is an excellent way of importing different modules. Here, I assign an alias called m to the math module. I do this by typing import math as m. Then, I type cosine equals m dot. I then select cos, C-O-S, from the list of functions, after which I add the number 0 in parentheses. On the next line, I'll print cosine and then I run the code. The result is the cosine value of 0, which is 1. This is possible because I used the alias called m. If I tried writing math.cos, it wouldn't work because the math module is now recognized as m instead. Let me remove this code from the screen and clear the terminal before we continue. An alias can also be used for a function that's imported. For example, I can type from math import factorial as f to alias the factorial function. Now I assign f of 10 typed as f opening parenthesis, the number 10, and a closing parenthesis to a variable called factorial 10. I'll print the variable and see if it works. When we run the code, we see that it works just fine. Using an alias in this way reduces the effort of typing factorial every time. After I remove the alias, I can import as many functions as I'd like from a given module. I'm going to import log and sqrt. I create a variable using the log function to find the value of log base 10 of 50. I do this by typing x equals log 10 opening parenthesis 50 and closing parenthesis. And again, I print the variable on the next line. And when I click run, I'll see whether or not it worked. Once again, it worked just fine. Now, what if I want to import all the functions inside a given module? I can remove the functions I added earlier and replace them with a star. This basically translates to import all from the math module. When I run the code again, let's see if it works. And it does. However, this practice of using a star is not the best approach in certain cases. For example, this is a small file, and I know that the log10 function is present inside the math module. But when you work with a large codebase, it can be difficult to track where the log10 function came from. Additionally, when you're importing other modules, it may get confusing. Importing packages is very similar to importing modules in Python. Just like you can have imported functions, you could also import variables and classes from a given module. Now I replace the star with a variable called SOMEVariable, which may be present inside the given module. Let me try to run the code again. Since the math module doesn't have such a variable, it throws an error when I print it. The interpreter is not able to import SOMEVariable from math. In this video, you explored different methods that can be used to import modules in Python using keywords like import from, star, and as. This enables you to use the modular structure of Python in object-oriented programming in general.
Now you should be fairly familiar with how modules work. Let's look at another related concept in Python, namespaces and scopes. The official Python documentation defines namespace as mapping from names to objects, and scope is the textual region of a Python program where the namespace is directly accessible. At this point, the dictionary, with its key value pairs, serves as the ideal data structure for the mapping of names and objects. You have also learned how every Python file can be a module. You can view the same module as a place where Python creates a module object. A module object contains the names of different attributes defined inside it. In this way, modules are a type of namespace. Namespaces and scopes can become very confusing very quickly, and so it is important to get as much practice of scopes as possible to ensure a standard of quality. There are four main types of scopes that can be defined in Python: local, enclosed, global, and built-in. The practice of trying to determine in which scope a certain variable belongs is known as scope resolution. Scope resolution follows what is known commonly as the LEGB rule. Let's explore these. Local. This is where the first search for a variable is in the local scope. Enclosed. This is defined inside an enclosing or nested functions. Global is defined at the uppermost level or simply outside functions. And built-in, which is the keywords present in the built-in module. In simpler terms, a variable declared inside a function is local, and the ones outside the scope of any function generally are global. Here is an example. The output for the code on screen shows the same variable name Greek in different scopes. There are three possible declarations of the variable. At the global level, inside the function b, or inside the nested function c, which is called from within b. The ID function is used here in the print statements, which returns the identity of the objects. You can make some observations from the output. The ID for the global variable alpha remains same as defined after the code is completely executed. The ID for the local variable beta inside the function b remains unchanged before and after the execution of nested function c. The ID for gamma is assigned only within the scope of the nested function, and the ID for all three variables is different even if they all have the same variable name. Variables in Python are implicitly declared when you define them. That means, unlike other programming languages, there is no special declaration made in Python for the variable which specifies its data type. What it also implies is that a given variable is local, not global, when it is declared, unless stated otherwise. This contrasts with most other programming languages where variables are global by default. So, when a variable is declared in a global space, it is also local to that space. This can be understood with a simple example. If you look at the content of both of these dictionaries, you can see how the value for the key country is different in both the cases. You have also used two special built-in functions called locals and globals that list the contents of the dictionary inside both of these scopes. Here you can see the output. In this example, you can see the global variable declared remains unchanged. While global variables are acceptable, they are discouraged for a number of reasons. When you are working with production code, the project structure can get complex, and working with global variables can be hard to diagnose, which lead to what is called the spaghetti code. Other paradigms such as access modifiers, concurrency, and memory allocation are better handled with local variables. While you are just beginning our journey using Python, it is always a good idea to integrate good practices in your code. There are two keywords that can be used to change the scope of the variables: global and non-local. The global keyword helps us access the global variables from within the function. Non-local is a special type of scope defined in Python that is used within the nested functions only in the condition that it has been defined earlier in the enclosed functions. Now you can write a piece of code that will better help you understand the idea of scope for an attribute. You have already created a file called animalfarm.py. You will be defining a function called d, inside which you will be creating another nested function, e. Let's write the rest of the code. You can start by defining a couple of variables, both of which will be called animal. The first one inside the d function and the second one inside the e function. Note how you had to first declare the variable inside the e function as non-local. You will now add a few more print statements for clarification for when you see the output. Finally, you have called the e function here, and you can add one more variable animal outside the d function. This will be a global variable. You can add a call for the d function and a print statement for the global variable. You can save this file and run the code. First, the global animal variable gets assigned camel. Then, call this function, and once inside it, assign elephant to the local animal. Then, declare the inner function e, and proceed by printing before calling functions animal, where the value of animal will be the local value, which is elephant. Once you are inside the inner function e, you use the non-local keyword to declare that you are going to use the animal variable, and you change the value to giraffe, and here you can see that the print statement will give inside nested function. The value is giraffe, which stays consistent even after you get out of the inner function. So when you print, after nested function, the value still remains giraffe. Once the function is fully executed, come out to see that the value of global animal will be camel, which you had assigned at the beginning. So you can see the changes that you have made inside are not going to affect the value of the global variable. Let's look at one last thing. If you comment the local variable out, this will throw an error. You can see there is no binding present for non-local animal present inside the D function, which was required here.
In this video, I'll cover the reload function that's used with import statements. The reload function reloads an imported module in Python. The only precondition is that the argument passed to it must be a module that has already been successfully imported within the program. Previously, you learned how the import statement is only loaded once by the Python interpreter, but the reload function lets you import and reload it multiple times. I'll demonstrate that. First, I create a new file, sample.py, and I add a simple print statement named hello world. Remember that any file in Python can be used as a module. I'm going to use this file inside another new file, and the new file is named using reloads.py. Now I import the sample.py module. I can add the import statement multiple times, but the interpreter only loads it once. If it had been reloaded, we would have seen hello world several times. However, I can change this with the help of the reload function. Let me remove this code and add the import lib module where the reload function sits. Then, I pass the module name as an argument to this function. Note that the sample module has been imported more than once, and I could do it as many times as I want. Now, to better demonstrate how the reload function can be used, I'm creating another file called filechanges.py. This file is going to list the content of a particular directory. In the following code, I will be updating the contents of the directory and be able to monitor the changes using a file that I will import. Since the interpreter loads the file only once, the reload function will allow us to reload that import and effectively update the changes every time without stopping the execution of running code. I begin by importing the built-in OS module, and I use a function called os.listdir inside it. Next, I pass the current path as an argument by right-clicking the Files tab at the top and selecting Copy Path. I paste this as an argument to the listdir function and add an R before the path. Because I'm looking for a directory and not a file, I remove filechanges.py from here. I'll save the output from the listdir function into a variable called contents. On the next line, I'll add a print function for the contents variable. Before running our program, I'll clear the terminal to make things clearer. The return value should list the files that are present in the given directory. You'll notice that it indeed lists all the files present in this directory once printed. I now go back to the reloads.py file and I clear the file. Then, I once again import the import lib module. After this, I import file changes and create a function called changes. As good practice, I add a try block and use the reload function to pass file changes as an argument. Let me go back to the filechanges.py file and create a function that will print the contents variable. This is now complete, but I'll add another print statement for clarity. I save this file and then I go back to using reloads.py. I call this function that I just created inside the file changes module, and because I want to make a try block work, I add the except and just pass for now. After this, I execute the code using a for loop. Because I want to do it more than once, I use the range function and call the function that I just wrote. To take some control of the program, I'll add an input statement here. Now the program will execute 5 times, and every time it will load the file changes module and list the contents of the directory. To make it more interesting, I'm creating a few text files inside the directory. Now I've returned to using the reloads.py file to run this code. Note that the content of the current directory is listed here, but I'll now remove the text file called text3.txt. When I execute the code again by hitting enter, you'll notice that the particular text file has been removed. Now, without changing anything else, I'll execute the rest of the code. If I also change the content of filechanges.py, for example, changing the print statement before the file names, I could see the code reflected after I press enter again. As I demonstrated, the reload function can be used for making dynamic changes within your code with the help of import statements.
Packages are bundled collections of modules in Python serving a specific purpose. In Python, there are currently tens of thousands of packages to choose from, and in this video, you'll learn about some of the most popular. You can think of this collection of packages like a traditional real-world library. Each package is a book or magazine, and this library gets bigger every day. In programming, a package is a directory or folder. And in the same way, a module is a file or document. You import packages in the same way as a module using the import statement. And like with the import statement, it's important to remember that unless defined correctly, the import serves no purpose. For example, suppose you want to import a package named foo. The import statement on its own will not serve any purpose. It needs to be in a format like from foo import a, where foo is the package and a is the module containing the functions you want. Exploring the package's directory structure or referring to code blocks online can save time. To work with packages in Python, it's important to know that pip is the default package manager, and Python Package Index, or PyPI, is the package index where you can find and publish packages. Python has an extensive collection of packages. As a developer starting out, it can be overwhelming, but it's important to understand what Python is most widely used for today. The major application areas for Python are data science, AI and machine learning, web frameworks, application development, automation, and hardware interfacing. With this in mind, packages can be grouped into categories. For example, built-in packages, data science, machine learning and AI, web and GUI development. Let's explore each of these briefly now, starting with built-in packages. These are packages that don't need to be installed separately and can be used as soon as you've installed Python. Almost every project uses one or more of these built-in packages, so it's worth getting to know them well. The most popular ones are OS, sys, CSV, JSON, importlib, re, math, and itertools. In the world of data science, the most popular Python packages are NumPy, SciPy, NLTK, and Pandas. These are all used for data exploration and manipulation. Other packages like OpenCV and matplotlib are used for image processing and data visualization. Within the world of machine learning, or ML, and artificial intelligence, or AI, the most popular packages are TensorFlow, PyTorch, and Keras. PyTorch and Keras are currently the most popular for deep learning and neural network implementation. There are other packages such as SciPy, scikit-learn, and Theano. Choosing which package to use will depend on the scale and scope of the project and how familiar you become with the package in question. Okay, let's move on to web development. Python today is primarily used for ML, AI, and web development. The most popular packages are Flask, which is a lightweight micro framework, and Django, which is a full stack framework. Other popular web development packages include CherryPy, Pyramid, Beautiful Soup, and Selenium. There are also other packages for robotics, game development, and other specialized domains. For any domain you want to work in, you'll find several Python packages relevant to it. While no one package may be a perfect fit for your current project, the open source community of Python developers is working relentlessly to fill the gaps. As a beginner Python coder, most functions you need will be met by one package. To continue expanding your knowledge of Python packages, you should think of a project you'd like to create and experiment with the packages I've mentioned in this video. In this video, you learned about packages in Python. You covered built-in packages and some of the most popular packages in use today. Python is one of the best languages to use for various data science projects and applications. In this video, you'll learn about some of the commonly used Python libraries in data analysis and data science. The last decade has seen exponential growth in all data science areas. The demand for data analysis and scientists is continually increasing, as it's a requirement for developers to incorporate scientific and data analysis into their code. Python has emerged as one of the most popular languages with data scientists. One of the main reasons for its popularity is the large number of different open source packages. These have been developed by thousands of contributors collaborating to provide free, usable resources. Many packages are top-rated because they are efficient and provide outstanding functionality. In no particular order of preference, these packages include NumPy, SciPy, Matplotlib, and scikit-learn. As an example, scikit-learn is used for predictive learning and is built on top of other popular packages. It consists of various supervised and unsupervised machine learning algorithms for classification, regression, and SVMs. Modeling data is the primary focus of this library, and it provides popular models such as clustering, feature extraction and selection, validation, and dimensionality reduction. Pandas is an acronym for Python Data Analysis, and this is a data analysis and manipulation tool. It's used primarily for working with datasets and provides functions for cleaning, analyzing, and manipulating data. Using it, I can compare different columns and find the arithmetic mean, max, and min values. The primary data structures used in Pandas are series and data frames. While series are single-dimensional and can be compared to a column in a table, data frames are multi-dimensional and can potentially store tables efficiently. They are agnostic to the data types being stored. Pandas' most common applications are reading CSV files and JSON objects and using them within Python code for faster retrieval. Pandas are known to bring speed and flexibility to data analysis. Pandas library is normally imported by the code import pandas as PD. NumPy stands for numerical Python and is a powerful library forming the base for libraries such as scikit-learn, scipy, plotly, and matplotlib. Python scientists use the abilities of NumPy especially when working in scientific domains such as signal, image processing, statistical computing, and quantum computing. NumPy carries out the calculations needed for algebraic areas such as Fourier transforms and matrices. The backbone data structure in NumPy is called ND-array or n-dimensional array, which substitutes the conventional use of lists in Python and is a much faster solution than lists. The dimensions in NumPy are called axes, and the number of such axes is called a rank. Conventionally, NumPy is imported with import NumPy as NP. Matplotlib is the visualization library used in Python. It can be used to create static, interactive, and animated visualizations. Many third-party tools such as ggplot and Seaborn extend the functions of matplotlib. These functions are located inside the pyplot subpackage. Matplotlib is imported with import matplotlib.pyplot as PLT. An example such as libraries 2.0 uses the matplotlib and NumPy libraries to, for instance, display a graphical representation of students in a class or the distribution of their scores. To recap what you've learned in this video, you should now know about the most commonly used Python data analysis and data science packages. Artificial intelligence, or AI, is broadly about making machines think like humans. Data science primarily focuses on the management and exploration of data, which may include media such as text, audio, images, and video. Machine learning, or ML, is a subsection of AI and deals with algorithms for training and generating insights from data. Many fields utilize machine learning. Some of the most widely used areas are natural language processing, deep learning, sentiment analysis, recommender engines, computer vision, and speech recognition. With the amount of text, image, and video data available today, data science and AI in particular are in greater demand than ever. Python is one of the most popular languages used in these domains. The reasons are syntactical efficiency and readability, flexibility with different languages, frameworks, and operating systems, a welcoming and large community of developers, ability to build ML models without having to understand the intricacies, user-friendly debug and testing tools, and modular structure. These all promote the development of many primarily open source libraries and frameworks. It's important not to get confused with the terms, packages, library, and frameworks. A package is a collection of modules, and both library and framework are often used interchangeably with packages. Libraries can also be a collection of packages with specific purpose, whereas the term framework is usually used where certain flow and architecture is involved. It's important to remember that all of these pieces of Python code are used with the help of import statements. Some of the most popular ML libraries in use today are in the areas of deep learning and neural networks, computer vision and image recognition, natural language processing, data visualization, and web scraping. It's important to understand that these are broad categorizations. Most of the libraries associated with them are not restricted to a particular field. Every project is unique and should be treated as such. The right selection of the library can save precious time when coding. In this video, you learned about machine learning libraries. Many fields use machine learning, and those fields, like deep learning and neural networks, rely on open source machine learning libraries that make developers work easier. These libraries are collections of packages, and the selection of the right library can save you time when coding. So in the future, think carefully about which library you should pick for a project to make sure that it suits your needs. Web frameworks are software applications designed to provide us with a standard way to build, deploy, and support web applications that we can use on the web. They help developers to focus on application logic and routines by automating redundant tasks, which helps cut development time. They also provide easy structuring and default models that are reliable, stable, and easily maintainable, saving time and effort. Web frameworks are primarily written in high-level code, which removes the overhead required for understanding concepts such as sockets, threading, and protocols. As a result, time is better spent working on application logic instead of routines. Python is a popular framework in web development thanks to several features such as good documentation, abundant libraries and packages, ease of implementation, code reusability, a secure framework, and easy integrations. The different frameworks in Python are efficient and make it easy to handle tasks such as form processing, routing requests, connection with databases, and user authentication. They also provide debugging and testing tools to handle profiling, test coverage, and test automation, etc. There are mainly three types of web frameworks in Python. These are full stack, micro frameworks, and asynchronous. Let's explore each briefly now. Full stack frameworks are considered a one-stop solution and usually include all the required functionalities. This can include form generations and validators, template layouts, HTTP request handling, WSGI interfaces for connection with web servers, and database connection handling. Some of the most popular Python frameworks are Django, Web2Py, and Pyramid. Micro frameworks are a lighter version of full stacks that do not offer as many patterns and functionalities. They are usually used in smaller web projects and building APIs. Flask, Bottle, Dash, and CherryPy are some of the popular micro frameworks. As the name suggests, asynchronous framework types are used to handle a large set of concurrent connections. They are mainly built using async.io networking libraries. Growler, AIO HTTP, and Sanic are some of the names you'll encounter. Choosing a framework can depend on many factors. This can include things like available documentation, scalability, flexibility, and integration. While this categorization is pretty broad, it's important to remember that each framework in Python has its own unique set of features and functionalities. This can make certain frameworks more suitable than others for a specific project. Two of the most widely used are Flask and Django. Let's explore each briefly now. Django is a high-level framework that encourages clean design and rapid development. It's a full-stack framework that's rich in features and libraries. It's secure and has templating systems and third-party support. It primarily gained popularity due to its rapid deployment speed. You can quickly build scalable apps without extensive knowledge of low-level programming. Flask is a micro framework and better used for smaller projects. It's easy to learn, simple to use, and has a large library of add-ons. In this lesson, you learned about web frameworks and the different types. You also learned about the different web frameworks in Python, such as Flask and Django. Testing is an essential component in quality assurance that ensures our software, applications, and websites work as expected. For example, suppose you've built your own website and it has a few hundred visitors every day. One day, an article you've published goes viral. Suddenly, 1 million people are visiting your site and the website crashes. Another scenario is online forms. We've all faced situations where we fill out a form and a prompt appears telling us that we have made a mistake. For example, accidentally entering letters in space provided for credit card numbers or missing special characters in passwords. This type of data validation is even more critical, especially in the domains of banking and finance. In this video, you'll learn about testing and its importance in the software development lifecycle. But what exactly is testing? Well, software testing is a process of evaluating and verifying the various software applications and products in terms of performance, correctness, and completeness. It helps identify bugs, gaps in the product, defects, and missing requirements with set expectations. In the early days of computers, software developers relied heavily on debugging, a process for removing and detecting potential errors. After the 1980s, as software grew in size, several different testing types and products also grew in parallel, depending on the requirements. Testing was primarily done in the later stages of the software lifecycle. Now it's evolved to be integrated at the early stages as well. The efficiency of any testing type is dependent on how well written it is. The ideal testing scenario is to have the least tests written to find the largest number of defects. While software testing is important in any scenario, the real test of the product comes when it's launched to market. There, it's judged by stakeholders and users. We live in the internet age. Products with bugs, especially in the early stages, make consumers lose interest very quickly as many alternatives are available. This is where testing plays an important role, and here are a few reasons why it can help. Testing helps detect poor designs, change inefficient flow or functionality, address scalability concerns, and find security vulnerabilities. Testing helps provide A/B testing to find the best suitable options, address compatibility with platforms and devices, provide assurance to stakeholders, and a better experience for end users. There are a few good practices that must be followed in testing to achieve optimal results. Test code allowing reusability of tests. Tests must be traceable to the requirements set. Tests written must be purpose-driven, efficient, and allow for repeatability. These testing techniques can then follow a procedural approach according to the type of testing used. The testing lifecycle in general can be broadly described as planning, preparation, execution, and reporting. The steps involved in achieving this can include writing scripts and test cases, compiling test results, correcting defects based on them, and generating reports from our test results. Okay, so you've already learned about test cases. They are a general set of actions containing steps, data, pre and post conditions written for a specific purpose. This purpose can improve functionality, flow, and finding defects. A well-written test case eventually provides good coverage, reusability, better user experience, reduces costs, and increases overall satisfaction. As the tech industry is ever growing, several testing categories, types, tools, and products have evolved, which are tailored to best meet the requirements of the software in question. For example, a web page will have different testing needs than an Android-based game. Even among web pages, a social media page will differ from one, say, from financial management. Testing can be categorized by several different factors. For example, depending on the amount we know about the internal implementation, we can call it black box or white box testing. There are also many testing types used in practice. These include compatibility, ad hoc, usability, and regression testing. Don't worry too much about these terms for the moment. You'll learn more about them later. For now, I just want you to know that with testing, there is no one-size-fits-all solution. When testing products, it's also important to understand when to stop, as no application will ever be 100% perfect. Otherwise, a developer may feel the product is well tested, but realize it's full of bugs and flaws as soon as it's released to the end users. A few metrics can be established for this purpose, given that there are well-written test cases in place. These include a certain number of test cycles, passing percentage of test cases, time deadlines, and time intervals between subsequent test failures. Testing in software development can be seen as the anchor of a ship or insurance for your vehicle. You can hope that everything operates smoothly, but often it does not. And while you can aim for perfection, there is always potential for human error. Quality assurance today has become an important component in the software development life cycles. Much of the credit goes to development of testing tools and techniques. The question is, what type of testing should you use? In this video, you'll learn about the types of testing, including the 4 main levels or categories of testing, which is unit, integration, system, and acceptance testing. There are different ways in which you can categorize the different test types. There are white box and black box tests. White box testing is where the tester has knowledge of the code, design, and functionalities. Black box tests function with no such information, and the tester has no idea about the internal implementation. There are also other ways to categorize different tests as functional, non-functional, and maintenance tests. Let's explore these. Functional tests are based on the business requirements stated. They determine if the features and functionalities are in line with the expectations. Non-functional tests are more complex to define and involve metrics such as overall performance and quality of the product. Maintenance tests occur when the system and its operational environment is corrected, changed, or extended. But there are also manual and automated testing methods that are dependent on the scale of the software. The most broadly accepted categorization is in terms of the levels of testing as you move ahead in the software lifecycle. Let's delve deeper into these levels of testing. The 4 main levels of testing are unit or component testing, integration testing, system testing, and acceptance testing. The 4 types of testing levels build on each other and have a sequential flow. Let's explore these now. In unit or component testing, the program tests specific individual components by isolating them. The components are low level, which means that they are closer to the actual written code. They often involve use of automation for continuous integration given their small sizes. So you usually write these tests while writing the code. For example, if the code is in Python, unit tests can be written with packages such as PyTest. Integration testing combines the unit tests and tests the flow of data from one component to another. The keyword here is an interface. This means that you test if the data is correctly fetched from a database within the Python code and if you have sent it to the web page. There are different approaches to it, such as top-down, bottom-up, and sandwich approaches. Your approach depends on what code level interfaces you attempt first. It builds on the unit testing and a tester deals with it. Next is system testing, which tests all the software. You test it against the set requirements and expectations to ensure completeness. This includes measurements of the location of deployed components, such as reliability, performance, security, and load balancing. It also measures operability in the working environment, such as the platform and the operating system. This is the most important stage handled by a team of testers. It's also the most critical stage, as the shipping of software to the stakeholders and end user happens after this phase. The final type of testing is acceptance testing. When the product arrives at this stage, it's generally considered to be ready for deployment. It's expected to be bug-free and meet the set standards. The stakeholders and a select few end users are involved in acceptance testing. It normally involves alpha, beta, and regression testing. One way of approaching this is to give pre-written scenarios to the users. You use the results for improvements and try to find bugs that were missed earlier. All the different testing levels are designed to optimize software at different stages. The key to testing is testing early and testing frequently. While each of the testing phases is important, early detection saves time, effort, and money. As the code gets increasingly complex, mistakes become harder to fix. It doesn't necessarily mean that unit testing will happen only at the beginning and acceptance at a later stage. There are many testing cycles where these levels are approached iteratively. A typical example is the Agile model. Here you release different versions of the product iteratively and you perform acceptance testing every few weeks. In this video, you learned about some of the types of testing such as unit testing, integration testing, system testing, and acceptance testing. It's important to remember that the purpose of these testing methods is to build a systematic approach for testing and identify faults and improvements as early as possible. This results in improved overall performance and experience. Well done. With advancements in technology, an increasing drive is towards code automation. In this video, you'll learn about test automation packages and the importance of automated testing. In the past, machines have substituted human effort in making goods, which helps us save both time and effort. In programming, the tests chosen for automation are the ones that have high repeatability and volume, predictable environment and data, and determinant outcomes. There are a number of testing types that can be automated. These include unit, regression, and integration. An ideal test code must form a bridge between the programming calls and the test cases. Python does a fine job in achieving this in addition to its clean, concise way of coding. There are some well-written frameworks in Python, and some are more well accepted than others. The ideal steps involved in test automation are usually preparing the test environment, running the test scripts, and analyzing the results. Okay, let's now examine some important Python testing frameworks that have grown in popularity over the years. First, let's explore the built-in testing package, PyUnit or Unitest. The Unitest framework supports test automation, independent testing modules, and aggregation of tests into collections. The first is PyTest, a native Python library that is simple, easy to use, and reasonably scalable. PyTest will be demonstrated later in this course. It can handle several functional test types such as unit, integration, and end-to-end. There is support for parameterized testing, which enables us to execute unit tests multiple times with different parameters passed. It can run parallel tests and generate HTML, XML, or plain text reports. You can also integrate it with other frameworks like PyUnit and Nose2 and web frameworks like Flask and Django. While primarily used with testing APIs, it's also well used with UI, database connections, and other web applications. Easy creation and quick bug fixes are why PyTest is the most popular testing framework for automation. Next is Robot, which is popular primarily for its keyword-driven development capabilities. These keywords are used in test cases and can be predefined or user-defined. Robot is very versatile and used for acceptance testing, robotic process automation or RPA, and test-driven development. It can be used for many domains including Android, APIs, and mainframes. Selenium is another open source testing framework that has gained popularity over time and is primarily driven towards web applications. It has support for the majority of web browsers and OS. There are browser-specific web drivers that enable testing functionalities like login, button clicks, and filling of forms. It allows the tester to select the speed and execution of tests and has an option to run specific tests or test suites. Apart from the popular frameworks PyTest, Robot, and Selenium, there are many more. It's important to know that a number of these testing frameworks are often used with other tools such as plugins, widgets, extensions, test runners, and drivers. These tools help integrate the software pieces being tested and add functionality. Sometimes more than one framework is employed over the code being tested. In this video, you learned about test automation packages. Let's recap quickly. Automation testing is an important reason why the software industry is able to move ahead swiftly and more smoothly. Manual testing provides focused attention and the ability to handle nuances and complex problems with more sophistication. This kind of testing can't be replaced by automated tests yet. It's still some time before test scenarios can be fully automated, but the developments of all these frameworks are in line with that endeavor.
In this video, I will demonstrate how to use PyTest to create simple tests for unit testing. PyTest is one of the most popular modules for unit testing in Python. This is because it allows you to do simple tests with minimal effort. And it also has simple, clean code with good documentation. First, I create a file called addition.py. Next, I add a function and pass two variables, a and b, inside it. I'm just going to do a simple calculation that will return the sum of these two variables. Similarly, I create another function called sub, which will perform the subtraction between the two variables. Second, I create another file called testaddition.py, in which I'm going to write my test cases. Now, I import the file that consists of the functions that need to be tested. Next, I'll also import the PyTest module. After that, I define a couple of test cases with the addition and subtraction functions. Each test case should be named test underscore, then the name of the function to be tested. In our case, we'll have test underscore add and test underscore sub. I'll use the assert keyword inside these functions because tests primarily rely on this keyword. It checks for conditions in your code and expects a Boolean value of true or false. When the return value is true, the test passes. When it is false, the test fails. Let's add assert statements to our tests. In our first test, we'll assert that the addition of 4 and 5 is 9. And in the second test, we'll assert that the subtraction of 4 and 5 is -1. Next, I make a split screen so that I could see both files. Now, I run PyTest, and I specify the file over which I'm going to do the testing. To do this, open a new terminal and enter Python -m pytest and the name of the test file, testaddition.py. I ran the code and both tests passed. This means that both the assert statements have been confirmed to be true. 4 plus 5 is 9, and 4 minus 5 is -1. These two dots after testaddition.py in the terminal also indicate that both tests passed. Now, I will intentionally make one of these tests fail. I do this by changing the -1 answer to -2. I make sure that I have saved the file, clear my terminal, and I'll run the test again. Note that the first test passed, but the second one didn't. Also note that where there were previously 2 dots, there is now only 1 dot and an F to indicate that the second test failed. The E's at the start of the lines show where the test failed, and it supplies the possible reason as to why it failed. I could also write these tests without the assert statement and just add pass. This passes the test regardless of any errors. When I run the code again, it indicates that both tests passed. You should note that I used an equality operator here, but I could have used less than, greater than, or keywords such as is, in, or not in. All that matters is that the assert statement gets a Boolean value. I can also add multiple assert statements in a single function. So, if I write assert true, that should return the result. And when I run the code again, it passes both tests. But if I make it false, it will show that one test has failed. This indicates that all the assert statements within a given function should return a true value for the test to pass. Note that using the test underscore prefix for both the file name as well as the function name is good practice. Now I'll restore my code and save the file. If I want to run my test over a specific function, I just add a double colon at the end of the file name, and then I write the function name. I'll clear my terminal first, then run my code. Note that only the function I specified has run. Congratulations! You now know about simple functions. In this video, you learned that you could use PyTest to implement unit testing and how to create and use simple tests for unit testing.
Testing has been a relatively recent entry in the software development lifecycle, but its importance has been growing as time passes. Software development is time sensitive, and in the process, developers often find testing gets squeezed into the time remaining after the code is written. This doesn't leave enough time to test and can lead to the software containing bugs that need to be dealt with over time. Test-driven development, or TDD, is an alternative programming practice in which the tests are written first and the code is written so that the tests will pass. This differs from the convention of first writing the code and testing the application progressively. TDD follows an iterative approach beginning with writing the test cases. The initial work requires feature and test planning by the team. With slight variations, let's explore the standard steps. Step 1. You write a test for a feature that fails. In Step 2, you write code in accordance with the tests. Step 3 requires that you run the test expecting them to fail. In Step 4, you evaluate the error and refactor the code as needed. And finally, in Step 5, you rerun the process. This process is also called the red-green refactor cycle. Red implies the failed tests, and green shows the passing tests after refactoring. The whole point of following this cycle is to fail the tests and rewrite until you don't have to. A feature is complete when everything is green and you no longer need to rerun. You can use a package library such as PyTest when automation becomes a priority. PyTest only requires writing functions, while Unitest requires classes. This means that PyTest has the advantage of being easier because it requires less effort. Okay, now let's explore some of the advantages you gain from TDD. Writing tests first and refactoring code based on it ensures the tests cover the code. You can now write tests with a specific feature and outcome in mind. The need for such forecasting provides clarity from the beginning. The forecasting also plays a role in integrating different components where you add new features and interfaces in accordance with the components that are already there. Working in cycles over the code gives the developer confidence to easily refactor in terms of additional changes. Overall, smaller code with early bug fixes, code extensibility, and eventual ease of debugging are the primary reasons TDD is growing in acceptance. Finally, let's briefly explore some of the differences between TDD and traditional testing. The main difference is that with TDD, the requirements and standards are highlighted from the beginning, making it purposeful. Modern-day development often employs a combination of both these forms of testing, depending on the different parts and stages of the software development cycle. There are several subtypes and variations of test-driven development. These include behavior-driven, acceptance test-driven, scaling, and developer test-driven development. These are all options that can be used in the software development process. Congratulations! In this video, you learned about the process of test-driven development. In this video, you'll learn about how to apply the test-driven development methodology. In conventional testing, you follow the process of writing code and then writing test cases to ensure the integrity of that code. In test-driven development, or TDD, the approach is the other way around, and test cases are where you must begin your thinking. The steps involved are as follows. Write test cases with some functionality in mind. Write code in accordance with the test cases, ensuring that they pass, and refactor code in case the tests fail. Let me demonstrate an example to design a test case that checks student enrollment with data stored in a database. The test needs to check the integrity of the names entered. First, I'll demonstrate how to design the test case and then write some code. Let's say I'm checking student enrollment for a class exam against a list of names that I already have. To keep things straightforward, I'm going to use a Python list with the names instead of a database. I want to make sure that the names I enter are on the list. And I also want to ensure data integrity, which means that I must be sure that the names are entered in the correct format. I've created two files. The first is test_findString, which is my testing file. And the second, findString, is my main file. I already have the PyTest package installed. And because this is test-driven development, I'll write my test function first. I begin by importing a curses module that will help me check the ASCII characters that are present. Then I import the PyTest module, as well as the findString module, which is my main file. I define a function named test_isPresent, and I add an assert statement to check if the isPresent function works, because I'm going to use it to validate my data entry. Contrary to the conventional approach of writing code, I first write test_findString.py, and then I add the test function named test_isPresent. In accordance with the tests, I create another file named filestring.py, in which I'll write the isPresent function. I define the function named isPresent, and I pass an argument called person in it. Then I make a list of names written as values. After that, I create a simple if-else condition to check if the passed argument is present inside the list. So the function called isPresent will check if the name passed is present in the list. Let me test my code. Note that the test has passed because the name Al is in the list. But this doesn't ensure the integrity of entries I may add. For example, I might not want numeric characters in the names. To address this issue, I write another function named test_noDigit. I'm going to update some of the code in my main program findstring.py in accordance with the newly added test. To do this, I create a function called noDigit that matches my test. And again, I create a simple if-else condition. I run the code and you'll note that one of the tests have passed and the other one has failed. So the name Al passed because it's on the list of names, but the value of N7 didn't pass because it contains a numeric character. I could also add more test cases and modify my code so that it's suitable for the test cases, and I can repeat the cycle until I have no more failed tests. Congratulations, you've now explored the test-driven development methodology. You've reached the end of this module on Python modules, packages, libraries, and tools. Great work. During this module, you learned that Python is a powerful language that allows you to build amazing things. But it can gain even more functionality with the use of modules, libraries, and tools. You may remember that we started with modules and learned that they are the building blocks for adding functionality to your code, so you don't need to continually redo everything. Next, we explored some of the commonly used Python libraries in data analysis and data science. And lastly, you discovered that testing as a tool is an essential component in quality assurance that ensures your software, applications, and websites work as expected. It's now time to recap the key lessons you learned and the skills that you gained. With that in mind, let's summarize the key points you learned in this module. You should now be able to explain what modules are in Python and why they are used. Identify the different types of modules and explain where they can be found. Explain how to access built-in and user-defined modules from different locations, and use import statements to access modules from different directories. You should also be able to create packages from the Python package index using pip, write modules using import statements, and explain and use the reload function in Python. You have now learned that Python has an extensive collection of packages and should be able to describe typical module use cases, differentiate between built-in and user-defined Python packages, list some popular Python packages, and list some common Python libraries used in data analysis and data science. In the module, you also learned about libraries, frameworks, and testing. You should therefore also be able to recognize popular Python libraries used in machine learning and artificial intelligence, explain big data and analysis with Python, define Python web frameworks, and list different types of web frameworks, describe testing and explain the different types of testing, list 4 main levels or categories of testing, describe testing packages in Python such as PyTest, Selenium, Robot, and explore the importance of automated testing. And you should now be able to explain test-driven development, TDD methodology, and list the features of test-driven development. This module was an introduction to Python modules, libraries, and tools. This knowledge enables you to extend the ability of your programming code. In this course, you were introduced to the foundations of Python development. Let's do a brief recap of what you covered. Module 1 was getting started with Python. In this first module, you learned about the different ways developers used Python in the real world and discovered the rationale for the existence of Python. You checked out your hardware and software by running Visual Studio Code and carrying out operating system environmental checks, identifying any required dependencies. You explored variables and data types and worked with strings, casting, and data files. This led you to the section on control flow and conditionals, where you got to use Python operators and build looping and flow controls into your code. In Module 2, you moved on to some core programming skills with Python, including exploring functions and data structures, scopes, lists, tuples, sets and dictionaries, and quargs. With all that coding built, it was time to check for errors. You finished Module 2 by examining errors, exceptions, and file handling and considering approaches to error handling. Nearly halfway through the course on Module 3, you discovered all about the paradigms of functional and object-oriented programming and associated logical concepts. You also had an introduction to algorithms and to Python classes and instances. Nearly at the course end in Module 4, you learned how you could boost your coding environment by using modules, libraries, and tools in Python. You also learned about the different types of testing and how to write a test. Well done on completing this course recap. It's almost time to put your knowledge to the test in the graded assessment. Are you ready to display all your Python abilities? Congratulations on completing the Programming in Python course. You've worked hard to get here and acquired a lot of important skills during the course. You should now have a great foundation of back-end web development skills. This is the base for you to continue building on in the future. And you've also demonstrated your skill set in the graded assessment. Following completion of this first course, you should now be able to complete basic programming with Python, distinguish between the programming paradigms of procedural, functional, and object-oriented programming, demonstrate how to use modules, packages, and libraries, and work within a test-driven development environment. So, what are the next steps? Well, this is one course in the Backend Developer Professional Certificate. While you've established a good foundation so far, there's still more for you to learn. So if you've enjoyed this course and want to discover more, why not enroll in the other courses? Throughout each of these courses, you'll continue to develop your skill set. Whether you're just starting out as a technical professional or student, this project will equip you with the knowledge of back-end development practices as used in many business areas, such as web development, artificial intelligence, machine learning, data analytics, and many other applications. You'll have written a portfolio of Python code that will demonstrate your skills to potential employers. This shows employees that you are self-driven and innovative. It also speaks volumes about you as an individual and your drive to continue your growth. Once you've completed all the courses in this certificate, you'll receive a Coursera certification for backend developer. These certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Congratulations once again on reaching the end of this course. It's been a pleasure to embark on this voyage of discovery with you. Best of luck and do continue to follow your learning journey.